Welcome back. Now it's time to finally build our first project with a visual user interface. And actually, we'll build not one, but 3 beautiful projects in this section so that you can learn the basics of so-called DOM manipulation. So, up until this point, we have only learned about the language itself. But now we will take it to the next level and actually make JavaScript interact with real web pages. So, for the first time now, we will finally see a real project come to life, and so that's gonna be a lot of fun and really exciting. Welcome to the first of 3 wonderful projects that we're gonna build in this section. And let's get started right away. And here I have a working demo of the project that we're gonna build over the next couple of videos. And this project is called Guess My Number, and I went with this kind of retro design, like inspired by the old 80s game, just to make it a bit more fun. So as the name says, the goal of this project is to simply guess a secret number, which is between 1 and 20. So here in this input, we can type a number, let's say 10, then we click check, and then here on the right side we get a message. In this case it says that our guess was too low. Also we can see that we started with a score of 20, and now after one failed guess it decreased to 19. So basically after each guess that we fail, the score decreases by 1. So let's try another one. It's still too low, and our score decreased again. Let's try 18. And now it's too high, so we get this different message. And now it's correct. So you see that we get this correct number message, the screen turns green, and also we now have the high score here of 17. So a high score is another feature of this small application. Then, if we want to play again, we can simply click the Again button, and it all resets everything except for the high score. So the high score is kept, and so if I'm quicker in this round, my high score will then become better. Let's start again at 10. So maybe I can do it faster. Well, I think I cannot. It's too high. And so my high score stays the same as it was before. Okay, so with this, I think you understood how this project works. So let's actually get to work. And as always, grab your starter files from the GitHub repository. I already have mine here. And then let's open up this folder. So that's this one. And let's start by taking a look at the files that we have here. First up, we have the prettier configuration. So exactly the one that we used in the editor setup section. And from now on, we will always use this configuration in every single project. Then we have an empty script. We have the CSS style, which you can take a look at if you're interested, and the same for the HTML. Now the HTML will actually be important because that's where we will find the class names of all of these elements that we're going to have to select to make this project work. But more about that later. And yeah, let's close up this sidebar and focus on our script here. So as you just saw, all of this interface here basically is implemented in HTML. So again, that is this document. Okay, and this whole HTML document is made up of smaller HTML elements. For example, this message that we see here is in our HTML, this paragraph here with the message class. And so now in JavaScript, we can actually select this element based on this class. So a little bit like we can select elements in CSS, we can do the same in JavaScript. And if you're not at all familiar with HTML and CSS, then please watch the HTML and CSS crash course that is in the previous section. Anyway, before we learn what the DOM and DOM manipulation actually are, Let's quickly learn an easy way of selecting an element like this in JavaScript. And this is how it works. We write document.querySelector. So this query selector is basically a method that's available on the document object. And more about that later. Now into this method, we need to pass in a selector. And again, this selector is exactly the same selector that we would use in CSS. So we pass in a string, and we want to select the element with the class name of message. And so we need to write a dot and then message. Again, this is exactly how we would select the same element using CSS, right? Now, if it was an ID instead of a class, we would use the hash, right? But in this case, it is really a class, and so let's use the dot. And now we can quickly take a look at the result of this selection here using the console. And remember that we set up the CL snippet in the editor setup section. So I just write CL, and then I get console.log automatically here. Now, in case you skipped that section, you can always go back and see how I did that, or you can just write a console.log manually. So I give it a save, and now I do another thing that we learned in the editor setup section, which is to open up this project using the live server, right? So let's open up the terminal here by clicking New Terminal. Okay, let's clear it using Command K. And again, we learned how to do all of this in the editor setup section. So if you skip that, then please go back and watch that one first. Anyway, we see that we're already in the folder. So guess my number, that's exactly the folder. And now all we need to do is to type live server, hit enter, and then it will open up a new tab in our browser. So this is the demo here that I'm going to keep on the right side, and then here on the left side is the actual project that we are building. Of course, nothing works yet, but let's just open up the console. So inspect console, give it some more space. And so indeed, we actually already have the P element here selected. So that's what we did here. So document.querySelector message. And so in the console, we then get basically this entire element. And as we hover over it, it actually even gets selected here on the page. Great. So this is the first basically DOM manipulation that you did. Great job. Now this element here itself is not really that useful. So instead, let's actually get this text. So this start guessing here. And we can do that simple enough. All we have to do is another dot and then text content. So this part here first selects the element. And so the result of this query selector method is going to be an element. And then on that element, we can read the text content property. And so that's why we use another dot here. And remember, when we have multiple dot operators, they are executed from left to right. And so first this operation here is done, then this selected here basically will get replaced with the element itself. And then on that element, we can read the text content property using another dot. So let's give it a save. This will then reload automatically. And yes, now we get start guessing, which is really just the text content of this element. Great. So now we kind of know how to establish this connection between our code and the user interface. So in other words, the HTML document that's being displayed in the browser. So this was a quick introduction to the DOM and how to select an element. But what is the DOM actually? And what is DOM manipulation, which is the big topic of this section? Well, let's find out in the next video. So in this section, we're going to make JavaScript interact with a web page for the very first time. And the technical term for that is doing DOM manipulation. Now, in the last lecture, you already selected an element from a page. And what that means is that you kind of interacted with the DOM already. So in this lecture, let's learn what the DOM actually is and how it works. So what is the DOM actually? Well, DOM stands for Document Object Model, and it is basically a structured representation of HTML documents. The DOM allows us to use JavaScript to access HTML elements and styles in order to manipulate them. For example, we will be able to change text, to change HTML attributes, and also to change CSS styles from our JavaScript. So we can say that the DOM is basically a connection point between HTML documents and JavaScript code. Now, the DOM is automatically created by the browser as soon as the HTML page loads, and it's stored in a tree structure like this one. In this tree, each HTML element is one object. And so let's now take a look at this DOM structure in a little bit more detail. And to illustrate this, here is a very simple HTML document, and here is what the DOM tree corresponding to this HTML looks like. So, as I already mentioned, this is a tree structure, which looks a bit like a family tree, right? And actually, we use the terms child element, parent element, sibling element, and so on when we talk about the DOM tree and DOM manipulation. Anyway, as you can see, for each element in the HTML, there is one element node in the DOM tree, and we can access and interact with each of these nodes using JavaScript. Okay, so the DOM always starts with the document object right at the very top. And document is a special object that we have access to in JavaScript. And this object serves as an entry point into the DOM. Remember how you used document.querySelector in the last lecture to select an element? So that means that the querySelector method is available on the document object. And so that's why we say that document is the entry point to the DOM, because we need it to start selecting elements. Alright, then the first child element of document is usually the HTML element, because that's usually the root element in all HTML documents. Next, HTML usually has two child elements, head and body. And so of course, you can also find them here in the DOM tree. In the HTML, they are adjacent elements, and so they are siblings in our DOM as well. Then, as we keep going deeper into the nested HTML structure, we keep adding more and more children to the DOM tree. So inside head and body, you have more child elements, and the two sections in the body even have child elements themselves. And from there, it goes even deeper, because the first paragraph also has a child, which is this link element here. And with that, finally, we have all our HTML elements in the DOM tree. But the DOM tree actually has more than just element nodes. It also has nodes for all the text itself, comments, and other stuff. Because basically, the rule is that whatever is in the HTML document also has to be in the DOM. And so, as you see, the DOM really is a complete representation of the HTML document, so that we can manipulate it in complex ways. And with this, you should now have a good overview of how the DOM works and what it looks like. But before we finish, I need to clarify something that many beginners find confusing. So, many people believe that the DOM and all the methods and properties that we can use to manipulate the DOM, such as document.querySelector and lots of other stuff, are actually part of JavaScript. However, this is not the case. Remember that JavaScript is actually just a dialect of the ECMAScript specification, and all this DOM-related stuff is simply not in there. So up until this point, we have only used the JavaScript language itself. But starting in this section, we will also use JavaScript in the browser. I mean, sure, we have used Google Chrome to run our code in the developer console, but that's not what I mean here. What I mean is to manipulate web pages that are actually displayed and rendered in the browser, just like any normal website that you know. Okay, but now you might ask, if the DOM is not a part of the JavaScript language, then how does this all work? Well, the DOM and DOM methods are actually part of something called the web APIs. So the web APIs are like libraries that browsers implement and that we can access from our JavaScript code. And API stands for Application Programming Interface, but more about that later. For now, what you need to know is that web APIs are basically libraries that are also written in JavaScript and that are automatically available for us to use. So all this happens behind the scenes. We don't have to import or do anything, okay? And there is actually an official DOM specification that browsers implement, which is the reason why DOM manipulation works the same in all browsers. Now, besides the DOM, there are actually a ton more web APIs, such as timers, the fetch API, and many more. Again, we will learn a lot more about this later on. For now, let's finally start our project and do some DOM manipulation in practice. Now that we have a better understanding of what DOM and DOM manipulation are, let's now actually select and manipulate some more elements. So in the previous lecture, we already selected this message element here by using query selector, right? Then we also got the text content from the selected element. But besides getting the text content, we can also set the content of the element. So let's do that. So instead of start guessing, let's say like correct number. So that's actually going to be like the winning phrase. So again, we select the element. So query selector. And the same selector. So again, the element with the class of message. And then again, text content. So that's exactly the same as here. Okay. Now here, we actually then logged the result to the console so that we could see it. But here, we will actually set this content to something else. And we do that by writing equal and then whatever we want the new content to be. So let's say correct number. And I'm also going to add here the party emoji. But again, you don't need to do that. It's just to improve the design of the app a little bit, basically. And so now if I save this, it should immediately change this text content here. So watch as I save now. And nothing happened, but that's because I'm here on the demo version. So I need the real one. And so here you see now correct number. Great, so that worked. And down here we still have to start guessing because that's what the content of the element used to be before. So in this line we started by reading the content of the element. And so at the beginning it was still start guessing because that's what is written here in the HTML element in the beginning, right? Then in the next line we changed it. And now if we would attempt to read it again, it should then be this new content that we said before. So let's copy and paste this line here really quick, give it a save. And so now you see that, of course, after changing the text content, when we then read it, it will be this new content. So exactly what we have now here. Okay, that makes sense. And so what we did here is really already DOM manipulation. Because in fact, here we manipulated the text content of one of the DOM nodes. So essentially this element here. So let's now do the same with this secret number and also the score. So both of these values are basically stored in an element. So let's take a look at the HTML. And so this is what I was telling you in the beginning, that we would need this HTML to basically get the class names of all the elements that we are interested in. So this secret number here, so this here is basically this div element here with the class number. And then the score, as you see here down here from this 20, this is where this 20 is. And in this case, it is this span element with the class score. So now let's go ahead and select the elements with the class number and score. Okay, so that's exactly what we did before. So query selector with the class number. And just to experiment some more with this, let's actually set it to something. Let's say 13. And then document dot query selector dot score. And by the way, there are also other ways of selecting elements, but we will talk about them in one of the next projects. And let's set this element also to another value. Oh, and actually I'm forgetting the text content here. So we cannot set the entire element because the element has way more than just the content. So I really have to say that the text content should be 13. So text content. And now as I reload this, this should be 13 and this 20. Let's actually set this to another number. Otherwise we wouldn't see it changing. And indeed, we get 13 and 10 now. Great, that's amazing. So doing some great DOM manipulation here. And now let's move on and do the same actually with this input field. So an input field, as the name says, is where we can input some data. And so actually we can also get the data from here, and we can of course also set it. So let's just see how that works, and it's very similar. So as always, we start by selecting the element. And now we need to get the class name of this element. And so that is, it's right here. So it has the class of guess. And as I said, it's an input element. So again, dot, which is the class selector, and then the name of the class, which is guess. And here we got this error because the query selector method expects at least one argument. And as we went to the HTML file, it then saved this JavaScript file, but we didn't have any string here, so any parameter yet. So that's why we got that error. And now if we want to get the value, which right now is actually empty, but if we want to get that, now this time we read the value property. And so let's log that to the console actually. So again, using the CL snippet. And if we reload this now, yeah, we just get this like empty value here because there is really nothing in there. Okay, but the big difference is that with an input field, to get the actual value, we use the value property. And we can of course also use it to set a value. So to manipulate this element. So dot value equals 23. Give it a save. And now we see 23 here. So as if we had written it ourselves. So we can delete it here just like any input field. But instead of us writing the number, it was JavaScript who wrote the 23 here for us simply by executing this code here. And to make this line of work here actually and to make this line of code here actually work, we can move it below the one where we're setting the value. So in VS Code, let's use Alt and the down arrow to move this line down. And then we should expect to see 23 here in the console instead of this empty line. And indeed, now we first write 23 here to this input field, and then afterwards we read it, and then the value is indeed 23. Great. But now what if we actually wanted to get this number here, for example, to log it to the console whenever we clicked on this button? Well, that's taking it to a whole new level. And so handling the click of a button is what we're going to learn in the next video. See you there soon. Let's now make our application actually do something when we click on the check button. So this is going to be the first time that our code reacts to something that happens in the DOM. And for that, we need to use an event listener. Now, an event is something that happens on the page. For example, a mouse click, or a mouse moving, or a key press, or many other events. Then, with an event listener, we can wait for a certain event to happen and then react to it. So let's try it out now. And let's actually start by getting rid of this code, because this has actually nothing yet to do with the application. But now we will actually start developing the application step by step. Anyway, in order to listen for events, we first need to select the element where the event should happen. And in this case, we want to listen to the event on this button element here. So this check button, because this is where the click that we're interested in will happen. So when we click on this button, something should happen. So let's select that button element. So query selector. And then once more, we need to go ahead and grab the class name of this button. And so here it is. Now here we actually have two class names. We have button and check, but the button class here is the more generic one, which also applies to this other button, this again button here. So the class that we are interested in is just the check class. So again, the dot for the class selector and then check. And so this will select the button element itself. So just as before, this here will then return an element. And now on that element, we can call the addEventListener method. So add event listener. And this is a method. And so we need to call it once more using the parentheses. Now, there are actually multiple ways to listen for events in JavaScript, but using this addEventListener method is the best one and also the most used one. Okay, now into this addEventListener method, we first need to pass in the type of the event. And in this case, it's just a simple click. So the name of the event is actually click. And so that is the first argument that we pass here into this function. But now we actually need to tell the event listener what to do. So basically, we need to specify the reaction to the click event. And we do that by defining a function. And that function will contain exactly the code that should be executed whenever this click event happens on this check button. And that function is going to be called the event handler. Now, this method, this addEventListener method here, is a special kind of function. That's because as a second argument, it expects this event handler function that we just talked about. So again, here as a second argument, we now need to pass in a function value as an argument. And that's probably quite confusing, I know, but that's no problem at this point. This will make more sense as we do this over and over again. For now, just remember what you learned in the fundamentals section, which is that a function is also just a value. And if a function is just a value, then we can also pass it into another function as an argument, just like any other value, like a string or a number. So let's create that function here. And just like before, we do that writing function, and then the curly braces for the function body. Okay, and now all we have to do is to specify what should happen. And to start, what we want to happen is to simply log to the console the value that is here in this input field. So console.log document.querySelector, and actually we already have this code up there, but let's just write it again. So remember that this element here has the class guess, and then from this element we take the value. Okay, and that's it. So let's save it, let's test it, and then we will just go over this again. So I will write 9, and now when I click this button, this 9 should appear down here in the console. And it does. Okay, great. Great job. So let's quickly go over this again. So we selected this button here using query selector, and then we used the add event listener method on that element to attach an event handler. And that event handler is this function here. Okay, so this is again just a function expression. So it's similar to when we do just, for example, this, and then just log something to the console. So this is also just a function value, right? And then we can assign that to a variable, and then we call all of this a function expression. You remember that, right? And so here, basically, we did the exact same thing. So we wrote here a function that has a similar format as this. We simply did not assign it to any variable. Instead, we passed it directly here into the add event listener method. So as a first argument, we had the name of the event that we're listening for, which is a click. And then as a second argument, we have this function value. And this function simply contains the code that we want to execute whenever the event happens. Also, note that we do not call this function here anywhere, right? We only define the function here and then pass it into the event handler. But it is the JavaScript engine who will call this function as soon as the event happens. Okay, that's important to understand. So again, this function will not be called immediately once this script here is executed. This function will only be called as soon as the event happens. And you can also see that here in the code because, well, we don't call the function anywhere using the parentheses, right? And so, yeah, again, we're just really passing it into the add event listener function. So this works just fine now. Let's try here another number. So now we get 99. And of course, we can also do some DOM manipulation here. For example, let's just, grab this piece of code here and paste it here as well. Give it a save. And now when I click this here, not only the value from this input field will get logged to the console, but also this message here will change. So the text content of this element. So you see, correct number and now 22. Now, of course, this has nothing to do with the game yet. So I just wanted to show you that, but let me get rid of this actually. But now let's actually start to slowly build up the game. So in the real game, when we click on this button here, of course, this number from this input field will have to get retrieved. So let's start with that. And so we already did this here, but instead of just logging it to the console, let's actually save it into a variable. So const guess and then equal this. Okay. And now let's log it to the console just so we see it. And so this should now do the exact same thing, but we first stored that value into a variable and then we log it afterwards. All right. Now remember how I said in the fundamentals section that usually whenever we get something from the user interface, for example from an input field, it usually always is a string. So let me show that to you here now. So again, we use the type of operator that we already learned before. And now when I put this here, we indeed get a string. However, we will eventually have to compare this number here with a randomly generated number. So that's going to be basically the secret number that we will have to guess. And so if we want to compare numbers with numbers, we need to first convert this string to a number. So let's do that here using the number function that we also already used before. And so now let's print both here. So the guess and then the type. And now we get 5. And now it's also here in purple. And we get that it's a number. And now let's start to implement the game logic here a little bit. But just the simplest case, which is the case that there's actually no guess. So usually in an application like this, which has an input value from the user, the first thing to do is to check if there actually is a value. And if there is no value, well, then we can print something to the console as a response. So we can say if there is no guess. And let me actually show you how that would look like. So if I click on the button now, indeed we get 0. And 0 is a falsy value. Okay? And so guess here in this logical context of the if-else statement will be false. So that's what we learned in the fundamentals section, right? So any value that is here in this condition part will always get evaluated to a Boolean. And so since this guess is 0 in this case, and 0 is a falsy value, it will be converted to false. But we want something to happen whenever this is false. And so here we actually want a true value, right? And so we simply use the negation operator to then invert this Boolean from false to true. And so in this case, we can then print some sort of message here to our message field or message element. And so let me again go ahead and copy it from here because we already did that before. So let's say no number, and then as always an emoji here. Let's do this one, or actually it's more like forbidden. So that's the one I used. Let's save it. And so now whenever I click this button, let's check it, then indeed we get no number. Okay? So again, this works because 0 is falsy, and so guess here is false now. But then we use the not operator to convert it to true, and like this, we can then make this block of code execute. Because remember, it only executes whenever this whole condition here is true. Okay, and so with this, we implemented the first scenario. So again, usually the first scenario is always to assume that there is actually no input. And then we need to respond to that somehow. Now in the next video, we will then implement all the other scenarios. For example, where this guess here is actually correct. So where it's equal to the secret number. So we will have to generate that secret number then and compare it to the guess. But let's leave that to the next video. Let's now continue building our game and actually implement the game logic itself. And with game logic, I basically mean implementing the way how the game works. So we need to implement what happens when the guess is correct. So when it's equal to the secret number. We also need to implement what happens when the guess is too low or when it's too high. So basically we have these three scenarios. And to start, we actually need to define that secret number. Otherwise, there's nothing which we can compare the guess to, right? Now, where do you think we should define that secret number? Should we do it inside of this button handler, or should we do it outside? Well, the answer is that we should do it outside, because we only want that secret number to be defined once. So only when we start the application. And so that's out here, outside of the handler function. If we define the secret number inside this handler function, then on each click, we would get a new secret number. And so then the game would make no sense at all, right? We just need one number, which we can then compare to each of the guesses here on each click. So let's define the number. So I'm just going to call it number here. And now we need a random number between 1 and 20. And this is actually pretty similar to the dice roll that we did earlier in the fundamentals section. So we use math.random. And so math is basically an object that JavaScript gives us. And on there, we have a lot of different methods. And random is one of them. And it gives us a number between 0 and 1. So let me show that to you. So whenever I run this, it will give me a new number. And it's always different from the one before. Now, if I want a number between 1 and 20, I will start by multiplying this by 20. And so now we have this decimal number here basically ranging between 0 and 20. But all this decimal here is just noise. So let's remove that. And for that, we use math.trunc. And I'm doing all of this here in the console so you can see how this is building up. Okay. And so now I have a number which goes from 0 to 19. Because the result of this here will never really include the number 20. It might only include like 19.999999. But now we're cutting off that decimal part. And so we are now left with a number between 0 and 19. And so to elevate it to between 1 and 20, all we have to do is to add 1 here. And with this, we make sure that the number is always between these two boundaries. So let's grab this now. So now that it works, and put it here. And with this, we have our secret number. Now in the real game, the number will obviously be hidden, so behind this question mark. But now, since we are still in development, let's actually display the number here so that we can then test our game logic as we develop it. So let's select that number. And I think, again, we already did it before, but let's do it here anyway again. Let's just, so the class name is number. And then remember, we use text content, and to set it, we simply use the equal sign. And now, what do we put here? Well, just the number that we just calculated. And now, as I save it, watch what happens. Here we now have our random number. And as I reload the page, you will see different random numbers appearing. And again, for you, of course, it will be different numbers. And you see here 20, which is actually the maximum. So this means that 20 is indeed included in our range here. Just to check if it's all right. So if we don't see any weird numbers, but it all looks okay to me. And so let's now move on and actually compare the secret number to the user's guess. So here we already have the condition, if there is no guess, then just print to the message element that there is no number. So let's again check that. And indeed, it works. But now, what if there actually is a guess? So let's say else if, and now we will actually check if the guess is the same as the secret number. And since I'm always saying secret number, let's actually change the variable name. So double click to select it, and then I can double click on all of the instances. So that's this one and this one. So that's a nice VS Code trick. And so now I have these 3 cursors. So let's delete all of that. Secret number. So the code works the same now, but the variable name makes a little bit more sense. So let's create a code block here. And now we need to specify what happens when the guess is correct. So again, when the guess is the same as the secret number. That's essentially what the guess being correct means, right? So what should happen then is that the correct number message should be displayed. So let's copy that and put that here. And for now, that's actually it. So I'll just give it a save now. And so let's actually test this. So 5, which of course is different. And then in the future, we will want a message here saying that the number is too high. So we're going to do that in a second. But now let's just put the correct number here. And indeed, we now get correct number. So that's exactly what we defined here in this else if block. All right. So I hope all of it makes sense. And now let's work on that scenario that I just mentioned, which is when the guess is greater than the number. So you see that here in this big if-else if statement, we are covering all the different scenarios that might happen here to this number. So the first one was that there is no number at all, right? Then we checked if it's equal to the secret number, And now we will check if it's greater. So if the guess is greater than the secret number. And then what should happen? Well, let's again select the message dot text content. And then let's say too high. So the guess is too high now. And again, adding an emoji here. So I want this graph here. Okay. And now also, since we are working on this, let's account for the last situation or the last scenario as well, which is that the guess is lower than the secret number. So guess below secret number. And with this, we covered all the scenarios. Let's just copy this one now. Too low. And now we're using the adder graph here. Give it a save and let's test it. So right now we know that it's a 3. So let's try 12. And so now we should see too high. And yes, it works. Now let's test 1, which is too low, and it works again. And now let's test 3, which is correct. And indeed it is. Great. So that's working already. Now let's move on to the next step, which is to work with the score here. So remember that each time that we guess a wrong number, our score should decrease. So let me show that here to you again. So let's say 5 and see how it starts at 20, just like in our code. But now as I check wrong, so it's too high, and now the score decreased to 19. So let me check another one. And so now you see that my number goes down each time that I do a wrong guess. And so let's implement that in our code here as well. So as you see here, we start with a score of 20. And now in these two scenarios, where the guess is wrong, so here where it's above and here where it's below, we want to decrease that score by 1, right? Because again, each time that there is a wrong guess, the score should decrease by 1. So how should we do that? And I can think of two ways of doing that. The first way is to read the score from here, then decrease it by 1, and then print it here again. So that would be the first way of doing it, but there is a better way. And the better way is to actually create a variable for the score in the code and then update that variable. So basically to decrease that variable and then display the value of that variable here in this score label. And by doing that, we have our data also in the code and not just on the DOM. And so that's always a very good thing to do. So let me do that now, and then I will explain it a little bit better. So I'm going to do that right here after the secret number. So const score, and as you already know, we start with 20. And so that's our initial score, so the value that we set to this variable. And actually this should be a let, because we will then decrease that value, remember? And so it cannot be a const, because a constant is immutable. Okay, and now here, let's go back to the wrong guess scenario, or scenarios, because it's this one and this one. And then all we do is to decrease the score. So score equal score minus 1. And maybe you already know, or hopefully you do, that this is the same as writing score minus minus. All right. So we decreased the score, and then all we have to do is to display that score here in this element. So once again, we already did that, so no need to repeat. So it's this one here. So we select the element with the class of score, and then as the text content, we give the score. All right, and that's it. Now we just need the same code also in the other wrong scenario. So where the guess is below the secret number. So I'm just copying this code and putting it here. Give it a save. And before testing it, let me again explain what we just did here. So as I said, we could have also stored this score basically in the DOM. And to do that, we would always just read this value from here. So right from the DOM, then we could decrease that value and then write it back here to the DOM. But then we would not have that value in our code. So essentially, our application would have no way of knowing that score at all points. And so it's always good to keep a variable which actually holds the data in our code and not just rely on the DOM to hold our data. All right. And this variable here can also be called a state variable because this score is part of the so-called application state, which is basically all the data that is relevant to the application. And we could say that this 17, so the secret number, is also part of the state of our application. All right. And so we want all the data always to be available somewhere in our code and not just in the DOM. Okay. So always keep that in mind. And so that is why we implemented the solution like this. So whenever there's a wrong guess, we just take the score that we already have in our code, then we decrease it by 1, and then we display that new score right here. So let's reload. Let's say 17, and watch what happens to our score now. And indeed, it decreased to 19, and our number is too high. And when I click again now, you see it decreasing even more. Now let's try with a lower number. So too low, and our score decreased again. And actually, let's keep going. So let's keep clicking here and watch what happens. So I'm clicking over and over on the same button here, and our score keeps going down, and eventually we reach 0. And at this point, we should basically lose the game, right? But as you see here, nothing, of course, happens. And we can keep clicking here and go until infinity, and our program will, of course, not care, because our program obviously has no idea of losing or of winning the game, right? It is completely on us to write all that logic. So basically what this means is that all of this checking here, so doing all this here, should only happen whenever the score is still above 0. And then when the score is actually 0, then we should get some kind of message here saying that we lost the game. So let's quickly do that here inside of this scenario. So basically we need another if statement here inside this already else if block. And that's of course not a problem at all. We can perfectly have one if inside of the other. So what I was just saying is that this here, all of this, should basically only happen while the score is still above 0. So let's do that. So if score is above 0, only then do all of this. All right. And now else, so basically if it is 0, then we want to display another message. So we want to say, you lost the game with some losing emoji. So I'm going to use this one here. So that's an explosion, I believe. So let's test that now. And we only implemented this for when the guess is above the secret number. So let's now use 12. It's too high. And now let's keep going to test what happens. So we are approaching it now. And now we lost the game. But actually I could click twice as my score was already 0. So try this for yourself. I will just reload here and again put a number that is above. So So now the score is 1, and as I click, we should get the message, "You lost the game." So let's try. And it didn't happen yet. And it did not happen because the score was indeed still greater than 0 here, right? So we need to change that to greater than 1, okay? So again, a larger number. Now I get 1, and if I click, now you lost the game. And all we need to do is to then update the score to 0 here. So let's just copy this, write 0, and then before we test it, we can actually copy the same code to this other scenario. Now, as you can see, we are creating a lot of duplicate code, and we will fix that by the end of this project. But for now, let's just keep working on this. And the only thing that really changes here is this message. So you see that here is some potential to eliminate duplicate code. But again, we will take care later of that. For now, let's just make it work. Okay, and with this, I think we're actually finished. Let's just test it. So 5 is too low. So let's keep going down. And you lost the game. Great. Now let's test a larger number. And I keep clicking here. And now we lost the game too. Great. So our game logic is already working, and actually the game itself is also kind of working already. There's just 2 things that are missing here, which is the high score and this play again button. But before implementing that functionality, in the next video, we're going to talk a little bit about CSS and how we can manipulate styles using JavaScript. So the DOM actually also includes CSS styles. And so with DOM manipulation, we can also change styles. So let's try that out now. And what I want to do here is to change the background of this entire page here to a green color whenever the player guesses the right number. So when the player wins the game. And we will also make this number here wider than. So let me just demonstrate that here. So let's quickly win this game here. 17. And so you see, we want this green background and also this number here being wider. And for that, of course, we need to manipulate the styles of this page. So the CSS. Okay, so that should happen here in this scenario where the player wins the game. So where the guess is equal to the secret number. And actually, let's add some comments here to make this code a little bit easier to understand. So this one, when player wins. This first one is when there is no input. This is when guess is too high. And this one here is when guess is too low. So this now at least looks a little bit nicer. But anyway, let's now learn how to manipulate CSS styles. So we want to manipulate the style of this whole page. And so what we need to do is to select the whole body of this page first. Okay, so the body is basically this entire visible part of the website. So it's basically this whole element. All right. So as always, we need to start by selecting the element that we want to manipulate. So document.query selector and then the selector. And now it's just the body element. So there's no dot because that's for classes. It's just really the element name. And since there's only one body, it's going to work just fine. So here we select the body, And now we want to change the CSS style. So here we need to write style. So we access basically the style property of this element, and then another dot, and then the name of the property that we want to change. And in this case, it is the background color. So background. And in CSS, we write the background color like this. Background dash color, right? However, in JavaScript, that's not allowed. And so in JavaScript, all these property names that have two words, like background color, will simply adopt the camel case notation that I already explained you before and that we've been using all the time. So instead of background dash color, it's going to be background uppercase C for color like this. And the same rule applies to all the other property names that have multiple words. So style.background color, and now we set it to something. And let's get the actual color from our CSS. So you see that background color here is the one that we're trying to define, and we will specify it to this color value. So this is a standard RBG value in hexadecimal. And so we set it equal to, then we must write a string, and then the value we want to set it to. So just like before, to set anything on the DOM, we simply use the equal sign. So we have all of this. So the background color property on the style property, and we want to set it to this value. And so we set it equal to the value. Okay, so that's one part. And now let's also increase the width of this number here. Okay, and that's important because I want to show you something there. So document.querySelector, and that is the element with the class of number. And again, we want to change the style. So .style.width. And then again, we need to specify a string. So whenever we are manipulating a style, we always need to specify a string. We cannot just write like a number, like 30. It has to be a string, and in there we need a unit. And now I already closed the file, so let's open it up again. And the number that I'm looking for currently has a width of 15 rem. And now I want to double it, so 30 rem. So 30 rem. And again, it needs to be inside of a string. I cannot just write 30 rem or 30, so just a number. That would not work. We have to specify a string, which in this case contains the number plus the unit. So the same would be for percentages or pixels or whatever unit we use in CSS. Okay, give it a save now. And now let's actually try the correct number right away. So 12. And yes, it worked. Let's actually get rid of the console here. Then the page looks a bit nicer. And we can also, by the way, get rid of the terminal here in VS Code, because even if we close this panel here, this process will still keep running. The only way we stop this process from running is by hitting here this trash can, which will kill the terminal, or by hitting Control C. So let's close it, because this takes up too much space. But yeah, so this worked just fine. Now these styles are actually set as inline styles. So of course we are not changing the CSS file or anything like that. And let me just show that to you. So actually I will need back the dev tools here. Make it a bit larger now just to show it to you. And so indeed, it is an inline style. So a style that is applied directly in the HTML using this style attribute. And the same is going to be true for the body. Exactly. So we see here, this is the background color that we just applied. All right. So of course, not changing the CSS file or anything like that. Okay. And that's it, actually. That's really the fundamentals of manipulating styles in CSS. The most important thing to remember is to use the style property, and then on there is where we specify the CSS property, And we need to specify that property in the camel case notation in case there is 2 words. And then the value always needs to be a string. So that's all you need to know in order to change styles like we just did here. Awesome. We're doing great progress in this project, and I hope that you're enjoying it so far and that you find it a lot of fun to be able to manipulate a web page like this. Anyway, in the next video, we will implement this reset button here, basically, where we can play the game again. And so I hope to see you there soon. So as I just said in the last video, let's now implement the functionality of playing the game again. And actually, I will leave that as a challenge for you, because this is already a great time for you to practice what you've been learning in this section. Now, before I give you the challenge, we first need to fix something here, which is that we should actually hide, of course, this secret number. So right now, as we load the page, the number gets visible. But instead, that should, of course, not happen. So we don't want this here, right? So this is where we set the text content of the number to the secret number. Instead, we want this to happen when the player actually guesses the correct number. So let's just cut it from here and move it to the situation where the player wins, which is here. So we display correct number, and then we also display the secret number. And so now you see that we're back to having the question mark. And so let's start guessing. So 10, that's too low. 15, that's too high. And now it's a real game because now we no longer know about the secret number. And 12 is correct. And so now our 12 is also visible here. And the high score, by the way, is also working. Let's just reload the page and do that again. So 10 is too low. 15, 18 is too high, so 17 maybe. So it's gotta be 16, right? I thought I tried. Oh, okay. I did something wrong. So 13, so it's gotta be 14. And yes, indeed. So the game itself is really working. And so now it's time to implement the functionality of this again button, which will basically reset here this entire interface. So let's go to the challenge I have for you here. And so as I just said, the challenge is to implement the game reset functionality so that the player can basically play again. And then here I'm giving you all the steps to implement this functionality in order to make it a little bit easier and not too overwhelming. Now, if you don't want the steps, then just pause the video now and try to implement it on your own. But probably at this point, it's better to get a step-by-step recipe of what you need to do. So first, select the element with the again class, and then attach a click event handler. So that's exactly what we did before with this button. And so now I want you to do the same with the again button. And try to see if you can remember how to do that instead of copying it from this other button. Then, once you have that event handler attached, in that function, restore the initial values of the score and of the number variables. So that are our two state variables of the application, basically. Remember? So the variable that holds the score and the variable that holds the secret number. So this here should actually be secret number. All right. Then also restore the initial conditions of the message, the number, and the score, and also of the guess input field. So basically when we click here, this here should be empty again. Here we should see the beginning message. Here the score should be back to 20. And here also should be the question mark as it was before. And then to finish, of course, also restore the original background color and the width of this number here. Okay, so just take a couple of minutes and try to do this, and I see you in a second. All right, so hopefully you managed to do this. Now it's my turn of doing the work. So we start, as I said, with selecting the button. So document.querySelector, and the class is again. So just showing that to you. So yeah, here it is. So that is the button. And then add event listener. And I'm just using autocomplete here because that's how developers do it. Then remember, the name of the event is a click. And then we need to specify a function. So this is our handler function, right? And by the way, we also say that this is an anonymous function because it doesn't have a name. So remember how I said before that usually we assign these function expressions to a variable, right? And then the function gets a name. But in this case, well, there is really no name for this function. We didn't call it anything, right? And so it's just an anonymous handler function. Anyway, let's now go here to step number 2. And so what we need to do here is to restore the initial values of the score and the secret number. So the score at the beginning of the game should always be 20, right? And then we also need a new secret number. So let's just get that from up here. So we don't need to calculate this over again. So we need just basically to reassign the value to secret number. So doing this same calculation here again. Now, if we want to reassign a value to this number, it cannot be a constant, right? And so we need to use a let here. So let's just copy this. And again, without the let, because we don't want to create a new secret number variable. All we want to do when a new game starts is to create a new secret number and then reassign the variable. So I'm just copying what I have selected here. And then down here is where I reassign this value to secret number. Okay. Next up, I want to restore the initial conditions of message, number, score, and the guess input field. So let's again copy this. So here, the string is start guessing. And we basically can get this from the HTML if we want. So this is the initial condition of the message, right? Then we also want to change the score. So let's just grab it from here. And that should be 20. Or actually, we can just set it to score. So to this variable, because that also already holds the number 20. And so that's a bit better than to repeat the same value. So instead, we are just referencing it here. Not 20, of course. It is score. Yeah, that was a silly mistake. Next up, we also want to change the number. So that's going to be this. So number, and set this one to the question mark. And finally, we also want to change the value that's here to empty. So let's copy that as well. So here is where we select that. Or actually even better, because we already set the value before. So document.querySelector, selecting the element with the guess class, and then we can simply set the value just as we did before to anything. And here, what we want to set it to is just to the empty string. So basically to nothing, because that's the empty value here. Remember that the value of an input is always a string. And so the empty string is basically the absence of any value here. Okay, and now to finish, all we need to do is to restore the background and the width of the number. So basically what we did in the last lecture, but redo it once we start a new game. So I'm just copying it here. and then paste it down here. Here, the number is 222, so this dark gray, and here it's 15 rem. Okay, and with this, we should have restored all the initial conditions, which will then make it possible to play the game again without reloading the browser. And that's going to be important later once we implement the Highscore, because then we will be able to play over and over again without reloading the page, which will then allow us to preserve this Highscore here throughout the different rounds. So let's just play the game so that we can finish it and play again. So that's too low. 15, 12, 13. Well, we can also use these buttons here, by the way. And we get the correct number. So that's nothing new. But now when I click again, everything should be restored. So let's see. And indeed, everything is back to the same. And of course, we can also do that while we are already playing the game. So let's just do this a couple of times. And now when I click again, this message should go to what it was. This should go back to 20, and it should also empty this field. So you see, that's exactly what happened. Great. So that was hopefully a lot of fun for you. And even if you did not manage to do all of it on your own, it was still important that you tried to do some of this, because it actually was kind of just repeating or reinforcing the stuff that we already did before. And hopefully you didn't just copy all of it like I just did, because as you're learning, the best thing to do is to really type all the code on your own, because that will then make it stuck in your brain. So in your muscle memory, so to say. Okay. Anyway, now in the next video, we will then finally implement this Highscore functionality here. And with that, we will then have our game completed. All right. So let's now implement the last missing functionality in our game, which is the Highscores. And to really understand how the Highscore should work in this game, let's take a look at the demo again. So let's reload the game and let's start here. And so you see that the score starts at 19. So let's try a couple of times, do a low score. Okay, so correct number, the score is 10, and the high score is now also set to 10, because this was my first game, and so now this is also my new high score. But now as I play again, my score is of course resetted to 20, but now if I do a better score than this 10 here, then that will become my new high score. Okay, and that is going to happen as soon as I win the game. So let's play again. And wish for a quick result. And great. So now my score is 17. And since that is more than the 10 that I had before, that is now also my high score. Okay? Again, because the current score is larger than the previous high score. And so that is now the new high score. Okay? All right. And so basically what we just saw here is now what we need to implement. First off, we're going to need a variable for the high score, right? So just like for the regular score, we also need to store the high score in a variable. So let high score, and let's start this one at 0. This way, the first score is always going to be the high score because it's always going to be greater than 0. Okay. So where do you think we should check for the high score? So basically, if the current score is greater than the high score. Well, remember that here the high score was set as soon as the player won the game. And so where is that in our code? Well, it's here in this if block. Okay, and so this is where we will check. And the check that we will do as I explained previously, is to ask whether the score is greater than the current high score, right? And if it is, so if our score of the current game is greater than the high score that we already had, well, then the high score will become this new current score, right? So high score equal score. And that's it. Now all we have to do is to display that new high score here in this element. And actually, of course, in our version of the game. So right here. So let's check the class name. And it is called the high score here. So just this span. So document.query selector. And don't remember, you should always write all of this here by hand to really put it into your brain. So document.query selector and high score. And I have a problem writing score apparently. So text content, and this will be set to high score. Okay, and that's it. This is the translation of the logic that I just explained earlier. So we need to have a high score variable so that we can keep track of it. And then whenever our game finishes, we check if the current score is greater than the high score. And if it is, that will become the new high score. And so we set our high score variable to the current score here. Okay. Let's just, to make sure, reload it here. And then let's play. Too high. Correct. Oh, and now we have a very high score because we did it in our second guess. Let me actually reload this page here. So I want a really low high score. So let's try it again. So I clicked a couple of times to decrease the current score. Oh, and now we have a score of 14. And you see the new high score is now 14 because it used to be 0, but of course 14 is greater, and so 14 becomes our new high score. Okay, and now as I click again, everything will reset except for the high score. So that was the goal of having this button here, so that we can play the game again, but keeping the high score. Because of course, if we reload the whole page, then everything will be lost. So the whole code will then run again and everything will reset. But here we now keep our high score, right? So let's play again and try to get a better score here. So that's too low. $17 maybe, and yeah, now we get an even better score because of course 18 is even greater than 17. One last time now with a lower score, just to see that it will then not become the new high score. So we always need to test for all the scenarios that we implemented in the code, just to make sure that everything works. Oh, 15 again. And so you see that the score was now 12, but the high score, of course, remained at 18, because this part here is now not true, right? Okay, so we implemented that as well, and now our game is actually functional. It works just fine, and you can show this now to a friend and tell them that you built this on your own with the power of JavaScript. So how great is that? So again, congratulations for making it to this point and for building really your first game using code. Now, it's not really a sophisticated game, but I still think it's a great achievement. Now, in the next video, we will finish up and clean this code a little bit. For example, this code here that we have in this scenario where the guess is too high is almost the same as we have here. And so we can change that a little bit to eliminate some of this duplicate code. There's also some other duplicate code that we can get rid of. And so, yeah, let's do that in the next lecture. because it's also important to really finish up our applications and not just make them work. To finish this project, let's now learn about a technique called refactoring in order to get rid of some of our duplicate code. So, as I said by the end of the last lecture, we have some repeated code in our project. And more specifically, where we can really see this is in these two scenarios, where the guess is too high and where the guess is too low. So here, this code is really almost the same as this code down here. The only thing that really changes is this string here. So this message that we display if the guess is too high or if it's too low. And so having a lot of duplicate code, remember, violates the don't repeat yourself principle. So the dry principle. So right now, all of this code here is not dry. Now, why is it actually so bad to have duplicate code, you might ask? Well, one of the answers is that whenever we have duplicate code, when we then want to change some functionality, we have to change the same code in multiple places. For example, we might want to change the message when the player loses the game. So this one here, right? And then we would have to change it here and here. And in a small example like this, it's not a big problem, but it can quickly become a nightmare for a bigger code base. So try to avoid duplicate code whenever you can. However, when we first write the code, then it's no big problem to start out with duplicate code. And so that's why I did it like this here. That's why we have this duplicate code, because I just wanted to make it work. But then, as we move on in the project, we can use a technique called refactoring. And refactoring basically means to restructure the code, but without changing how it works. So basically, we do refactoring to improve the code and to eliminate duplicate code. And so let's now start to refactor all of this code here that we just talked about before. So the first step of refactoring is to identify duplicate or almost duplicate code like we already have here. So this code here is almost the same as this one, with this string here being the only exception. And so what we're going to do now is a way to eliminate half of this code here, basically. So how are we going to do that? Well, this first if block here checks if the guess is too high, and this one checks if the guess is too low. But in both cases, what we're really doing is to check if the guess is different from the secret number, right? So whenever the guess is different from the secret number, then all of this code here should get executed, right? Where the only thing that changes is this string. So instead of having one big block for the case where the guess is too high and one for when the guess is too low, let's just have one block for the situation where the guess is different. So let me actually add a new else if block here, and then we delete these two, okay? So here, else if, and then this moves down here, and then when guess is wrong, basically. And so that means basically the opposite of this. So here we have when the player wins is guess equal secret number. But here, when the guess is wrong, it means that guess is different from secret number. And so now we can just take this code, which is the same in the two blocks. I will copy it and paste it here. So this is what should happen, except that the too high should of course only happen when the guess is larger than the secret number. So now we still need a conditional to figure out if the guess is greater or lower than the secret number. Now what I'm going to do here is to actually use a ternary operator. And so let me show you how. So I will say when the guess is greater than the secret number, then here the string should be too high. And if not, so else, then it means that the guess is less than a secret number. That's just the opposite, right? And so then we want this string. So let's copy that, put it here, and that's it. So I will give it a save. And now we can safely delete all of this here. Whoa, that's too much. Let's delete it. Or actually, let me just comment all of it so that you can still keep it here as a reference. Now here something is kind of wrong. Oh, and that's because I took away the closing curly brace here. So this one. And so now everything should be correct. Yeah, so you see the red underline is gone there now. And so let me explain again what we did here. So first we unified the two conditions that we had earlier, where the guess was either greater or larger than a secret number. Both of these basically mean that the guess is different than a secret number. And so we just created a block for that, because all of this code here is the same in both situations. The only thing that changes is the message that is displayed on the page. And so here we then basically determined that message with the ternary operator. So here is where we then asked if the guess is greater than the secret number. And if it is, then the text content here should be too high. But if it's not, then the text content should become too low. And remember that this works because the ternary operator is really an operator. And so it will return basically a value. Okay, so all of this here, all this operator will return a value, either this one here or this one. And so then that value is what will get stored in the text content of this message element. So let's now test this actually. So that's too low. Let's try 20. And that's too high. So it means that it's probably working. Let's try 17. Let's try 19. And so it's got to be 18. And yes, everything worked. And so our refactoring here was indeed successful. And I hope it made sense to you. You can just pause the video and review your code in case that it's not 100% clear yet. Okay? All right. So we fixed that by simply condensing two versions of almost the same code into just one. However, sometimes a good refactoring technique is also to create functions. For example, we have the same code here in multiple places. So this code where we set the message. So as I select this code here, VS Code will highlight all the same versions of the code in the entire file. So you see that we have this document.querySelector message.text content all over the place here, right? Well, at least 1, 2, 3, 4 times. Down here, yeah, here. So 5 times even. So that's a lot of duplicate code. And the same is true for setting the number, or for setting the score, or also, for example, for calculating this random secret number. We have the same code here and also here. And whenever that happens, we can also refactor this same code into a function and then call the function in all the places where we have the duplicate code. So basically, we can refactor functionality that we use over and over again into their own functions in order to make the code more dry. Now, I'm not going to do that into all the examples that I just mentioned, but I will do it with setting the message text content. All right. So what I will do is to copy this. Okay. And then I will create a function out here. And the function will be called display message. So it's a function, and the parameter will be the message. And then in the function block, all we will do is this repeated code. So setting the message, and then we will set it equal to the message that is passed into the function. All right. And now to show you how it works, well, let's just use it down here. So instead of this, let me comment it out. I can now simply say display message and then with this string. So this string is now the argument. Okay. And so this argument is what will become the message here in this function when I call it, right? And so then here we say document.querySelector for the message.text content should be the message that we just passed in. That makes sense, right? And so basically we took this code here, which is responsible for setting the message, and put it into this display message function that we can now use everywhere instead of having this repetitive code. And just to show you that it works, let's now just actually do this. So clicking here without any content. And so now we should see the no number displaying here just like before. And indeed, it works just fine. So let's now go ahead and replace all of these occurrences of this same code. I will not delete them, I will just comment them out, but you can go ahead and delete them from your code base if you feel like it. Instead, let's just use always display message, because that is a lot cleaner. Also, this really shows what we're doing here. So when we're reading the code, we don't have to really understand what's happening. So if we try to read this code like 1 year from now, and if we then come here, we have to try to understand what all of this means here, right? But instead, if we simply have a function called display message, it's a lot easier to simply read the code and say, okay, this here probably means to display a message, and this here is going to be the message, right? That's a lot easier to understand when you read the code later. And that's also an important thing in web development. So here is another one, and this is the one that we just refactored earlier. So this one is going to be a little bit different. So display message, and now here we need the argument. But that's no problem. We can simply do the exact same thing that we did here. So let's just grab this, and now we can comment this out, and actually this one too, and just paste it here, right? And so now, according to this condition here, the argument will either be too high or too low, because the result of this operator, once again, will be either this first string here or this second string. And so that will then be the argument, and the message will then be displayed accordingly. Okay, here, once again, display message, you lost the game. Okay, and down here there's another one. Yes, here. So display message. And give it a save. And so now everything should work the same. And yeah, that's awesome. Yeah, everything works just the same, but our code is a little bit more dry now. And as I said, you could do the same for all the repetitive stuff here, which I will actually not do here because that takes too much time, but you can of course have some fun and do it on your own. But there's really no need to do it. I just wanted to make a point here that this is a really important thing that we do when we write real code. So always keep refactoring in mind when you write your own code. And of course, we will do a lot of refactoring throughout this course. Anyway, with this, we finished this project. Again, I really hope that you liked it and that you maybe showed it to a friend or so and told them that you did it in this course and yeah, how much fun it really is to build something like this. Next up, we have another project, which is also going to be really fun because we will build a real UI component, and that's going to be a modal window. So stay tuned for that one once you finished this one and really understood how all of it worked. Welcome back. Let's now start working on project number 2 of this section. And in this small project, we're going to build our first UI component. And that is this modal window that we can see here by opening or by clicking actually on one of these buttons. So I'm sure you've seen this kind of component all over the place when visiting web pages. And so it's simply this window here basically and this overlay which gets overlaid over the rest of the page, right? So no matter which of these 3 buttons we click, it will always open this modal window. And to close this window, as you already saw, we can either click this button here, or we can click outside of the window. So basically on this overlay. And again, I'm sure that you have seen this functionality when visiting other web pages. So that worked as well. And finally, we can also close this window by hitting the escape key on our keyboard like this. Okay. And this is actually very simple and very easy to build. Probably way easier than it looks like. But it will still be very useful to learn how to work with classes. And that's super important because manipulating classes is actually the main way in which we manipulate web pages. Okay. Now here on the left side, I still have the code from the previous project open. And that's because I wanted to show you how to close the live server. So let's go back to the terminal. And so as we hit new terminal, it actually creates a new terminal. So if we want to go to the first one that was already running, we need to go here to this menu here, and then number 1, which is this node. So to change this now, we hit Control C, and that's even Control on a Mac. So it's not Command C, it is Control C. And I guess on Windows, it's going to be the same. But if it's not, you can just click this trash can here, and that will also then kill the terminal. So as I hit Control C, the process has finished, and so the live server is no longer running. So if I come here to this URL, so this localhost URL plus the current port, which is 8080. So if I now reload this page, it will be gone. So there's no connection possible anymore because I just killed the live server. Okay, just wanted to let you know about that. Okay, anyway, let's now close up this folder here and open a new one. And as always, I already have here the starter files for this modal project. So let's open up a new VS Code window. And let's open up this one. And once again, I have the prettier configuration here, and then the index, the JavaScript, and the CSS styles. Okay, open up script. And actually we can open all of them because we will want to take a look at the 3 files. Okay, and as before, we still are using strict mode, and so I already included that here at the top of the file. Okay, and now let's get to work actually. Now this time we will actually start by selecting everything that we're gonna need for this project. So that's usually what we do when we build a project like this. So we select the elements that we need, and then we store the selections into variables. Okay, and then we can use them over and over again. So that's way better than selecting the same elements over and over again, like we did in the last project. All right, but in the last project, I didn't want to overcomplicate stuff and do too many things at the same time. And so I just selected all the stuff multiple times. But again, this time we will have all the necessary selections, so all the necessary elements that we're going to need, nicely organized here at the top of the file, each in its own variable. So let's take a look at the HTML. And so here we see the 3 buttons. So that's these 3 buttons. And then we actually already have the modal window here in the code. So this div element here. So it's already in the code, it's simply hidden. That's why it has this hidden class. And now in the CSS, let's come here to the bottom of the file. And so the hidden class simply sets the display to none. And so that's why the window is currently hidden. All right. So again, as I said in the beginning, in this project, we will work with classes. And so this hidden class is the main class that we will be concerned with. So anyway, this means that we will not basically create the HTML for the modal window using JavaScript. It is already there. All we will do is to show it and to hide it according to the clicks on the buttons. So that's the modal, and that is the overlay. So that's basically this dark part here, which hides the background. And then here we have this button to close the modal window. And so that's all that we need. So again, we need to select the modal, the overlay, the close modal button, and then of course the show modal buttons. Okay, so let's do that. So const modal is document.querySelector, and then just like before, we are looking for the element with the class of modal. Okay, so just like we did in the first project, we select an element using this selector, but then this time we actually store the result of the selection, so the selected element, in this variable. Okay, so that's the element with the class modal. Now we want overlay and then close modal. So overlay, and of course we could give these any names that we wanted, but these names make it easy to understand what they are. So I'm giving them the same names as the class names, basically. So that's the overlay. And now the close modal button. And let's call this one actually a button. So btn, which stands for button, and then close modal document.querySelector. And then this class is close-modal. Okay. And now finally, we also want the show modal buttons. Now, there are actually 3 elements with this class name. So let me show you what happens when we simply select in the same way that we did before. So let's say button, or buttons actually, because we want multiple, open modal, and then document.querySelector open modal. Okay, and so watch what happens when we log this to the console. So buttons open modal, that's the one. And now to actually see this, we need to again start the live server. So new terminal, clear this console, and then all I have to do is to type live server, hit enter, and here we go. So this is our modal window now. And this one we can now close. And actually it has the exact same URL. So it's always this 127.0.0.1, which stands for localhost at port 8080. So if we reloaded this one, it would show us the same thing. Okay, so we can just close one of them. And so it looks exactly the same as the demo, but of course, nothing is going to happen yet. Because as you know, we have no event handlers on any of these buttons yet. But now I wanted to take a look at the console. And yeah. And now here we get null for some reason. So it means that it could not select anything here for this selector. And so let's take a look. Yeah, actually it is show modal and not open. Okay, so let's fix that. So it's not open, it is show. And maybe you have spotted that if you took a more careful look at the HTML than I did. Now anyway, now we see this button here selected. However, as you can see, it is only the first one, okay? And so now we see the limitation of our query selector method here for the first time. So whenever we use query selector with a selector which actually matches multiple elements, only the first one will get selected. And so here we need another one, but it's pretty similar. It's called query selector all. So that's a pretty obvious name, but it's going to do the job. So as I save now you see that we get something called a node list here. So let me open that. And now as I hover, you see that these are actually all of our 3 buttons. Okay. So this node list here is a little bit like an array. It's not exactly like an array, but here for now, it works as though it was an array. Okay. And so now if we want to do something, for example, to all of these buttons, then we can simply loop through this node list and do something with them. So let's actually quickly do that. So we will now again use the for loop. And now I hope there's no need to explain anymore how this one works. So I should stay below the length of this node list, which again, for our purposes here, works just like an array. Buttons, open modal dot length, and then at the end of each iteration, increase the counter. And so in each iteration, what we want to do is simply to log to the console the text content of each of them. All right. So what we want to do is buttons open modal, and then we take the current one. And so this here is now an element. Okay. It's one of these elements. And well, now it already logged because it saved the file. But yeah, anyway, each of these here is one element. And so now on each of them, we can simply use the text content property just like we did in the last project. All right. So let's save it again. And indeed, now we get the 3 text contents for all the 3 buttons. And here you might have noticed that I didn't even use the curly braces to define a block. And that's because just like in an if-else statement, if there's only one line of code that I want to execute, I actually don't have to create this block. Okay, I can just write one line after the for loop, and then that's the one that will be iterated over and over again. Okay, so again, this works just fine. And now I have a way of selecting multiple elements with the same class. And then with the for loop, I can do something for each of them. In this case, all we did was to log their text content to the console. But in the future, we will then be able to do real stuff using this technique. Okay, and that's it for this video. In the next one, we will actually already make this modal window work. So don't wait, and let's move on to the next video right away. Let's now actually learn how to manipulate classes with JavaScript. But the first thing that we have to do is to actually react to a click on each of these buttons here. So right now, of course, nothing happens. And so now we need to attach an event handler to each of these 3 buttons. Now we finished the last video by learning how we can do something for all of these 3 buttons at the same time, right? So for that, we used a for loop, which loops over this node list, which is basically an array holding all of the buttons. And so this buttons open modal at position number I is the current button element in each iteration. And then from there, we simply read the text content property just like on any other element. All right. But now let's take it one step further. And instead of simply reading the text content property, we will call the addEventListener method, just like we learned in the last project. Okay, so remember, in order to respond to a click event, we will attach an event handler function to the element. And event handler and event listener are pretty much the same thing. So that's why this method is called event listener. So let's say add event listener and then the name of the event. And that is once more the click event. And then the second argument is the function which will contain the code that should be executed once the button is clicked. So that will be an anonymous function, remember, so a function without a name. And it is, of course, also a function expression, because it's simply this value here. So this function value. So just as I explained multiple times already, but it's important to keep remembering this stuff as we go here through this section. And to start, let's simply log to the console the text content of the button that was clicked. Now here there's actually a mistake, because of course we don't want to log to the console this event listener, right? That doesn't make any sense. Instead, we now want to log something to the console right here inside this handler function. So that's just CL again. And then let's just say button clicked. Give it a save. And now each of these three buttons here has their own event handler function attached to it. So button clicked. And when we clicked on this one, then the same should appear. And indeed, now we have two. So that's what this 2 means. And as we click here, we get another one and another and another. And so, yeah, this worked. So we attached this function here now to all of the 3 buttons. And again, because we did it here in the loop while we were looping over this node list, which contains all of these 3 buttons. Okay, but now, of course, this is not the only thing that we want to do. Instead, we want to display the modal. And remember that this modal is already in the HTML. It is hidden right now because it has the hidden class. If it did not have this hidden class, it would be visible. Let me actually show that. So I delete it, and if I save it now, then you see here is the modal. Right? Here it is. And that's because the hidden class is now gone. And so basically this is exactly what we will do using JavaScript. So removing this class. Okay. So what we want to do is to take the modal. So this element that we selected here previously, right? So we selected it and then stored it into this variable. And so now we take that selected element and on there we can read the class list property. So that's class list. And then this class list property itself has a couple of methods. And the one we're going to use now is remove. And as I just explained, the class that we're going to remove is the class called hidden. Okay? And we can actually also remove multiple classes. For that, we just have to pass them in with commas like this. So here we then can specify more classes. Just keep in mind that we do not use the dot here. So not like this, okay? And I'm telling you that because I used to do that mistake myself and I remember that. And so yeah, I want you to avoid it. So the dot is only for the selector. But here we are not anymore selecting anything. We're just passing in the name of the class. And so all we need is the string with that name, okay? Now besides removing classes, we can also add classes, and we can even check if an element contains a certain class or not. And we will use all of them in this video and the next one. Okay, and this should actually already do the trick. So when I save this now, and let's click here, and it worked. Great. So the hidden class is now gone, and I can show that to you here using the inspect. And then we need to give it some more space back. And then you see here the modal class that used to be here is no longer there. Now we can of course not close it because that functionality is not yet there, but at least now it is open. Now we also have the overlay, which is this one, which also has the hidden class. And so in order to show that overlay, we need to remove the hidden class from this element as well. So that's easy enough. It's just the same thing again. So overlay dot class list dot remove, and then again hidden. All right. And yeah, beautiful. That's really nice. So using classes like this is a really great and handy way of manipulating web pages. And in practice, adding and removing classes like we just did here is the main way in which we change styles on websites. That's because a class basically aggregates many styles in just one class. Now in this case, actually the hidden class only contains this one style here. So this would have been the same as specifying the display style directly in JavaScript. So like we learned in the last project. So we could have done also modal.style.display and then set it to block, I guess, or what was it? Yeah, nothing. So basically, display none means that it's not visible. And if we want it to be visible, we would set it to display block. Okay, so this would do the exact same thing, but you can see that it's a bit more of a pain because then we would have to memorize what exactly we have to write here. So the exact property name and the exact value. And this is only for one style. Imagine that the hidden class actually had 10 properties. Then we would have to write all of these properties here manually and change all their values. So that's a lot of work and it's not fun. And so instead, we can basically aggregate all of these properties in one class that we then define here in CSS. And then in JavaScript, we simply add and remove these classes as we need or don't need these styles. So usually when you need to manipulate styles on a page, then always just export the styles into a class and then use the class just like we did here. All right. Now what we just did here is for showing the modal window, but now let's also add the ability of then hiding it by clicking that button. So this button here. Okay. So right now, as I said, it's not possible to close the window unless we reload the whole page. So let's take this button here that we already selected and simply add an event listener to that one as well. So button close modal dot add event listener, and again waiting for the click event, and then let's specify our function here again. Okay, so again we are just defining the function here. We are not calling it itself. It is the JavaScript engine who will call this function as soon as the click event happens on exactly this element. All right. Anyway, here we now want to do the opposite. So basically we want to add the class back on. So modal.classList.add this time. And so we add the hidden class back on, which will then hide the modal. And the same actually for the overlay. So let's just duplicate this line here and change this to overlay. And yeah, this should already work. So that already worked before. And now let's check it. And yes, it does. And it should work for all the 3 buttons, of course. And yeah, it does. Great. So again, this is a very common thing to do. We change the appearance of websites and of elements like this all the time using this class technique. Next up, usually when we click outside of a modal, then the modal window also closes. So that's pretty common, right? So what I mean is clicking this area here outside should also close this window. So basically we want this code here to also be executed when we click on the modal, or actually on the overlay. So let's do that. So overlay.add event listener click. And now what should I do? Well, just to make it work, I can copy this code here, but you already know that this is not a good idea, probably. But let's just, for now, see if it works. So if we click outside, so this is the overlay. So as we click it now, then indeed the modal and the overlay are both hidden again. Great. So this works now, but again, we do not want this same code here in these two places. We want actually the exact same function to be executed no matter if we click the close button or if we click the overlay. So how should we do that? Well, we can simply export this function into a more real named function. So let me cut the code from here, and then I will create a function called close modal. So const close modal equals this function value. Okay, and so now this variable here is what holds the function value. And so what I can do now is to here specify that close modal function. And that's it. That's the function right here. So this here, what we have here, is exactly the same as this. And again, notice that we are not calling the function. We are not doing this, right? This would not work at all because it would immediately call the function as soon as JavaScript executes this line. But that's not what we want to happen. We want the close modal function to be executed only as soon as the click event happens on the close modal button. All right? And now here we can just do the same thing. So again, close modal. And that's it. That's so much better than what we had before. Not only did we make our code more dry, but we also made it more readable, more expressive, and more declarative. So right now, when we read this code here, it's a lot easier to understand. So we just read button close modal at the event listener of close the modal. Okay, that makes sense. So just by looking at this line, we see that when this element is clicked, then we want to close the modal. The same, when the overlay is clicked, we want to close the modal. All right, and so we know exactly what's going to happen when we read this code. And so for that advantage alone, let's do the same thing here with this function. So the one that opens the modal. So let me grab this one, just put them up here. Can also get rid of this console.log. And so let's put the two functions here together. So open modal. And now this function will be just this, right? So I'll just cut it again and paste it here. And so now we assigned this function here to this open modal variable. So once more, a nice function expression. And now we just take that and put it here. Open modal. And of course, again, we don't call it. We simply declare, or we define it here and tell JavaScript, hey, whenever a click happens on one of these buttons, then please call this function that we just specify here. All right. And so this is our code, and it's a lot better. And so actually we just did some refactoring here, and so restructuring our code without changing the functionality. And so that means that our code should still work the same. And indeed it does. We can open and close in two ways, and we can open it on all of the three buttons. Beautiful. That's really, really great. So to recap, if you want to use the same function in multiple event listeners, then you need to specify that function as a separate function, like this one here. And then you can pass that function as an argument to multiple addEventListener methods. So just like we did it here, right? So that's one of the takeaways of this video. And the other one is that we really, in practice, use the functionality of adding and removing classes all the time in order to change the appearance of elements on our page. And that's because classes allow us to basically aggregate multiple CSS properties in just one, like a container. So each class functions a bit like a container with a lot of properties in it. And then here, by adding and removing them, we basically can activate and deactivate certain styles all at the same time. Okay, so keep that in mind and even better, actually write notes maybe with what I'm saying, because this is really important stuff. So working with classes is something that we do all the time. And there is a third thing that we do with classes, which is to check if a class is actually present on a certain element. And so that's going to be the topic of the next video, along with learning how to actually deal with a Keypress event. So that's yet another really exciting video. So let's now check that out. Let's now learn how to handle Keypress events. So right now we can already close the modal by clicking the close button and by clicking outside of the modal. But usually there is also a third way, and that's by hitting the escape key on the keyboard, right? And so this is actually a great use case to learn how to respond to keyboard events. So in order to listen for keyboard events, we still need to use add event listener, because the Keypress event is simply just another type of event. Now, keyboard events are so-called global events because they do not happen on one specific element. And for global events like keyboard events, we usually listen on the whole document. So let's close this terminal here. And now let's write document. So that's the same document that we use for query selector. And so basically it's a big object which contains a bunch of methods for all kinds of stuff. And that includes the add event listener method. So by using add event listener here on the document, we are basically listening for events everywhere. So no matter where they happen on the page, they will always trigger the event handler that we're going to specify here. All right. Now here about the name of the event itself, there are actually three types of events for the keyboard. There is the key down, the key press, or the key up. Key up, which is, so it's this one. This one only happens when we lift our finger off the keyboard, basically, or off the key. Key press is fired continuously as we keep our finger on a certain key. And key down is fired as soon as we just press down the key. And so usually that is the one that we use. Okay, so the name of this event is just key down, and this event will happen as soon as we hit any key on the keyboard. Okay, and then just like before, we specify a function here. And this time let's specify it here directly, so without creating a separate function. So function, and then the usual way, just like we have been doing. Now, as I just mentioned here, so this function here will actually be executed for any key press that happens. So let me prove that to you. And actually it will be hard to prove because you cannot see what key I'm pressing. But anyway, a key was pressed. And so now as I go to the console and just press any key, you see a key was pressed. And it doesn't matter which one. So Q, 3, P, enter, ESC, any key just renders here the same message. However, we only want to close the pop-up when the escape key was pressed. Okay, so that key in the top left corner which says ESC, right? So how will we know which key was actually pressed if this event here happens for all the keys? Well, the information about which key was pressed will be stored in the event that is going to occur as soon as any key is pressed. So remember, as I hit any key here on the keyboard, a key down event is generated, and our listener function here, so our handler function, is waiting for that event to happen. And anytime that an event like this occurs, JavaScript does in fact generate an object. And that object contains all the information about the event itself, and we can then actually access that object in the event handler function. All right, so again, when an event happened, we can have access to information about that event in the event handler function, just like this one. Now, up until this point, we have never looked at that event. we only just listened for it and then reacted to it, right? But this time, we actually need to look at the event object in order to figure out which key was pressed. And how can we do that? Well, what we need to do is to give this function here a parameter, and let's call it E, which stands for event. So we could also call it event, or we could call it X or QI, so it doesn't matter, but I like to call it E, which stands again for event. Okay, so then as the event occurs, JavaScript will call this function with the event object as an argument. And once more, this works because we do not call this function here ourselves, right? We do not call the function, we only define it here. So we say, hey JavaScript, call this function when a key down event happens. And when you do so, please pass in the event object as an argument. Okay? And we will learn about the mechanics of this a bit better later. But it's probably still a good idea to already take notes of this stuff that I'm explaining. Anyway, now that you know why this function has access to an event, so to this E here, let's now actually take a look at it. So simply logging it to the console for now, and we can actually get rid of this one here. And now I will hit the Enter key. And so you see, now we get this event, and it's called a keyword event. It is just an object that is generated by JavaScript. So you see that here in the console, it actually looks like the objects that we generated ourselves previously. So with a key here and then a value. So a property and a value. And what matters here is basically the key, which, as I said, was enter. So I hit the enter key, and then this event was generated with the key property set to enter. So that's great information, because now when I hit the escape key, then you see that the key was now escape. Or I can of course hit any key. So this was the space key. So you see here that we have a space, or the Q, or Z, or Control, or Shift. And so whatever key you press, we now get this information about the event itself. And in this case, since it was a keyboard event, we get information about which key was pressed. So as you see, the information about the key, I was always getting it from this key property. So let's just log e.key, because remember we used dot and then the property name to read any property from an object. And so escape is now the key that I pressed, or enter, or shift, and so on and so forth. Great. And now that I know which key was actually pressed, I can use that information to actually close the modal whenever the escape key is pressed. So we can simply do if e.key triple equal escape. And then again, let's just log to the console to see if it works. Esc was pressed. And so now I can hit any key and nothing happens. Or actually, some stuff happens because we're still logging here the e.key, but the string that I just wrote here does not appear unless I hit the escape key. So now you see esc was pressed. All right. So that's of course not what we want, but instead we want to close the modal. However, I only want to close the modal when the modal is actually visible, right? And how do we know if the modal is currently visible? Well, if the modal contains the class hidden, it means that it's not visible. And so basically, when it does not contain the class hidden, it means that it's visible, and then that's the condition in which we want to close it. All right? And so we talked in the last lecture about adding and removing classes, but as I mentioned back then, we can also check if an element already has a certain class. And so now that becomes really handy, because now I can do this. So if the escape key is pressed, then we can now check if the modal contains the hidden class. So another if. So if modal and again dot class list and then dot contains and then again the class name. So that's hidden in this case. So if the modal dot class name contains the hidden class, it means that the modal is currently hidden. And so in this condition, we actually don't want to do anything. We only want to close the modal if it does not contain the hidden class, right? And so here we can once more invert that Boolean value. All right, so this not here is very important, as you probably start to see. So let's read this again. If the modal does not contain the hidden class, then close the modal. And so how do we close the modal? Well, we can simply call this close modal function, right? So let's do that. Close modal. And here we do actually need to call this function, okay? Because when this function here is executing, so this one here, as it then reaches this line, of course, something needs to happen. And what needs to happen is basically this code. So we could just copy this code down here, but that's of course not what we want. Instead, we can simply use this function here again, and using means here to call it. So to execute the code that is in here, so this. So let's test this now, and then we can improve the code even a little bit. So we open it. Now I'm going to press just any key, let's say enter. So you see enter. And now as I hit the escape key, watch what happens. Yes, indeed, the modal is gone. Great. Let's see where this button clicked here comes from in line 9. Now that's of course because of this console.log. And let's get rid of this. Okay, let's try it again. Open it on this button. I hit any other key, nothing happens. I hit escape and it's gone. Great. Now let's read this code here a little bit. So basically this means if the pressed key is escape and if the modal does not contain the hidden class, then execute this function to close the modal. Now notice how I just said if this and then if this. And so what I mean is that we can actually aggregate these two if statements together. And so this is the same as having just, and I'm cutting it here. So it's the same as having just this. Now we can get rid of this stuff here. And that's it. And so now it reads the exact same way as before. If the pressed key is escape and if the modal does not contain the class of hidden, then close the modal. So give it another try just to make sure. And yes, that works perfect. Beautiful. And with this, our modal is actually feature complete. It works exactly as our demo here. And so with this, we finished this very small second project. So once again, I hope you liked this one, and I hope you can start to see the power of DOM manipulation so that in the future you will be able to build anything you can imagine just with JavaScript. Now that is of course still a long way to go, but that's also why we have the next project, which is going to be a really nice project to basically train and reinforce most of the things that we already did in this project and the previous one. So the next project is going to be more like a practice project, but I still believe it's very important to do that project in case you have the time. And believe me, it's by far the most exciting thing we have done yet in this course. So I hope to see you there soon after you take a well-deserved break. Welcome back to project number 3 of this section. And this project is going to be the most exciting one, because now we will take everything that we learned in the first two projects to a whole new level and build a really cool and amazing game. And this is the game that I was talking about, and it's called the Pig game. Now, this project here is really going to be a practice project. So a project where you and me will together reinforce all the skills that you have learned up until this point. Because remember from the last section, reinforcing knowledge is one of the most important things that you can do to learn, right? So in this project, I will do a little bit less explaining than before, at least about the stuff that we already learned, because we are really just practicing here, okay? Now, if you're in a hurry and just want to learn the basics, please feel free to skip this project. But of course, I would still really advise you to code along with me here. But now let's see how this game actually works. And in fact, you can try that along with me, because this time I hosted this demo on a live website. So you can access that by piggamev2.netlify.app. And the link is also in the README file of the repository for this course on github.com. But anyway, this is more of a real game now, because we actually have 2 players. So you can play this with a friend or something, or just against yourself. So the idea is that we roll a dice. And so now I'm player number 1. So this one is now the active player. So I roll a dice. And so you see that I rolled a 2. And so this number gets added to my current score down here. Okay, so this is my current score for the current round. And this here is my total score. And so let's see how that's going to work. So I can roll the dice again now if I want to. And now I rolled a 4. And that 4 got added to the 2 that I had previously. So now that's 6. And now I can choose to hold this score. So if I click this button, this score of the current round will get added to my total score, which right now is 0. And so when I hold, then my score will be 0 now, and we switched to player number 2. And now I can click roll dice again. So we rolled a 2, and I can hold again. And so now player 2 has 2 points. Now the thing here is that whenever we roll a 1, we lose all our current score, and it's then the next player's turn. And so that's why sometimes we need to hold our points. So let me show that to you. And oh, indeed, I rolled a 1 right away. And so now it's player 2 again. So let's keep rolling the dice. And I will now again wait for a 1 so that you can see that all my current score will be lost. So that's a lot of points already there. And now I rolled a 1, and the player lost all the points. Okay, so I could have held the points, and then I would have added all these points here to my score. So let's do that here. And again, a 1. And so, yeah, now here I hold, and I added them to these points. And I think by now you get how the game works, right? So the first player to reach 100 points then wins the game. But I will now not demonstrate that because that's going to take too long. So we have these 2 buttons here, and then we also have, just like in the previous game, a way of resetting the game. So when I click here, as you might expect, this dice will disappear, and all the scores are set back to 0. And to understand this game a little bit better, for this application, I designed something called a flowchart. So let's take a look at that. And this is what a flowchart looks like. So basically, it's a representation of everything that can happen in the application. So on the left side, we have in yellow the possible actions that the user can take. And then from there, we see what happens in the application as one of these options is basically chosen. So as one of the actions is executed. So whenever the user rolls the dice, so clicks that roll dice button, then we need to generate a random dice roll. Then we display that dice roll, and then we check whether it is a 1. If it's not a 1, then add that dice roll to the current score. And of course, display it. Right? So that is exactly the behavior that we saw when we tested out the game earlier, right? Now, if the dice roll is actually a 1, then simply switch the player. And so in this case, the dice roll will not get added to the current score. Next, the other option is that the user wants to hold his score, and then we add the current score to the total score. Once that is done, we must check if the score is above or equal 100. Because as I said, the player wins whenever the score is at least 100 points, right? And if it's not, then we just switch the player and the game keeps on running. Finally, when the user chooses to reset the game, we simply set all scores to 0 and set the player number 1 back to being the starting player. All right, so this is a very nice way, again, to visualize what happens in the application, and it's also a very good guide for us to actually implement the application in code. So usually, whenever I build a project like this one, I like to draw a flowchart like this. And it doesn't need to have all this precision right from the start, so we can just start out with a rough sketch without the complete plan of what we're going to build. But anyway, this is very helpful before we actually start writing code to have a good idea of what we will have to do. And if you want to build your own flowcharts that look like this, you can do so on diagrams.net. So that's where I designed this flowchart, and it's a very nice online drawing application that is completely free and really easy and fast to use. Okay, and so now, as always, let's open up our project folder. So I have the starter files here already, and now I need a new VS Code window. And then I just open the pick game. And this time, since the application needs this whole space, let's actually put it here on a separate desktop. And then as we test out, I will just move here from one desktop to the other. So let's make this bigger this time. And so, like always, we already have all our files here. So let's take a look at them. And JavaScript. So here, as always, just the use strict. Then here we have all the styles that we need for the application, and we will take a look at them as we go through the project. And then finally, the HTML file. Okay, and I also actually included the image of this flowchart here for you, so that you can maybe take a look at it yourself to make sure that you really understand how it works. Okay, so take a minute or two to maybe test the app again and check out this flowchart before we actually start. All right. Oh, also, I wanted to show you that I have one image here for each of the dices. So dice 1 looks like this, like 2 looks like this, and so on and so forth. So we have one image for each of the possible 6 numbers. So that's going to be important later. But now let's just start to write a little bit of code here. Let's get ourselves a new terminal here so that we can take a look at the application as it looks right now. And here I like to minimize it a little bit. Live server. Okay. And so this is our live version of the pick game. So again, we are here at this localhost at port 8080. And if you're seeing some other port, that's no problem at all, as long as it works. So maybe you still have something running on this port, maybe from the previous project, and then this project will run on another port. That doesn't really matter. So right now, in the starting point, this is what our application looks like. But of course, in the demo, we don't see the dice in the beginning, and we don't see any scores here. Okay? And so the first thing that we're going to do is to basically put these scores to 0 and make this dice disappear. And so that's going to be basically the starting condition here. So let's go back here to the code, and let me just show you where these initial values come from. So this is the 43 score that we just saw, and this is the 24. And so let's take a moment to inspect the code, because as you already know, we need the class names, and in this case also the IDs, to then identify and select the elements. So basically here we have one of these sections here for each of the players. And you see that the first one is player 0 and the second one is player 1. And I will explain you why the players are called 0 and 1 instead of 1 and 2, probably in the next lecture. So it will make sense by then, okay? But now about the scores, they are stored in this element and in this one here. And so you see both of them have the score class, but then each of them has a different ID. And so this time we need to select these two elements using their unique ID instead of a class name. So that's the ID of score -- 0 and score -- 1. So let's do that. So const score 1 and then document .query selector. So this is the way that we learned it before. And now here we actually need the hash symbol. So score 0. So actually I'm interested in 0 here. Okay, and so again, now we used this hash because that is the selector for the ID. And the dot that we used to use is only for classes. Okay. Now, when we're selecting using an ID, then there's actually another way of selecting an element. And right now, that's exactly what we're doing. So we're interested in IDs, not in classes. And so let me show you that other way of selecting elements that only works by ID. So let's call this one score 1. And then again, we use document, but then we're not calling query selector. Instead, we call get element by ID. And then here we just pass in the name of the ID. So just score 1. So without the hash here, because now we're not writing a selector, we are only passing in the name of the ID that we're looking for. Okay, so this works exactly the same as this, but the get element by ID is supposed to be a little bit faster than query selector. But I guess that's only relevant if you're selecting like thousands of elements at once. So usually I like to always use query selector, but I still wanted to show you that there also exists get element by ID. All right. And actually let's call these two here score 0 L, which stands for element, because you might then confuse maybe this variable here for simply the score value of player 0, right? And so in this case, we are making it really clear that this is a DOM element. So score 0 L. All right. Okay. So we're selecting these here, and now we can use the variables to do something on them. And again, we do that because probably we will need to do something with these selected elements multiple times throughout the application. And so we just define them once at the top of our file instead of having to select the same elements over and over again. So let's just add a comment here. And comments are also a good way of structuring the code and also of planning how we will build some features. So selecting elements. And so in this project, we will try to get a little bit more used to actually writing comments. All right. Anyway, let's now set these initial conditions of score 0 element. And then, as you know, we use text content, and then we set it to 0. All right. And now the same for score 1. Score 1 element dot text content to 0. And here we are specifying numbers, not strings, but JavaScript will then automatically convert them to strings to actually display them on the page. So if we go now to the application, that should already be in effect. And indeed, you see that now the scores are actually at 0. Great. Now all we have to do is to hide this dice here. And so let's do that using the technique that we learned in the previous project, which is basically creating a hidden class and then add that hidden class here at the beginning. Okay, so let's go to our style. And right now I don't have that class yet, so let's just create it. And I can close the terminal here. Let's just do that at the very end. So we create a class like this, and then we just set the display to none. So that's exactly the class that we had in the previous project as well. Okay, and so now we can just add that class to the dice at the beginning of the game. So that's easy enough, but first we need to select it. So let's call it dice L for the dice element. Let's check out what the ID or the class of it is. And here we see that it's actually just this dice class. So this image with this class of dice. So document.query selector dice. And so here we have the starting conditions. And now let's simply do dice element dot class list dot add, and now simply the string which contains the name of the class. And that's the hidden class. Give it a save. Let's check it out. And indeed, now the dice is gone. And let's see the HTML here actually. And now indeed, we have the hidden class here besides the dice class. Great. And then as we implement the roll dice functionality, of course, we will want the dice to be visible. And then we can simply remove that class again from the dice. Okay. And actually, that's exactly what we're going to do in the next video. In this video, we will actually start implementing our game's functionality. And we will start with the most important functionality, which is rolling the dice. And let's start with another look at our flowchart here. So that's why I included it in the starter files. So when the user rolls a dice, we want to first generate a random dice roll, then display it, and then check whether it is a 1 or not. And if it's not, we add that dice roll to the current score. And if it is a 1, we go to the next player. And maybe you're noticing that having or building a flowchart like this is pretty similar to actually dividing the big problem down into smaller sub-problems. So essentially, all these squares that we have here on the flowchart are like the sub-problems that we now need to go ahead and implement. So again, for a bigger application like this one, it's a very good idea to draw a flowchart like this, along with the process of solving problems that I taught you in the previous section. So use all of these methods that I showed you together whenever you need to solve a problem. Because in the end, building a project like this is also simply solving a problem. So you know how the project is supposed to work, but then the problem is to essentially implement it yourself. And so you need to divide that big problem that can seem very scary into smaller problems that will then be easy to implement. And as we move through this project, you will see that it's not so scary after all. And with that being said, let's now also see this part of the flowchart in action in the real application. So this is a little bit less abstract. So we roll the dice, and now we roll the 1. So let's just do it again. Let me reload the game as if it was a new game. So we roll the dice, we roll a number. So we generate a random number and then display the dice accordingly. And then we add that score down here. Again, and now we actually rolled a 1. And so we moved on to the next player. Okay. So that's what I just explained before using the flowchart, but seeing it in action is a bit easier. So we want to react to clicking that roll button. So we need to select that button element and then add an event listener or an event handler, right? So here we have our 3 buttons, and actually let's select all of them. So we will need them anyway later. So that's button new, button roll, and button dash dash hold. So const button new is document.querySelector.btn and then 2 dashes new. And now I will just duplicate this line here. So that's button roll, and here also roll, and then hold. So let's just confirm new roll and hold, and indeed new roll and hold. So that's going to work just fine. And now let's implement here the rolling dice functionality. So for that, we take the roll button. So that's button roll. And then, as always, when we want to react to an event, which in this case is going to be a click, we use the add event listener method. Then the name of the event, and then our handler function right here. And since we will not reuse this function, I can simply write it here directly. So let's now write some comments before we actually write the code, because that is very helpful in knowing what we should do. So we already know that we need to start by generating a random dice roll. Then we display the dice. And then we check for a rolled 1, basically. And if true, switch to next player. Okay, so that's exactly what we have in the flowchart as well. So let's start here. So let's create simply a dice variable. And so that's why now we have dice L here for the element, and then dice for the number itself. And this variable here needs to be not a global variable, so not a variable outside here, because each time that we roll the dice, we want to generate a new number. And so let's simply define that variable here. And now we create this random dice roll just as before. So math.random, which creates a number between 0 and 0.9999, so almost 1. Multiply that by 6. Then we truncate all of this. So we remove the decimal part. So that's math.trunc. So basically we pass in the result of all of this into this math.trunc function. And so this will then give us a number between 0 and 5. And so we just add 1 to elevate that to 1 to 6. So that's similar to what we did before. And now we just need to display this dice. Now the first thing that we need to do is to actually remove the hidden class. So remember in the starting conditions, we hid the dice by adding the hidden class. And so now the first thing is to remove that. So dice element dot class list dot remove. So just like in the last project. And now comes the interesting part. So we know that the dice will be a number between 1 and 6, all right? And now according to these numbers, we want to display one of these images that we have here. So you see that we have dice -1, -2, 3, 4, 5, and 6. And so now we want to use this dice number here to, according to that number, display one of the images. And that's actually not hard to do. So let me show you how it looks like in the HTML now. So you see that right now, the source of the image is dice5.png. And if you know some HTML, you know that the source attribute here is how we define which image should be displayed. And we can now actually we can manipulate this source attribute from our JavaScript. And so that's the trick that we will use to display the image according to the rolled dice number. So let's again take the dice element, and then here there is a new thing. So now we can use the source property. So src, just like it is called in the HTML. And now we can set it to a string, and that string will then be the name of the image displayed. So let's use a template literal, and then we write dice dash, because that's basically the common name in all of these image names. And then here we use the dice number .png. And so with this, we can dynamically load one of these 6 images here, depending on the random rolled dice. So let's give it a save and let's give it a try, because this part should already be working now. So let's see. And indeed, we get this 3. Let's actually also log to the console for now this random number, just so we see that the dice is actually the corresponding one to the number. So let's go back here to the console, make it a bit smaller. And now let's roll the dice, and it works. Great. So we get a 2, and so indeed a 2 is also displayed here. Now 6 and 6 here. And let's just see if we get all the numbers. But yeah, we get the 1, and we already saw the 6 happening as well. So that means that our code is correct. Great. And now all that we have to do is to keep adding the rolled dice to the current score. Okay. And so that's what we will do here in this case, where we check for the rolled 1. So remember, that only happens when the number is not a 1, right? So again, if it's a 1, switch player. If no, then add the dice roll to the current score. So basically, let's test here if the dice is not 1. Because this is our main case, so the one that we're mostly interested in. And then our else block, which will be basically in case that dice is a 1. So let's just grab that here. So here we want to switch to the next player. But if it's not a 1, then we want to add the dice to the current score. So let's do this part here. And in order to actually be able to add the current dice to the current score, we need a way of saving that current score somewhere, right? So remember from the first project that we should not just store any data only in the DOM, right? So in this particular case, we should not only display this current score on the user interface. Instead, we also want a variable in our code which always holds the current score of this current round. Okay, so we need to define a variable for that. And where do you think we should do that? Well, it is certainly not in this function. So not in this handler function, because if we did that, then each time that we roll a dice, the current score would be resetted. So it would be redefined, because this function here is called over and over again each time that the button is clicked. So if we want to basically persist that value, so if it should keep existing, then it needs to be outside here in the main program. So let's call this one current score. And we start it at 0. And it needs to be a let because we will keep updating it. So again, this cannot be inside of this function because then it would be set to 0 each time that we click the button, right? And so therefore it needs to be outside. Okay, and now we say current score is equal to current score plus the dice. And once again, there is a shortcut operator for repeating this variable here. So instead of this, we can just write current score plus equal the dice. Okay, so that's exactly the same, but it's a little bit faster to write. And now all we need to do is to display the score on the current player. Now at this point, we will just display it on player 1 to make it a little bit simpler, but in the future we will need to keep track of which player is the active player. So that we will do in the next lecture. But again, for now, let's just display the score on player 1. So let's select the score or the current score for player 1. So let's check where that is scored. And it is right here with this ID --1 and --0. So let's actually copy that. And then I will select both of these elements up here. So let's do that below this one. And actually I will keep using get element by ID now. So current 0 and then again element. Get element by ID and then just the class name, again without the hash symbol there. And then current 1 element is document.get element and then current 1. Okay, and so now let's use this one. So let me copy it. Dot text content equals, of course, the current score that we just defined previously. Okay, and let me just add a note here. Change later, because in the future we will need to display this current score at the current player and not always at player number 0 or player number 1, right? But for now we just want to make this functionality work. So let's just test it out for now. So roll dice 4, and you see that it added the 4 to the 0. And now 3 plus 4 is 7, and so it works. And now that we rolled a 1, nothing happened. So in this situation, we want to move to the next player. So basically switching the player. And so that's going to be this else branch. But this one I will leave for the next lecture because this involves doing a lot of stuff. So maybe you can think about what we need to do, because that would be a good opportunity for you to start thinking by yourself how to implement this kind of functionality. So try that out, and then let's move on to the next video. Let's keep building our pick game. And in this video, we're going to be concerned with switching from one active player to another one. So as we already know, whenever the player rolls a 1, we will enter this else block, right? So when the dice is not a 1, then the current dice gets added to the current score. But if we happen to roll a 1, then we lose all our score, and it is the next player's round. All right. So in the previous lecture, we implemented this functionality of adding the dice to the current score only as the player number 0. Okay. But now we need to make this work for both player number 0 and number 1. And so for that, we need to keep track of which player is actually the current player. And in order to do that, we actually need to keep track of which player is actually the active player in the moment that the dice was rolled. So basically, we need to know which player is right now playing. And with right now, I mean whenever the button is clicked. All right. So we will create another variable which will hold exactly that. So it will hold 0 if the current player is player 0, and it will hold 1 if the active player is player number 1. So let active player, and since we start with the first player, we set it to 0. Because remember that player number 1 is player 0, and player 2 is, here in our code, player number 1. And in fact, let me explain you right away why that is. So the reason is that we will store the scores of both players in an array. So let me do that here. So let, or actually const, because it's an array. So const scores equals an array which will start with 0 points for both sides. And so these scores are actually the final scores. So the big scores which accumulate. Let me show that to you in the demo. So that's these big scores here. So these are the current scores, and these are, let's say, the total scores that keep accumulating, right? And so we are storing these two scores here in an array. And remember that the array is 0 based. And so the score of player number 1 will be here at position 0, and the score of player 2 will be at position 1. And so that's why it will be handy to have the active player variable here also set to 0 and 1. Okay, and we will see that in action actually in the next lecture where we will hold the scores. But for now, knowing which is the active player is going to be important to actually display the current score here for the current player and not just always for player number 0. So instead of manipulating the element of player 0, so the current score of player 0, let's actually select the element dynamically. Okay, so let me show that to you. So we will actually now do the selection right here. Document dot, and actually let's use get element by ID. And then here we need the class name. So the class name is going to be either current 0 for player 0 or current 1 for player 1. And so maybe now you start to see once more why we use the active player as 0 or 1. Because now we can use that variable to basically build these class names, okay? So when it's player 0, we will then end up with current -- 0. And if it's 1, we will end up with current -- 1, because that's going to be the active player. So what I just said is to do this. So current -- and then the number of the active player. Okay, and so now on this, we will get the text content and set it to the current score. Okay, so again, this one here will always set the text content on player number 0. But here we do instead select the score element dynamically based on which is the active player right now. Okay, so this is a very handy trick of building the ID name like this dynamically. Now here, when we switch the player, we of course will then need to change that value from 0 to 1 or from 1 to 0. So let's do that here. So essentially switching the next player means to change that value. So active player. And now here, let's now use again the ternary operator. So we can say if the active player is 0, then we want the new active player to be 1. And else it should be 0. All right. Does that make sense? So essentially we are reassigning the active player here. And we're checking whether right now it is player 0. So if it is, then here the result of this whole operator, so which again is all of this, then the result will be 1. And so then active player will be equal to 1. But if this is false here, so if the player is actually 1, well, then the active player will become 0. And so essentially this allows us to switch from 0 to 1. All right, so I think this should actually work already. So this is the demo, this is the real game. Let's just make sure that it works and reload it. And now as we roll the dice, remember that we are player number 0 right now. So this one. So 3 gets added to 0 is 3, then 7. So this works right now. 3, Let's wait for a 1 so that we can switch the player and see what happens then. Okay, so now we rolled a 1, and so now we should be player number 1. So essentially player 2. And so now when we roll the dice again, the new score should appear down here, right? Because this here is current 1. So this element here is the current 1 that we just defined previously. And indeed, it kind of works. So something happened here, but of course we need to reset the current score. So the current score was just for this player, but now we added that 4 to the current score of the previous round. So as we switch the player, we also need to reset the current score. Okay, so the logic of the active player is already working, but we still need to reset the current score. Also, you see that visually nothing changed yet. So in the real game, when the player is switched, this side here becomes white, and so the background kind of changes there. Oh, and another thing is that this current score here should also then be set back to 0 again. Okay, so basically the previous player should have its current score here visibly set to 0. So let me just show you what happens here when we switch to another player. So you see the current score, and now there's a 1, and so now this side here became white, and then of course the current of the other player became 0. So let's first take care of that logic of changing the values, and then I will show you how we change the background here. So let's go back, and the first thing that we need to do is to set the current score back to 0. So current score back to 0, and then we need to set the text content back to 0. Okay, so basically of the active player before we switch it. So for example, player 0 was playing, and then we switched to player 1, but before we do that switch, we need to change the current score of player 0 back to 0. So we need to do that here before we do the switch. Okay, so basically what we do is the same as this, but we simply set it to 0. Okay, so we're selecting the current player, which at this point is still 0, and then we set his text content to 0, and then we switch from 0 to 1. Okay, and actually we can also set the current score to 0 here, but that doesn't really matter, because the current score is not bound to any player. So saving it, and let's try again. So all of this is still working, but let's wait what happens on the 1. So that's a lot of points here. Okay, so the current score is back to 0 here. And now watch what happens. And yeah, nice, that's working now. So now the actual current score variable was also set back to 0. And so 6 plus 0 now on player number 1 is 6. So as we keep doing that, it keeps adding here, and now we're back to player number 0. So this one. Oh, then I rolled another one right away, and so we switched to this player back again immediately. But you see that the logic here is already working. Now, the only thing that's left to do is that visual change, so putting that white background here on this other player. So let me show you in the HTML how that works. And so basically, the player that is active has this whole section here with the player -- active class. So you see that this first section, which is for player 0, right now has this class because player 0 is always the first player. But then as we switch to the other player, we want to remove that class from here and basically put it here on the other player. Okay, so let's do that. And as always, we will start by selecting these two players. And this time is actually a class. So player 0 class, in player 1 class. So let's do that here and do that as the first. So const player 0 element document dot query selector, and now we need the dot for the class name. So that's player dash dash 1, and I'm just copying it here. I'm too lazy. And this one here is actually player 0. So 0 and 1 right here. And now let's actually change their class names. So the player active class. So down here. And for that, I will now show you yet another method that's available on the class list property. So we already saw, well, actually, let's start typing first. So player 0 element dot class list. And we already saw the remove method. We saw the add method, but now I will show you the toggle method. So we will use toggle now. And what toggle will do is that it will add the class if it is not there. And if it is there, it will remove it. Okay. So we could do that manually also by checking if the class is there and only removing it if it is. But using toggle takes that work away from us. So actually, we could have used this toggle method in the previous project of the pop-up, but back then I actually wanted to show you the contains method. Remember that? But now, again, we will use toggle here because it is easier. And so now we simply have to add this player active class, or actually to toggle it. So if we do that on both, then it will work. Because on player 0, it will remove the class if it's there, and if it's not, it will add it. And the same thing on the other player. And since we start with the player active class on only one element, so only on player 0 here, then toggling both at the same time will ensure that it's only ever on one of the elements at once. So let's now check that out. Just to make sure, reload it here. And let's wait for it. It's taking a lot of time. And yes, so we switched the active player and now it's also nicely visible. And yes, we changed it back as well. And so that works beautifully. Great job. And now, basically, the only thing that's missing to actually make this game work is to hold the current score. And so that's going to be the topic of the next video. And now let's implement the feature of a player holding the current score. And let's again look at our flowchart here. And once again, this flowchart basically represents the division of our big problem, which is to implement this game, into smaller problems, which are all of these green, basically, sub-problems here. Now, what we are going to implement is the functionality of holding the score. And remember, that happens whenever the user clicks on that button to hold the score. So when that happened, we want to add the current score to the total score, right? So let's see that in the demo version here. So I'm reloading here. And then as I roll the dice, let's roll it again. So I have 8 current points. And as I click hold, you see that these points will basically be transferred to my global score. So in this case, 0 plus 8 will then be 8. And then we change to the next player. And so that's exactly what we have here in the flowchart, followed by switching the player. Now, this switching of player only happens when the score is still below 100, because when the score is at least 100, then the current player wins. Okay, and so now let's implement basically this logic that we have here. Okay. So we want something to happen when the user clicks on this hold button, so button hold, right? So let's take that and add an event handler. So button hold dot add event a listener. Once more on the click, and then once more our function value here, the function that will be executed as the user clicks the button. And so let's again write some comments to say what we want to happen here. First, add current score to the score of the active player. So active player's score. And then check score is already at least 100. And if so, then basically finish the game. And if not, then switch to the next player. All right, so now we want to define the current player's score. And remember how I told you in the last lecture that to store the scores, we are using this scores variable. And this scores variable is this array, which at the same time holds the score of player 0 and player 1. So player 0 at position 0 and player 1 at position 1. And so now we can use the active player variable to get the correct score of the current player. So scores at position active player, so that's what I just explained, will be equal that score plus the current score. So we say plus equal the current score. So again, when it's player 1, then this will be scores 1. But when player is 0, then it will be scores 0. And then we take that value and add the current score to it and assign it again to scores at the current active player. So just to make it 100% clear, if player is currently 1, then this would be this. Okay, so scores at 1 is equal to scores at 1 plus the current score. So I'm just going to leave it here as a comment so that you really understand what's happening here. So we changed that score, and now we of course need to display it as well. And so now we will do it in a similar way to as we did up here, where we basically select it based on the active player. So document.get element by ID. And now let's just check out again the name of the element. So that's score 0 and score 1. So these are the IDs. And again, we will replace 0 or 1 here dynamically. So again, a template string, current, and then here the active player. So when it's player 0, it will be current 0. And so that first score will be selected. And when it's player 1, well, then the other element will get selected. And then we can set the text content to the score of the active player. So scores, active player. Give it a save. And so now our game should almost be finished. We will be able to play it basically until infinity, but it should work. But actually, it would not yet work because we haven't yet switched to the next player here. So right now, as we hold the score, we are not switching. So we are not checking if the score is greater than 100, but we are also not switching. And so let's leave that checking if the score is 100. So basically checking if the player won the game. Let's leave that for the end. And for now, let's just switch to the next player, because usually that is what needs to happen. So switching to the next player is this code. So it's going to be the exact same thing. We still need to reset the current score to 0 here, both in our program and also on the user interface, which is what we do here, we need to switch the player from 0 to 1 or from 1 to 0, and we need to toggle the player active classes to show which player is the active one. So all of this code here, we will need it again down here. So should I just go ahead and copy it now? And I hope that you already know the answer for that. So that would violate the don't repeat yourself principle. And so what I'm going to do is to simply take this code and put it into a function. And then I will call that function in both the places where I need this code to execute. So I'm cutting the code now here. And then up here, I will create a function. So I'm going to call this one switch player equals a function, and this function does not need any argument at all or any parameter because the code is exactly the same in both situations. So usually when we are refactoring something like we are essentially doing here, then there is many times like a small thing that changes in the code. And then it's very useful to have a parameter so that when we call the function, we can specify what changes. So that's what we did when we refactored some code in the first project. But here, nothing changes. All we want to do is to simply repeat this code. And so we don't need any parameters and we don't need to return anything. This is simply just a reusable piece of code. And so let's call that here. Switch player, call it here, and call it here. And again, we will then put this in the if-else statement later once we check for the score to check if the player has won. But now we just want to make the game work. And so, of course, after we hold the score, we need to switch to the next player. So exactly as it says here in our flowchart, except that we're now skipping for now this part. So we're going from add current score to total score directly to switch player. Okay, and so now we should be ready to test our own version here. So now I have 6, let's hold it, and okay, something went wrong here indeed, because our score is still at 0, and that should not be happening. So let's check it out. And let's start by adding a console.log here, just to see if we are actually catching this event. So if we are handling it correctly. So hold button. So as I mentioned in the previous section, we really use console.log all the time to debug any kind of situation. And I could have just erased this part of the video showing you just the final solution, but I think it's a good idea to show you the debugging process right here in the video as well. So let's play and let's hold. And so we got the hold button here. So something worked. And actually, yeah, also the background color changed sides here and the current score was erased. So we already knew actually that something was indeed happening, but let's now actually find out what is going on here. And so now I want to log this value. Okay, so I'm basically now logging the score of the active player, and let me actually do that after I assigned it. So after we changed it, I will want to take a look at it in the console. Maybe the only problem is that it's not showing up in the element, so as the text content. But maybe the score itself is correct, and then we can see it in the console. So let's play again, and we already changed the player. And now I hold, and indeed, here we get 9. So that's the score that we had before. Let me show that to you again, and reload. So I roll the dice 3, now I have 8, and watch what happens in the console as I click hold. And so indeed, I get the value of 8, which means that the score is actually correctly calculated. Now I just need to fix the part where it is not displaying here in this element. So here I selected current, So let me see. Oh, and yeah, that is of course a problem. It needs to be score. So it's score 0 and score 1, not current 0 and current 1. So that was the mistake. So here it is score. And now we can get rid of this console.log. And actually also of the other one that we have with the dice roll. So just make the code a bit better. Now I can close it up, roll the dice, and now as I hold, that should appear there, the number 4. And yes, now it works. Great. So let's play here a little bit. So now we accumulated 13 points. So let's hold them to end up with 17. And indeed, that works. Now let's hold these 4. And so I think this game is really a lot of fun to play, especially if you try it with someone else, which I actually did a couple of times as I was preparing this game, and I can tell you that it's really fun. But now let's actually get to the final part of this lecture, which is to check if someone reached the final goal of 100 points. And so if that happens, the game is over and we should not be able to click any of the buttons anymore. And we also want to assign a special class to the winner player to make it really obvious that that player has won. Okay, so let's add that check now. And so that shouldn't be too hard. So if scores at active player, so remember that is always here the score of the player that is currently active. So if that is greater or equal than 100, then the player has won. So this is where we finish the game. So when we finish the game, we want to assign a player winner class. And let me show that to you here in the CSS. So yeah, it's this one, player winner, which has this darker background color. So let me copy that. Paste that here. And now let's then select actually the player. So document.query selector. And let's again take a look at the code here, just so we don't make any mistakes. And so the player is really a class, player dash dash, and then the number of the active player. So that is player dash dash and active player. And then onto this element, we want to take the class list and add this class name that we just copied from our CSS. And then we also want to remove the active player class. Okay, so where is that? Yeah, so when we switch the player, we turn on this player active. Right, but now we then need to remove that because otherwise we will have the active player class at the same time as the player winner class. So let's fix that. But we simply need to select the same element again. And then here we remove player active. Okay, I hope that made sense. And now let's test it. And to make it a little bit faster, let's actually test it just with 20. Otherwise, it's going to take forever to reach that 100 points. All right. Well, and before we do that, let's now actually put this switching the player into the else block. Okay. So when the game finishes, we of course do not want to switch the player, but if it does not, only then we do switch the player. And remember that 20 points is enough to win. So let's roll the dice a couple of times. 11, so we're almost there. That was close with 16. And so now we should have enough. So if we hold now, then 10 plus 11 here is 21. So that's over 20. And so now this should then show us the winner player class. Well, that didn't really happen. That's weird. If I keep clicking here, then this number keeps getting added. And let me see in the HTML if the class wasn't added, but actually it was not. So we still have the active player, and the winner class is nowhere to be found. So let's check that. Oh, and here we actually have the problem. So I did a mistake that I told you before not to make, which is when we use query selector, we need an actual selector. So here we are selecting a class, and so we're missing the dot here and here. So only when we get element by ID, then we do not specify the selector, we only specify the ID name itself. But when we use query selector, this needs to be a query. And so if we are selecting based on a class, we need the dot here. And so that should be fixed now. But this is great to show you that mistakes like this happen in development all the time. So if you do this yourself, then really don't beat yourself up, because that's just completely normal, as you're seeing here. I didn't plan these mistakes. Anyway, now we have 16 plus 5 is 21, so that should be enough to win the game. Now we really got this winner class here showing that player 1 won the game. So this is now red too, and yeah, the dark background here too. Now the problem is first that we're still showing the dice, so we want to get rid of that. But even worse is that we can still click on these buttons. We can actually still keep playing the game. So you see that everything works the same. And now this player also won. They also have 22 points. But we still can keep playing the game. So of course, that is not good. So that is the next thing that we need to solve. And let's think how we could solve this. And for me, I think the easiest solution is to create a variable that holds the state of the game. So if we are still playing or not. So this is going to be a state variable, which kind of tells us the condition of a system. And in this case, the condition will be, is the game playing or not? And so if the game is playing, then we can click these buttons and then everything will work as normally. But then as soon as the game is finished, we will say that the game is no longer playing. And then we can no longer click on these buttons. All right. I hope that sounds good to you. So let's implement it. And so what I will do here is say, let playing, and now this will be a Boolean value. And so we start with true. So in the beginning of the game, we are of course playing. And so playing is true. And then when we finish the game, we will set playing to false. So that's in this case. So finish the game. And the first thing that we're going to do is to set playing to false. Okay. Now this in itself will of course not yet do anything. So we only defined whether the game is playing or not, but none of our code is reacting to that. So remember that we only want to be able to click on these buttons once we are playing. And so let's define that. So let's go to the first button, which is the button roll. And so basically what we can do now is that all of this logic that we have here should only be executed if we are playing. All right, so that's simple enough. So let's just say if playing, then do all of this. So let's remove that from here and put it down here. And then as we save it, Prettier will take care of indenting all the code and put it nice and beautiful. Okay. Now, playing here is a Boolean variable, and so that's why we don't have to write any condition like this, for example, because again, playing itself is already a Boolean, so we don't need to check if true is equal to true. And so now when we click on this button while the game is no longer playing, then nothing will happen. And so that's the beauty and the goal of having this playing variable. And now let's simply do the same for this other button. Okay, so if playing, then do all of this. And again, I'm deleting it from here and simply writing it down here. Give it a save, and then it will be beautiful and back to normal. And so now, as soon as one player wins, we will finish the game and set playing to false. And so the next time we click on any of these buttons, then here playing will be false, and then none of this code will be executed. And the same here for this button for rolling the dice. So I hope you were able to follow that logic, and so maybe you can use this kind of logic in your own projects as well. And this is actually the reason why it's so cool to start building projects as games. Because in games, we need a lot of this type of logic. And so it's really fun to demonstrate all these different aspects that are quite common actually in programming. So a state variable like this playing here, is very usual in programming. And so you can start to get used to sometimes needing a variable like that. And now let's try it out again. And remember that we still can win the game at 20. And just to make sure, let's reload. And now as I roll the dice, so let's hold here. And let's see if we can do it in one run. Oh, and we can. So we are at 20. And now let me hold. And now I won the game here. And now let's see what happens when I click. And nothing happens. The same for hold. So these buttons, of course, like you can still click them, but nothing happens. All right, that's awesome. There's just one last thing to do, which is to get rid of this dice here. So let's go back one last time. And so that also happens here when we finish the game. So remember that we displayed the dice up here when we roll the button. And so let's just copy this and basically add this hidden class back on. So right here, for example. And so now instead of removing it, we just add it back. Okay, give it a save. And let's try to do it fast again. And yes, now we should win the game and the dice is gone. Awesome. So we are almost done here with this project. So our game works really great. All there's left to do now is to implement this new game button here. So we could of course play again by reloading the page, but it's always nice to have a button to simply reset the game. And so let's move on to the next video and do that to finish this project. Welcome to the last lecture of this project and of this section. And in this one, we're going to implement the functionality of resetting the game at any point in time. So what we're looking for when we click on this button here is to remove the winner class and to set all the scores of all the players here back to 0. So all the total scores, this and all the current scores should also be put back to 0. So essentially, we need to set back all the initial conditions of the game. Now, we already did something similar to this in our first game, and so maybe this is a good opportunity to leave this as a challenge for you. And this one will be a little bit more difficult than the one in the Guess My Number project, but you can still try to do it. So what I want you to do is when we click on this button, as I just mentioned, reset all the initial conditions of the game. And it doesn't matter if your solution will be dramatically different from mine. Okay, I just want you to try and I want you to write code on your own. No matter if you actually achieve the goal in the end or not. That is not the point right now. So just pause the video here, please, and try to do at least part of this on your own. So hopefully you had a great time doing that. And so let's now go back together here and do it ourselves. So we need this button new. And so once more, we will add an event handler on there. So that's button new dot add event listener, waiting for a click, and then we want to execute whatever happens here. So as I said, we need to reset all the scores. So let's start with that. And I guess I already selected these up here. So that is score L0 and score 1L. Okay, so these two scores, we want to set them back to 0. Now, actually, we already did that here. So let's just copy it for now. Okay. Then we also need to set all the current scores back to 0. So that is current 0L and current 1L. So current 0L equal 0, and then current 1L also back to 0. Next up, we need to remove the winner class. So this dark class that we have here, and now it's going to disappear because as I move out from this window, it will save and then it will reload. So I'll only go half. But you see this dark class, the winner class, needs to disappear. And so let's do that. And so that should be player 0 element dot class list dot remove and player winner. Now, of course, we do not know which player won the game. And so we have to do this on both the player elements. Okay? And that's no problem at all. So we already know that only one of these two elements will have this class, but we can still tell JavaScript to remove a class even if it's not there. So JavaScript will happily do that. Then next up, we also need to remove the active classes on both players, because again, we do not know at this point which one is the active player. So let's just remove them too. Now we'll just copy it. So player winner here is both active. And then we also need to set the first player to be the active player. So let's do that. And in fact, let me just change the code here in this line, because there's no need to remove it from player 0. Because, well, player 0 should be the active player in the beginning. And so there's no need of removing it and then adding it back. So I will simply add it. All right. And if it was already there, then JavaScript will not add it again. Okay. So just like with removing, so if the class is not there, but we are still telling JavaScript to remove it, it will not give us an error. It will simply do nothing. And if we add a class that's already there, it will not add a second one. And so here, it's not a problem. So even if the class is already there, by saying add player active, we will not add another one. Okay. All right. And that's it for the visible part of the user interface. So we changed classes here and we manipulated the content. But of course, we also need to set our internal state variables back to the initial state. So basically what we need to do is to add these scores back to 0, set the current score back to 0, set the active player back to the first player, and also basically start the game again by setting playing back to true. So what should we do here? Should I simply take this code and copy it to the other function? And you already know the answer to this question, don't you? So of course not. Instead, we will create a function which contains this code together with the code that is already down here. Okay, and then we will create a new function with all of this. And I'm going to call this function init, which stands for initialization. So let me cut this code here and create this function here. So again, calling it init which stands for initialization. And this is once again just a function that serves as a reusable piece of code. So we need no arguments here. Okay, so this is the init function, which will initialize our game. And now we also want this code in there as well. And in fact, we want all of this code. So all of the starting conditions should now be set here in this init function. So let's grab this and paste it here. Okay, and now these two are duplicate. So they're already down here. So this is the same as this and this. So let's remove it from here. And then let's move this one down a little bit. Okay, and again, I used Option or Alt arrow down to move the line like that. Give it some space here. And okay, so this is our initializing function. Now, when do we want this function here to be executed? We want it in two situations. So whenever we load the page for the very first time, or also when that button is clicked that we were just working on, right? So of course, we need the scores to be 0 at the beginning, together with the current score and the active player and all of that. And so we used to have this code outside of any function. And so it was executed right when the file was loaded. But now this code is inside of this function. And right now we are not calling this function here at any point. And so this code in here will not get executed as the page loads. Okay, so right now, as we load the page, you will see that it has these weird starting conditions that it had initially. So showing these random numbers and showing the dice. And nothing is going to work now if I click any of this. And so that's because our initial variables here are not set, because this function does not run on its own. And so, as you might guess, the solution to that is to simply run it. So as we now load this script, then JavaScript will find this function definition, and then it will find this line of code which runs the function. And so then, by that time, all of this code here will be executed, and then our game will work just fine. So let me show that to you. And so now we are back to looking normal, and our game should work. Oh, and actually nothing is working. So let's take a look at the console. But I can already guess what is happening. Okay. And so, yeah, we see here from these errors that these variables are not defined. Playing is not defined. And yeah, but it's not the only variable that is not defined. And so let me show you the error here. So this error comes from something that we already talked about very briefly before, but I didn't really go into yet. That's because in the next section, we will really get deep into something called scoping. Okay? But let me just explain to you right now that these variables that I defined here, they're only available inside of this init function. Okay? So again, this scores, this current score, this active player, and this playing, all of these variables, I declared them in here inside of this function. And so because of that, they are not accessible outside of the function. So we say that they are scoped to this init function because this is where I declared them. And so the solution is to declare these variables outside of any function, but without any value. And so it's then in the init function where they will really be declared. Okay? And if that doesn't make 100% sense, it will make after the next section where we will really understand deeply how scoping like this works. Anyway, let's now declare these 4 variables here outside. So I will use let now for all of them. So scores, and then remember, as we already did in the fundamentals section, we can define a bunch of empty variables by using commas here. So current score, active player, and playing. So now these variables, they basically live outside here. And so what we do here then is to essentially reassign them a value. So we need to get rid of these lets here, because that would then create new variables here. But again, that's not what we want. We want the variables basically to live out here, and then in the init function, we only reassign their values. So that's very different. So declaring a variable is not the same as assigning them a value, okay? And so right now here, we only assign them a value, but they still live outside here, and that's why they are then accessible in every function everywhere. All right. And now just to finish, we also need to use this init function, of course, on the reload function. So on this event handler here. And so, just like before, here we now do not declare this anonymous function, but instead we pass in the init function, which again is really just a value. And so it's perfectly okay to pass this value into this other function. And just keep in mind that we do not call this function here. It is JavaScript who will call the init function as soon as the user clicks on the new button. And so now everything will work just fine. So we get 5 down here. And let's hold it now. And indeed, we moved to the other side. And with this, we should win the game now. So let's see. Hold, and indeed. And now here comes the test to see if this button works. And indeed, it does. And we can restart the game just like this. This time, let's player 2 win the game here, just to see if it works there as well. So that's enough points. And indeed, it works. But what matters is now that as we click the new game button, everything is back to normal and player 1 is back to being the current player. All right, great. And with that, we actually finished the game, almost finished. Let's set the threshold here back to actually 100 points. So that is the limit here on which we want this game to finish. But with that, the game is ready and feature complete. And yeah, I hope you're happy with it. So congratulations, great job for making it to the end of this section. That's already a really great achievement. And I hope that you can see that you already learned a lot of new stuff here. And now you can go ahead and play this game with your friends, and you can tell them that actually you coded this by yourself. So the code you wrote on your computer is what made this program possible. It's what makes this really come to life, so to say. So how cool is that? And maybe even your friend will then become interested in programming and you can do this journey together. But anyway, with this, we now really finished the fundamentals part of this course. And once again, I really hope that you can see that you already learned a lot of new concepts here in this last couple of hours. So congratulations once again, and I see you in the next section, which is really important because there you're going to learn how JavaScript actually works behind the scenes. In this section, we will take a look behind the scenes of JavaScript and learn how the language actually works. So throughout this section, we will take your basic knowledge of JavaScript and elevate it to a completely new level, where you will then understand exactly how everything that you learned before actually works under the hood. And this is actually extremely important, because this knowledge will really empower you to write better code and to understand other developers' code. And so, in the end, it will make you a better, more confident, and more successful developer. Now, I'm telling you all this because some people find this kind of theory lectures boring for some reason. But they are really not. And I actually invested well over a month into building this section alone. And so that might show you just how crucial this information is. And finally, knowing how JavaScript really works will also set you apart from the competition, because many other junior developers simply don't know about much of this stuff. So don't be scared of theory, and let's get started. As an introduction to this theory section, I want to start with a very cool and very high-level overview about the JavaScript language, just so you get a first overview of most of the things that we need to learn in order to eventually master JavaScript. And this is going to be a long lecture, so get ready for a crazy ride. And I want to start by coming back to that first definition that I gave you on JavaScript, where I told you that JavaScript is a high-level, object-oriented, multi-paradigm programming language. Now, this is of course 100% correct, but it's also really just the surface, the tip of the iceberg. So what about this definition? JavaScript is a high-level, prototype-based, object-oriented, multi-paradigm, interpreted, or just-in-time compiled, dynamic, single-threaded, garbage-collected programming language with first-class functions and a non-blocking event loop concurrency model. Wait, what? Is this some kind of joke? Well, yeah, it kind of is, actually. I just packed as much information as possible about JavaScript into one unreadable sentence just for fun. But besides fun, this also gives us a great opportunity to unpack all of this in order to get a first peek into all the stuff that we're going to learn about JavaScript throughout the course. And this is not to intimidate you. It's really not. I just want you to get the big picture before really getting started, and also introduce some topics that are just good to know. Because getting the big picture before diving deep is, in my opinion, an amazing learning technique. So with that being said, let's unpack this now a little bit. So these are the 9 JavaScript topics that we're briefly going to talk about in this lecture, slightly reordered. And starting with the high-level part, as you might already know, every program that runs on your computer needs some hardware resources, such as memory and a CPU, to do its work. Now, there are low-level languages, such as C, where you have to manually manage these resources. For example, asking the computer for memory to create a new variable. On the other side, you have high-level languages, such as JavaScript and Python, where we do not have to manage resources at all, because these languages have so-called abstractions that take all of that work away from us. This makes the language easier to learn and to use, but the downside is that programs will never be as fast or as optimized as, for example, C programs. Now, one of the powerful tools that takes memory management away from us developers is garbage collection, which is basically an algorithm inside the JavaScript engine which automatically removes old unused objects from the computer memory in order not to clog it up with unnecessary stuff. So it's a little bit like JavaScript has a cleaning guy who cleans our memory from time to time so that we don't have to do it manually in our code. Next up, JavaScript is an interpreted or just-in-time compiled language. And again, we will learn more about this in this section, but what you need to know for now is that the computer's processor only understands zeros and ones. That's right. Ultimately, every single program needs to be written in zeros and ones, which is also called machine code. And since that's not really practical to write, is it? We simply write human-readable JavaScript code, which is an abstraction over machine code. But this code eventually needs to be translated to machine code, and that step can be either compiling or interpreting. This step is necessary in every single programming language because no one writes machine code manually. In the case of JavaScript, this happens inside the JavaScript engine. Now, one of the things that makes JavaScript so popular is the fact that it's a multi-paradigm language. In programming, a paradigm is an approach and an overall mindset of structuring our code, which will ultimately direct the coding style and technique in a project that uses a certain paradigm. And this definition still sounds kind of abstract, but don't worry, it will become more clear as we move on. Now, three popular paradigms are procedural, object-oriented, and functional programming. So procedural programming is what we've been doing so far, which is basically just organizing the code in a very linear way, and then with some functions in between. Now, about object-oriented programming and functional programming, I will talk about them in a second. Also, we can classify paradigms as imperative or as declarative. But again, more on that later. Now, many languages are only procedural or only object-oriented or only functional. But JavaScript does all of it. So it's really flexible and versatile, and so we can do really whatever we want with it. It's our choice. We can use whatever paradigm we want. And in this course, I will show you how to use all of them. So, about the object-oriented nature of JavaScript, it is a prototype-based object-oriented approach. Now, what does that mean? Well, first, almost everything in JavaScript is an object, except for primitive values such as numbers, strings, etc. But arrays, for example, are just object. And we already saw that in practice, right? Now, have you ever wondered why we can create an array and then use the push method on it, for example? Well, it's because of prototypal inheritance. Basically, we create arrays from an array blueprint, which is like a template, and this is called the prototype. This prototype contains all the array methods, and the arrays that we create in our code then inherit the methods from the blueprint, so that we can use them on the arrays. And this, what I just explained to you, is actually a huge oversimplification, which might still sound confusing, and that's the reason why there is a whole section on object-oriented programming with JavaScript later in the course. But since this is a big overview lecture, I wanted to first introduce this topic right here. Next up, JavaScript is a language with first-class functions, which simply means that functions are treated just as regular variables. So we can pass functions into other functions, and we can even return functions from functions. And this is extremely powerful, because it allows us to use a lot of powerful techniques, and also allows for functional programming, which is one of the paradigms that we just talked about before. And in fact, we have already used the power of first-class functions without knowing that they are called first-class functions. So remember this piece of code that we wrote for closing the modal window that we built before. So right here, we passed the close modal function into the add event listener function as if it was just a regular variable, right? And actually, not all languages have first-class functions, but JavaScript has, and it is amazing. Believe me, it's really, really helpful. Next, I said that JavaScript is a dynamic language, and dynamic actually means dynamically typed. So as we've already seen, in JavaScript, we don't assign data types to variables. Instead, they only became known when the JavaScript engine executes our code. Also, the type of variables can easily be changed as we reassign variables. And this is basically what dynamically typed means. Now, there is a lot of controversy if this is good or bad, but this is just how it works. Now, the same is not true for most other programming languages, where we have to manually assign types to variables. And this then usually prevents bugs from happening, which is the reason why many people say that JavaScript should be a strongly typed language as well. And if you yourself want to use JavaScript with types, then you can always look into TypeScript. But anyway, let's now finally talk about the single thread and the non-blocking event loop concurrency model. Now, this is a really complex topic, and probably the most complex one of the whole course, which is why it's kind of at the end of the course. And therefore, I'm not going to go into specifics here just yet, but instead I will just define some things here. First, what actually is a concurrency model? Well, it's just a fancy term that means how the JavaScript engine handles multiple tasks happening at the same time. Now, okay, that's cool, but why do we need that? Well, because JavaScript itself runs in one single thread, which means that it can only do one thing at a time. And therefore, we need a way of handling multiple things happening at the same time. And by the way, in computing, a thread is like a set of instructions that is executed in the computer's CPU. So basically, the thread is where our code is actually executed in the machine's processor. All right, but what if there is a long-running task, like fetching data from a remote server? Well, it sounds like that would block the single thread where the code is running, right? But of course, we don't want that. What we want is so-called non-blocking behavior. And how do we achieve that? Well, by using a so-called event loop. The event loop takes long-running tasks, executes them in the background, and then puts them back in the main thread once they are finished. And this is, in a nutshell, JavaScript's non-blocking event loop concurrency model with a single thread. It sounds like a mouthful for sure, but in the end, it really just compresses to this. Just keep in mind that, again, this is a huge oversimplification that we will come back to. All right, and this actually rounds up this overview lecture. I know there was a ton of stuff to take in, but I hope that you still learned a thing or two here. So I talked about the JavaScript engine in the last lecture, but what is that engine actually? And what is a JavaScript runtime? Also, how is JavaScript code translated to machine code? So that's just some of the topics that we talked about in the last video, and so now let's find out how they work in this lecture. So a JavaScript engine is simply a computer program that executes JavaScript code. There are a lot of steps involved in doing that, but essentially executing JavaScript code is what an engine does. Now, every browser has its own JavaScript engine, but probably the most well-known engine is Google's V8. The V8 engine powers Google Chrome, but also Node.js, which is that JavaScript runtime that we talked about in the beginning of the course. So the one that we can use to build server-side applications with JavaScript, so outside of any browser. And of course, all the other browsers have their own JavaScript engines, which you can look up online if you're interested. Anyway, it's quite easy to understand what an engine is, but what's most important is to actually understand its components and how it works. So any JavaScript engine always contains a call stack and a heap. The call stack is where our code is actually executed using something called execution contexts. Then the heap is an unstructured memory pool which stores all the objects that our application needs. All right, so with this look at the engine, we have answered where our code is executed. But now the question is how the code is compiled to machine code so that it actually can be executed afterwards. Well, let's find out. But first, we need to make a quick computer science side note here and talk about the difference between compilation and interpretation. So in the last lecture, we learned that the computer's processor only understands zeros and ones, and that therefore every single computer program ultimately needs to be converted into this machine code. And this can happen using compilation or interpretation. So in compilation, the entire source code is converted into machine code at once. And this machine code is then written into a portable file that can be executed on any computer. So we have two different steps here. First, the machine code is built, and then it is executed in the CPU, so in the processor. And the execution can happen way after the compilation, of course. For example, any application that you're using on your computer right now has been compiled before, and you are now executing it way after its compilation. Now, on the other hand, in interpretation, there is an interpreter which runs through the source code and executes it line by line. So here we do not have the same two steps as before. Instead, the code is read and executed all at the same time. Of course, the source code still needs to be converted into machine code, but it simply happens right before it's executed and not ahead of time. Now, JavaScript used to be a purely interpreted language, but the problem with interpreted languages is that they are much, much slower than compiled languages. This used to be okay for JavaScript, but now with modern JavaScript and fully fledged web applications that we build and use today, low performance is no longer acceptable. Just imagine you were using Google Maps in your browser and you were dragging the map, and each time you dragged, it would take 1 second for it to move. That would be completely unacceptable, right? Now, many people still think that JavaScript is an interpreted language, but that's not really true anymore. So instead of simple interpretation, modern JavaScript engine now use a mix between compilation and interpretation, which is called just-in-time compilation. This approach basically compiles the entire code into machine code at once and then executes it right away. So we still have the two steps of regular ahead-of-time compilation, but there is no portable file to execute, and the execution happens immediately after compilation. And this is perfect for JavaScript, as it's really a lot faster than just executing code line by line. Now, I skimmed over some details here, but this is really all you need to know. Anyway, let's now understand how this works in the particular case of JavaScript. So, as a piece of JavaScript code enters the engine, the first step is to parse the code, which essentially means to read the code. During the parsing process, the code is parsed into a data structure called the Abstract Syntax Tree, or AST. This works by first splitting up each line of code into pieces that are meaningful to the language, like the const or function keywords, and then saving all these pieces into the tree in a structured way. This step also checks if there are any syntax errors, and the resulting tree will later be used to generate the machine code. Now let's say we have a very simple program. All it does is to declare a variable like this. And this is what the AST for just this one line of code looks like. So we have a variable declaration, which should be a constant with the name x and the value of 23. And besides that, there is a lot of other stuff here, as you can see. So just imagine what it would look like for a large, real application. And of course, you don't need to know what an AST looks like. This is just for curiosity, okay? Now, sometimes I get asked if this tree has anything to do with the DOM tree, and the answer is a very clear no. So, this tree has absolutely nothing to do with the DOM. It is not related in any way. It's just a representation of our entire code inside the engine. Anyway, the next step is compilation, which takes the generated AST and compiles it into machine code, just as we learned in the previous slide. This machine code then gets executed right away. Because remember, modern JavaScript engine use just-in-time compilation. And remember, execution happens in the JavaScript engine's call stack. But we will dig deeper into this in the next lecture. Alright, so far so good. We have our code running, so we can finish here, right? Well, not so fast, because modern JavaScript engines actually have some pretty clever optimization strategies. What they do is to create a very unoptimized version of machine code in the beginning, just so that it can start executing as fast as possible. Then, in the background, this code is being optimized and recompiled during the already running program execution. And this can be done multiple times, and after each optimization, the unoptimized code is simply swapped for the new, more optimized code without ever stopping execution, of course. And this process is what makes modern engines, such as V8, so fast. And all this parsing, compilation, and optimization happens in some special threads inside the engine that we cannot access from our code. So completely separate from the main thread that is basically running in the call stack, executing our own code. Now, different engines implement this in slightly different ways, but in a nutshell, this is what modern just-in-time compilation looks like for JavaScript. And the next time someone tells you JavaScript is an interpreted language, you just show them this slide so that they can learn how it really works. Alright, so we looked at the JavaScript engine and how it works behind the scenes in quite some detail. Now, to round off this lecture, let's also take a look at what a JavaScript runtime is, and in particular, the most common one, which is the browser. And by doing this, we can get the bigger picture of how all the pieces fit together when we use JavaScript. And so this is a really important slide. So, we can imagine a JavaScript runtime as a big box or a big container which includes all the things that we need in order to use JavaScript, in this case, in the browser. And the heart of any JavaScript runtime is always a JavaScript engine. So exactly the one we've been talking about. That's why it makes sense to talk about engines and runtimes together. Without an engine, there is no runtime, and there is no JavaScript at all. However, the engine alone is not enough. In order to work properly, we also need access to the web APIs. And we talked about web APIs before, remember? So that's everything related to the DOM, or timers, or even the console.log that we use all the time. So essentially, web APIs are functionalities provided to the engine, but which are actually not part of the JavaScript language itself. JavaScript simply gets access to these APIs through the global window object. But it still makes sense that the web APIs are also part of the runtime. Because, again, a runtime is just like a box that contains all the JavaScript-related stuff that we need. Next, a typical JavaScript runtime also includes a so-called callback queue. This is a data structure that contains all the callback functions that are ready to be executed. For example, we attach event handler functions to DOM elements, like a button, to react to certain events, right? And these event handler functions are also called callback functions, okay? So as the event happens, for example a click, the callback function will be called. And here is how that actually works behind the scenes. So the first thing that actually happens after the event is that the callback function is put into the callback queue. Then, when the call stack is empty, the callback function is passed to the stack so that it can be executed. And this happens by something called the event loop. So basically, the event loop takes callback functions from the callback queue and puts them in the call stack so that they can be executed. And remember how I said in the last lecture that the event loop is how JavaScript's non-blocking concurrency model is implemented? Well, here is an overview of how that works. Now, we will go over why this makes JavaScript non-blocking in a special lecture about the event loop later in the course, because this is really a fundamental piece of JavaScript development that every developer needs to understand deeply. All right, so as I already said, the focus in this course is on JavaScript in the browser, and that's why we analyzed the browser JavaScript runtime. However, it's also important to remember that JavaScript can exist outside of browsers, for example in Node.js. And so here is what the Node.js JavaScript runtime looks like. It's pretty similar, but since we don't have a browser, of course we can't have the web APIs, because it's the browser who provides these. Instead, we have multiple C++ bindings and a so-called thread pool. Now, details don't matter here at all. I just want you to know that different JavaScript runtimes do exist. All right, cool. That's all I had to tell you about JavaScript engines and runtimes. In the next lecture, we will learn how JavaScript is executed in the call stack. In this lecture, let's answer the question, how is JavaScript code executed? We already know that it happens in a call stack in the engine, but let's dig a bit deeper now. And let's start by supposing that our code was just finished compiling, just in a way that we learned in the last lecture. So the code is now ready to be executed. What happens then is that a so-called global execution context is created for the top-level code. And top-level code is basically code that is not inside any function. So again, in the beginning, only the code that is outside of functions will be executed. And this makes sense, right? Functions should only be executed when they are called. And actually, we saw this happening already in our pick game project. So there we had an init function which initialized our entire project, but in order to actually initialize the game the first time that the page loaded, we needed to call that function immediately in our top-level code. And so that's what I mean here. But anyway, we can also see what top-level code is in this example here. So this name variable declaration is clearly top-level code, right? And therefore, it will be executed in the global execution context. Next, we have two functions, one expression and one declaration. So these will also be declared so that they can be called later. But the code inside the functions will only be executed when the functions are called. Okay, so we know that a global execution context is created for top-level code. But now, what exactly is an execution context? Well, an execution context is an abstract concept, but I define it basically as an environment in which a piece of JavaScript is executed. It's like a box that stores all the necessary information for some code to be executed, such as local variables or arguments passed into a function. So JavaScript code always runs inside an execution context. And to make this a bit more intuitive, let's imagine you order a pizza at a takeaway. So usually that pizza comes in a box, right? And it might also come with some other stuff that is necessary for you to eat the pizza, such as cutlery or a receipt, so that you can actually pay for the pizza before eating it. So in this analogy, the pizza is the JavaScript code to be executed, and the box is of course the execution context for our pizza. And that's because eating the pizza happens inside the box, which is then the environment for eating pizza. The box also contains cutlery and the receipt, which are necessary to eat the pizza, or in other words, to execute the code. Okay? I hope that made sense and made the concept of execution context a little bit more clear. Now, in any JavaScript project, no matter how large it is, there is only ever one global execution context. It's always there as the default context, and it's where top-level code will execute. And speaking of execute, now that we have an environment where the top-level code can be executed, it finally is executed. And there is not a lot to say about the execution itself. It's just the computer's CPU processing the machine code that it received. Okay, and once this first code, so the top-level code, is finished, functions finally start to execute as well. And here is how that works. For each and every function call, a new execution context will be created containing all the information that is necessary to run exactly that function. And the same goes for methods, of course, because they're simply functions attached to objects, remember? Anyway, all these execution contexts together make up the call stack that I mentioned before, but more on that in a second. Now, when all functions are done executing, the engine will basically keep waiting for callback functions to arrive so that it can execute these. For example, a callback function associated with a click event. And remember that it's the event loop who provides these new callback functions, as we learned in the last lecture. Alright, so we know now what an execution context is, but don't really know what it's made of, so what's inside of it. And so let's find that out next. And the first thing that's inside any execution context is a so-called variable environment. In this environment, all our variables and function declarations are stored, and there's also a special arguments object. This object contains, as the name says, all the arguments that were passed into the function that the current execution context belongs to. Because remember, each function gets its own execution context as soon as the function is called. So basically, all the variables that are somehow declared inside a function will end up in its variable environment. However, a function can also access variables outside of the function. And we have already seen that in action throughout this course, especially in the projects of the previous section. And this works because of something called the scope chain. And we will learn all about scoping and the scope chain later in this section. But for now, what you need to know is that the scope chain basically consists of references to variables that are located outside of the current function. And to keep track of the scope chain, it is stored in each execution context. Finally, each context also gets a special variable called the this keyword. And once more, there is a special lecture just about the this keyword later in the section. Okay, now the content of the execution context, so variable environment, scope chain, and this keyword, is generated in the so-called creation phase, which happens right before execution. And now just one final but very important detail that we need to keep in mind is that execution contexts belonging to arrow functions do not get their own arguments keyword, nor do they get the this keyword. Okay? So basically, arrow functions don't have the arguments object and the this keyword. Instead, they can use the arguments object and the this keyword from their closest regular function parent. And this is an extremely important detail to remember about arrow functions, and we will come back to it later. So these are the things that are necessary to run each function, as well as the code in the top level. Now behind the scenes, it's actually even more complex, but I think we're fine like this, aren't we? And now let's actually try to simulate the creation phase for this code example here. So, as you hopefully know by now, we will get one global execution context and one for each function. So one for the first function and one for the second function. In the global context, we have the name variable declaration, the first and second function declarations, as well as the X variable declaration. For the functions, the variable environment will literally contain all the code of a particular function. Now, the value of X is marked as unknown here because this value is the result of the first function that we didn't run yet. But we will simulate this in the next slide. Now, technically, none of these values actually become known during the creation phase, but only in the execution phase. So this is not 100% accurate here, but it's just to illustrate how these execution contexts work. Okay, so just keep that in mind. Anyway, now in the first function, we have the A variable set to 1 and the B variable, which once again requires a function call in order to become known. Finally, the variable environment of the second function contains the C variable set to 2, and since this is a regular function, so not an arrow function, it also has the arguments object. And this object is an array which contains all the arguments that were passed into the function when it was called. In this case, as you can see, that's 7 and 9. Quite simple, right? Well, it's simple because this is an extremely small amount of code. But now imagine there are hundreds of execution contexts for hundreds of functions. How will the engine keep track of the order in which functions were called? And how will it know where it currently is in the execution? Well, that's where the call stack finally comes in. And remember that the call stack, together with the memory heap, makes up the JavaScript engine itself. But what actually is the call stack? Well, it's basically a place where execution contexts get stacked on top of each other in order to keep track of where we are in the program's execution. So the execution context that is on top of the stack is the one that is currently running. And when it's finished running, it will be removed from the stack and execution will go back to the previous execution context. And using the analogy from before, it is as if you bought pizzas with some friends. Each friend has a pizza box, and then you put the boxes on top of each other, forming a stack, in order to keep track which pizza belongs to each friend. Now, all this sounds a bit abstract, doesn't it? And so to demonstrate how the call stack works, let's walk through this code example together so that I can show you exactly what happens. So, once the code is compiled, top-level code will start execution. And then, as we learned in the beginning of the lecture, a global execution context will be created for the top-level code, right? So this is where all the code outside of any function will be executed. And what happens with this execution context? That's right, it will be put in the call stack. And since this context is now at the top of the stack, it is the one where the code is currently being executed. So let's continue now with this execution. So here, there is a simple variable declaration, and then the first and the second functions are declared. So nothing fancy, but that's just how normal top-level code gets executed. But then, in the last line, is where things start to get interesting. Here we declare the X variable with the value that is going to be returned from calling the first function. And so, let's actually call that function. Now, what happens immediately when a function is called? Well, it gets its own execution context so that it can run the code that's inside its body. Perfect. And what happens to the context? Well, again, it is put in the call stack on top of the current context, and so it's now the new current execution context. Great, so let's continue. So we have yet another simple variable declaration here, and this variable will of course be defined in the variable environment of the current execution context and not in the global context, right? Then, right in the next line, we have another function call. So let's call that function and move there. And as you guessed, a new execution context was created right away for this second function. And once more, it is pushed onto the call stack and becomes the new active context. Now, what's important to note here is that the execution of the first function has now been paused, okay? So again, we are running the second function now, and in the meantime, no other function is being executed. The first function stopped at this point where the second function was called and will only continue as soon as this second function returns. And it has to work this way because, remember, JavaScript has only one thread of execution, and so it can only do one thing at a time. Okay? Never forget that. Now, moving to the next line, we have a return statement, meaning that the function will finish its execution. So, what does that mean for the call stack? Well, it basically means that the function's execution context will be popped off the stack and disappear from the computer's memory. At least that's what you need to know for now, because actually the popped off execution context might keep living in memory, but more about that later in the course. Anyway, what happens next is that the previous execution context will now be back to being the active execution context again. And so let's also go back to where we were before in the code. And I hope that by now you start to see how the call stack really keeps track of the order of execution here. Without the call stack, how would the engine know which function was being executed before? It wouldn't know where to go back to, right? And that's the beauty of the call stack. It makes this process almost effortless. So I like to use the analogy of the call stack being like a map for the JavaScript engine, because the call stack ensures that the order of execution never gets lost, just like a map does, at least if you use it correctly. All right, so we returned from the second function, are back in the first function where we have this calculation, and then finally, this first function also returns. And so here, the same as before happens. So the current execution context gets popped off the stack, and the previous context is now the current context where code is executed. In this case, we're back to the global execution context and the line of code where the first function was first called. So here, the returned value is finally assigned to X, and the execution is finished. Now, the program will now actually stay in this state forever until it is eventually really finished. And that only happens like when we close the browser tab or the browser window. Only when the program is really finished like this is when the global execution context is also popped off the stack. And this is, in a nutshell, how the call stack works. So hopefully it makes sense now that we say that JavaScript code runs inside the call stack. And actually, it is more accurate to say that code runs inside of execution contexts that are in the stack, but the general point is that code runs in the call stack, which is of course true. Great! Next up, we will learn some more about the variable environment and how variables are created. So stay tuned for the next video. Let's continue our journey of diving really deep into how JavaScript actually works behind the scenes. I really hope you have enjoyed it so far and are able to see the immense value that these lectures bring to the table. Now, after this lecture, there will finally be another coding lecture. So hang tight, we're almost there. But now let's get started with this lecture. So we learned in the last lecture that each execution context has a variable environment, a scope chain, and a this keyword. So in this lecture, let's learn what scope and the scope chain are, why they are so important, and how they work. And let's start by understanding what scoping actually means and learn about some related concepts as well. So scoping controls how our program's variables are organized and accessed by the JavaScript engine. So basically, scoping asks the question, where do variables live? Or where can we access a certain variable and where not? Now, in JavaScript, we have something called lexical scoping. And lexical scoping means that the way variables are organized and accessed is entirely controlled by the placement of functions and of blocks in the program's code. For example, a function that is written inside another function has access to the variables of the parent function. Okay? So again, variable scoping is influenced by where exactly we write our functions and code blocks. Okay, and now about scope itself. Scope is the space or environment in which a certain variable is declared. Simple as that. And in the case of functions, that's essentially the variable environment which is stored in the function's execution context. So if now you're asking yourself, what's the difference between scope and variable environment? Then the answer is that for the case of functions, it's basically the same. Now in JavaScript, we have the global scope, function scope, and block scope. And we will talk about these in a second. But first, let's also define what the scope of a variable is. So the scope of a variable is basically the entire region of our code where a certain variable can be accessed. Now, some people use the word scope for all of this, but I like to define all these concepts that we have here in a clear way because there are actually subtle differences. For example, if you take a close look at it, scope is not the same as scope of a variable, and so you should know about these subtle differences, right? And I know it might still sound all the same for now, but after looking at a couple of examples and writing some real code, you will understand everything I just showed you here. Anyway, let's now talk about the three different types of scope in JavaScript. So that's global scope, function scope, and block scope. And remember, scope is the place in our code where variables are declared. And when I say variables, the exact same thing is true for functions as well. Because in the end, functions are just values that are stored in variables. So first, the global scope is, once more, for top-level code. So this is for variables that are declared outside of any function or block. These variables will be accessible everywhere in our program, in all functions and all blocks. So really everywhere. Next, each and every function creates a scope, and the variables declared inside that function scope are only accessible inside that function. This is also called a local scope, opposed to the global scope. So local variables live in the function, so to say. And outside of the function, the variables are then not accessible at all. Again, this is technically the same as the function's variable environment, but we still need to give it the name of scope in this context, because blocks also create scopes. Anyway, in this example here, the now variable is 2037 inside the calc_h function, and therefore we can use it in the function to do calculations. But outside of the function, as we try to log it to the console, we get a reference error. So JavaScript is trying to find the now variable in this global scope, so outside of the function, but it cannot find it. And so there is going to be an error. And if you remember our pig game project from the previous section, That is also the reason why we had to declare a couple of variables outside of the init function. Remember that? So we had some variables declared in the init function, and then that gave us an error because other functions were trying to access these variables. But of course, they were in the function scope, and so they were locally scoped, and so we couldn't access them outside of that function where they were declared. And here, it actually does not matter what kind of function we're using. So function declarations, function expressions, and arrow functions all create their own scope. Now, traditionally, only functions used to create scopes in JavaScript. But starting in ES6, blocks also create scopes now. And with blocks, we mean everything that is between curly braces, such as the block of an if statement or a for loop. So just like with functions, variables declared inside a block are only accessible inside that block and not outside of it. Now, the big difference is that block scopes only apply to variables declared with let or const. Okay? So, again, only let and const variables are restricted to the block in which they were created. That's why we say that let and const variables are block scoped. So if I declared a variable using var in this block, then that variable would actually still be accessible outside of the block and would be scoped to the current function or to the global scope. And so we say that var is function scoped. So in ES5 and before, we only had global scope and function scope. And that's why ES5 variables declared with var only care about functions, but not about blocks. They simply ignore them. Finally, also starting in ES6, all functions are now also block scoped, at least in strict mode, which you should always be using anyway. And just like with let and const variables, this means that functions declared inside a block are only accessible inside that block. Okay? And we will see examples of all that in the next video when we're gonna go back to coding. So, to recap, let and const variables, as well as functions, are block scoped. And if you already know other programming languages, block scoping is probably more in line with what you already know. Function scopes are weird for some beginners in the JavaScript world. And that's why block scopes were introduced in ES6. But now, to understand all this a little bit better, let's actually look at a more real and detailed example and also learn about the scope chain. And here we have some code with different functions and blocks, and we're going to take a look at the scopes that are in this code, as well as build the scope chain. And of course, we start with the global scope. As you can see, the myName variable is the only variable declaration that we have in the global scope. Now, technically, the first function also counts as a variable that is present in the global scope, but I want to keep it simple here, and so I will only consider variable declarations and no functions, all right? Just keep in mind that whatever I'm explaining here for variables also works the same for functions. Anyway, inside the global scope, we have a scope for the first function because each function creates its own scope, remember? And what's in this scope? Well, it's the h variable that's declared right at the top of the function. Next, inside the first scope, let's now consider the second function, which will also create its own scope containing the job variable set to teacher. So as you see, we have a nested structure of scopes with one scope inside the other. But now comes the actually interesting part, because here in the second function, we have this line of code where we need the myName variable and the h variable, which were both not declared inside the current scope. But we really need these variables here, because otherwise we can't create this string here, right? So how can this be fixed? How will the JavaScript engine know the values of these variables? Well, the secret is that every scope always has access to all the variables from all its outer scopes. So from all its parent scopes. In our example, this means that the second scope can access the h variable from the scope of the first function. Of course, this also means that the first scope can access variables that are in the global scope, because that is the parent scope. As a consequence of this, the second scope will then also be able to access the myName variable from the global scope, because it has access to the variables from the first scope. And by the way, all this also applies to function arguments, but in this example we just don't have any. And this is essentially how the scope chain works. In other words, if one scope needs to use a certain variable but cannot find it in the current scope, it will look up in the scope chain and see if it can find the variable in one of the parent scopes. If it can, it will then use that variable. And if it can't, then there will be an error. And this process is called variable lookup. Now, it's important to note that these variables are not copied from one scope to another, okay? Instead, scopes simply look up in the scope chain until they find the variable that they need, and then they use it. What's also extremely important to note is that this does not work the other way around. A certain scope will never ever have access to the variables of an inner scope. In this example, the first scope, for example, will never get access to the job variable that is stored in the second scope. Okay? So again, one scope can only look up in the scope chain, but it cannot look down, basically. So only parent scope can be used, but no child scopes. Anyway, with all this in place now, this line of code can be executed and print to the console, Jonas is a 30-year-old teacher, even though the myName and h variables were not defined in the current scope. All the engine did was to get them from the scope chain. And as you might be noticing, we have actually already done this before in our own code. We just didn't really understand what was going on and how it all worked. But now we do know how it works. Amazing, right? Anyway, we still have one more scope left here, and that's the one created by this block here. Remember that starting with ES6, not only functions create scopes, but also blocks. However, these scopes only work for the ES6 variable types, so for let and const variables. That's why the only variable that's in this scope is the decade variable. The millennial variable isn't declared with const or let, and therefore it is not scoped to just this block. Instead, the millennial variable is actually part of the first function scope. So again, for a variable declared with var, block scopes don't apply at all. They are function scoped, not block scoped. Let and const, on the other hand, are in fact block scoped. Okay? This is one of the fundamental things that you need to keep in mind about let, const, and var, and about scoping in general. So if you're taking notes, and I hope you are taking lots of notes, then this must definitely be in there. Now, about the scope chain, if the millennial variable is in the first function scope, then of course the second function scope also has access to it, even if it doesn't really need that variable. Also, the scope chain does of course apply to block scopes as well, and therefore in our if block scope, we get access to all the variables from all its outer scopes. So from the first function scope, and of course from the global scope. That's why I said in the last slide that variables in a global scope are accessible from everywhere. They are because they are always at the top of the scope chain. In fact, we call variables in the global scope global variables. Very creative, right? But we actually use this term a lot in JavaScript. Now, it's important to understand that our purple block scope does not get access to any variables from the yellow second function scope, and the same the other way around. And why is that? Well, it's because of lexical scoping, as we learned in the last slide. So the way that we can access variables depends on where the scope is placed, so where it is written in the code. In this case, none of these two scopes is written inside of one another. They are both child scopes of the first function. We could even say that they are sibling scopes. And so by the rules of lexical scoping, they cannot have access to each other's variables, simply because one is not written inside the other one. We can also say that the scope chain only works upwards, not sideways. Okay, so this was a lot to take in, but I hope that everything still keeps making sense at this point. And if not, don't worry, we will see all this working in practice in the next video. But for now though, there is one more thing that we need to talk about, which is the difference between the scope chain and the call stack. I get a lot of questions about this all the time, and so I decided to talk about how the call stack, execution context, variable environments, and scope are all related to one another. So before we move on to the next video. And once more, let's look at some more code here. So we have three functions called first, second, and third in order to make this easier to understand. We start by calling the first function, which then calls the second function, which in turn calls the third function. So from what we learned before, the call stack for this example will look like this, right? One execution context for each function in the exact order in which they were called. I also included the variable environment of each execution context. For now, all this has nothing to do with scopes or the scope chain, all right? All I'm doing is creating one execution context for each function call and filling it with the variables of that function. And you can pause the video here for a moment to understand the content of each variable environment. Okay, and now that you did that, and we have all these variable environments in place, we can actually start building the scope chain. As always, we're going to start with the global scope. And the variables available in the global scope are exactly the ones stored in the variable environment of the global execution context. And given everything we've learned so far, that makes sense, right? And note that in this example, I am actually including functions in each scope, unlike we did in the previous slide. Now, in the global scope, we also call the first function, which is the reason why we have an execution context for it in the call stack. And this function, of course, also gets its own scope, which contains all the variables that are declared inside of the function. And once again, this is exactly the same as the variable environment of the function's execution context. However, that's not all, because now we already know about the scope chain. So the first scope also gets access to all the variables from its parent scope, thanks to the scope chain. Now, as we already know, the scope chain is all about the order in which functions are written in the code. But what's really important to note here is that the scope chain has nothing to do with the order in which functions were called. Or, in other words, the scope chain has nothing to do with the order of the execution contexts in the call stack. The scope chain does get the variable environments from the execution contexts, as shown by the red arrows here, but that's it. The order of function calls is not relevant to the scope chain at all. All right? Really keep that in mind. Now, moving on to the second function now. Once again, its scope is equal to its variable environment. Also, it's lexically written within the first function, and so of course, it will have access to all its parent scopes as well. So we can say that the scope chain in a certain scope is equal to adding together all the variable environments of all the parent scopes. And so this is how scope and the scope chain are built in the JavaScript engine behind the scenes. Okay, now in the second function, we try to call the third function. But why does that work? Well, it works because the third function is in the scope chain of the second function scope, as we can see here in our scope chain diagram. It's a function in the global scope, or a global function, and therefore it's accessible everywhere. Of course, this will create a new scope along with the scope chain, as we already know. Great, so what happens in this third function? Well, we're trying to access variables b, c, d, and a here. D is no problem because it's right there in the third function scope. So that one is easy. Then variable c is not in a local scope, and so JavaScript needs to do a variable lookup. So it looks up in the scope chain, looking for variable c, but it's not there. And of course it isn't, because c is defined in the second function, and there is just no way in which the third function can access variables defined in the second function. And that is true even though it was the second function who called the third. And so here is even more proof that the order in which functions are called does not affect the scope chain at all. And so here, as a result, we get the reference error because both C and B cannot be found in the third scope nor in the scope chain. Okay, and with this, I hope I made it crystal clear that execution contexts, variable environments, the call stack, scope, and the scope chain are all different, but still very related concepts. And if it's not yet crystal clear, then it's no problem to maybe rewatch this slide, or maybe even this entire lecture a little bit later. And I know that this was quite a long lecture with a ton of stuff to take in, and so here is a handy summary with the main takeaways from this video. So to start, scoping asks the question, where do variables live? Or where can we access a certain variable and where not? That's what scoping is all about. Now, there are three types of scope in JavaScript: the global scope, scopes defined by functions, and scopes defined by blocks, starting in ES6. However, only let and const variables are block scoped. Variables declared with var automatically end up in the closest function scope. Next, in JavaScript, we have lexical scoping, which means that the rules of where we can access variables are based on where in the code functions and blocks are written. And now let the magic begin, because every scope always has access to all the variables from all its outer scopes. And this is what we call the scope chain. When a certain variable is not in the current scope, the engine looks up in the scope chain until it finds the variable that it's looking for. And this process is called variable lookup. It's important to note that the scope chain is a one-way street. So a scope will never ever have access to the variables of an inner scope, only of outer scopes. We can also think of the scope chain in a certain scope as being equal to adding together all the variable environments of all the parent scopes. And finally, we need to keep in mind that the scope chain has nothing to do with the order in which functions were called. So the order of function calls does not affect the scope chain at all. Okay, and now that's actually it. This is, in a nutshell, scoping in JavaScript. See you in the next video. Now it's time to see scoping in action in a semi-complex example to make sure that you really get this super important concept. And as always, let's start by opening up a new VS Code window with our starter files. So that's already here at my desktop. And again, I have the prettier configuration here. The index is not really important here. And so let's just start writing some JavaScript code here. And I'm going to start by writing a simple calc_h function. And this time, let's actually use a function declaration. Not that it matters, but just to have some diversity and not always create the same type of function. So calc_h, which is going to receive a birth year. And then all this function does is to calculate an age. And so this is nothing new at this point. So the current year minus the birth year. Then let's also return that age here. And so this calc_h function here is, as we learned in the last lecture, defined in a global scope. And that's because it is here in the top level code, right? Also, this function here creates its own scope, and that scope is going to be equivalent to the variable environment of its execution context. So that's all the stuff we learned over the past couple of lectures. And now let's create a global variable here. So I'm going to call that one first name. And now let's actually call the function. So calc_h with 1991. And then here inside of this calc_h function, I will log first name to the console. So first name. Now, as you see, this first name variable is not actually in this scope of the calc_h function. However, it is a global variable that we defined out here. And so therefore, through the scope chain, it's going to be made available also inside of this scope. So inside of this function, right? So let's just execute this code here just to see that it actually works. And then we're going to explain a little bit more. So live server. And so here we go. Let's open up the console. Let's reload to get rid of this error. And OK. So you see that indeed Jonas here was printed to the console, which is the first name variable. And so when this line of code here was executed, JavaScript did not find this variable in this scope. And so it did a variable lookup, where it looked up in the scope chain to see if it found the variable there. And indeed, the parent scope of the calc_h function is the global scope. And the first name variable is in there, and therefore JavaScript could then use that. Now here, if we tried, for example, just name, then JavaScript would also do a lookup, but it would not find this variable in the global scope. And therefore, we would get an error. Now with this variable, actually, we would get no error. As I explained to you in the beginning, this is kind of a special variable name that we should not use. So let's say I used last name. And so again, this variable is nowhere to be found. So even by doing a lookup into the parent scope, and so now when I save this, then I get this last name is not defined error. Okay. And so going back here to first name, then of course, everything works just the same. And that is true, even though this variable here was actually defined after the calc_h function. But that's not a problem at all, because remember that the code in the function is only executed once it's actually called. And so that happens after the declaration of the first name variable. So right here. And so at this point in the code, the first name variable is already in the global execution variable environment. So in the global scope, ready to be used. Okay, but let's actually get rid of this here. And let's create another function inside of this function. So function print h, and this will print a nice string to the console. And as you also know already, it also creates a new scope. And let's create an output variable, which is going to be the string that we will build here. So output equals you are the age, and I forgot the curly braces, born in birth year. And then we simply log that message to the console. And now to actually see this result here, we need to, of course, call the function. So let's do that right here. So print age. And now we get this string with all the data that we actually computed, and it works just fine. So we get the age that was calculated here, and also the birth year that was passed into this function. And so here again, we see the magic of the scope chain in action. So once again, the engine, as it is executing this print age function, is trying to access or is trying to find the age variable in the current scope. However, it cannot find it there, and so therefore it goes to the parent scope, where it will then find this age variable, of course, that we created here. And the same is true for the birth year variable, because for scoping, the parameter of a function works just like normal variables. And also remember that we say that the scope of a variable is the entire region of the code in which the variable is accessible. So for example, the scope of the age variable is all of this area here. So everywhere here, the age variable is accessible. So of course in the calc_age function where it was defined, and then also in all the child scopes, so all the inner scopes, okay? But of course, age is not accessible outside of the calc_age scope. So let me demonstrate that here. So here we will not be able to access the age variable. And that is because, as I mentioned, the scope chain is a one-way street. So only an inner scope can have access to the variables of its outer scope, but not the other way around. So now here we are in the outer scope, and we cannot have access to the variables of a child scope, which the scope of the calc_age function here surely is. Okay, and the same goes for functions again, and so we cannot call the print age function out here for the same reason. So let's comment out this one. And so now we get print age is not defined. Okay, so here in the global scope, we do not have access to any variables defined in any other scope. All right. And here let's actually take it to the next level and also include the name of the person. So let's say first name, and let's try this now. And indeed, it does have access to the first name variable. And so here the engine is doing an even bigger or longer variable lookup. So right now we are of course in the print age scope here. And so then JavaScript cannot find the variable in the current scope. So it looks up in the scope chain, which is then the next step, the calc_age function. However, it can also not find first name in this scope, and therefore it goes up even further into the global scope. And there it is. And so this is the value that is going to be used. Okay, so I hope all of this made sense until this point. Let's now go further and also create a block scope right here in this print age function. So let's do an if statement here. And we will check if the person based on the birth year is a millennial. And so that is if you were born between 1981 and 1996, then you're a millennial. And so let's check for that. So birth year needs to be at least 1981 and below 1996. And so here we are creating a block, and therefore this will be a new block scope. And so let's now define a variable here using const. And I'm going to call it string. And let's say, so first we get this string here to the console, and then we can also say, so if the person is a millennial, we will say, oh, and you're a millennial. And then again, the first name. And so now we are adding even one more step here to the scope chain, because now the lookup for first name is even longer, but it still will work. So let me log that to the console. And so in this case, I am clearly a millennial, okay? And again, Jonas here is still found all the way here from the outer scope. But now, what do you think will happen as we try to log this variable outside of this block scope? So basically do the same, but outside of the block. So indeed, we get an error that str is not defined. And again, that's because const and let variables are block scoped. So they are valid, so they are available only inside the block in which they were created. But now watch as we create yet another variable, which I will call millennial. And let's set it to true. And so this is an old pre-ES6 variable. And so what do you think will happen as we log it also here outside of this block? So we need to comment out this one. So again, what do you think is going to happen now? And JavaScript can actually find it. And so that is because of the fact that var variables, so variables declared with the var keyword, are function scoped. So they simply ignore the block because they are not block scoped at all. They're just function scoped. And so here we are still in the same function. So here we are trying to access the variable that was defined in the same function, right? So right now, the scope of the millennial variable is this entire function, no matter if it was declared inside of a block or not. Because again, var variables do not care about blocks at all. And so therefore, we can then access the millennial variable inside of its scope. Okay? So keep that in mind as you use or as you see a variable declared with var, right? Because as I said, on your own, you should probably not use this variable yourself. Always just use const or let. But if you are reading other code bases or even working with older code, then keep in mind that this is how the var variable works. And so that's why it's very important to learn about this here as well. Okay, next up, let's prove that functions are also in fact block scoped starting in ES6. So let's just create a simple function here that will add two values. Return a plus b. And then let's attempt to call it here outside of the block. So add 2 and 3. And now we get add is not defined. And so, in fact, the scope of this add function here is only the block in which it was defined. So only here we can use the add function. And so that proves that functions are now in fact block scoped. But remember that that is only true for strict mode. And so that's the mode that we're actually currently in. But if I turn this off, you should see now actually add being called. So let's log the result of that to the console. And so we should now see 5. And indeed, now it works. All right, but we should always use strict mode. And so now we should get that error back. And so let's also comment this out. And so you can keep this here as a reference. Okay, and now to finish, let's do some experiments here. So what do you think is going to happen if we declare a variable in this scope here? So in this new block scope that already exists in a parent scope. So for example, let's say here, const first name equals Stephen. So what do you think this string here will look like now? So do you think that here it will say Jonas or Stephen? Well, let's try. And in fact, it now says Stephen. And that happens because, as always, JavaScript tries to look for the variable name in the current scope. And right now, it actually is in the current scope. So first name is indeed in this same block, so in this same scope. And so therefore, JavaScript will then use that variable and not perform any variable lookup in the scope chain. So the scope chain isn't necessary at all if the variable that we're looking for is already in the current scope. And so that's exactly the case right here. But of course, then outside of this block, the first name variable is still going to be the one coming from the scope chain. So that's why here you still see Jonas. So right here in the print h function, which is another scope, so it's the parent scope of this scope, right? And so here, first name is still Jonas, because it is not in the current scope of this function, and therefore JavaScript will make a variable lookup in the scope chain until it can find first name, which is still Jonas, coming from down here. So here we created a new variable with the same name of another variable that we had already created in a parent scope. So we have two first name variables right now, but that is not a problem at all, because in fact they are completely different variables. They simply happen to have the same name, but that's not a problem at all, because they are defined in different scopes. And so you can have repeated variable names. That's absolutely no problem. And that's also the reason why you can have different functions with the same parameter names, because again, each parameter is only defined in that scope of that function. And therefore, it's not a problem at all to have many functions with the exact same parameter names, in the same way that it's not a problem to have functions with the same variable names inside of them. But now watch what happens when we redefine a variable from a parent scope inside of an inner scope. So not creating a new variable, but simply reassigning the value of a variable. So let's do that here. And let's now say output equals new output. And here we then have to change the output to a let. But let's just analyze what we did here. So we are in the print h scope. So that's all of this here. And in here we have the output variable. Then we have a inner scope, so like a child scope here, which then redefines this output variable from the outer scope. And so if we then try to access that output here again, what do you think is going to happen? Well, we get new output here. And that is because we actually manipulated an existing variable here inside of a child scope, so inside of an inner scope, right? We did not create a new variable. We simply redefined a variable that we accessed here from the parent scope. So if we did create a new variable called output here, then we would have the same situation as before with first name. So this would then be a completely different variable and would not at all affect the output from the outer scope. And so now, as we save this, then this new output should disappear and should be back to the original output as we defined it in the scope now. So indeed, now the new output is gone. And again, that's because it is now its own variable. So a brand new variable which just happens to have the same name as a variable from its parent scope. But to illustrate this here, let's actually leave it like this. And I will also comment it, creating new variable with same name as outer scopes variable. And let's put this together here. Reassigning outer scopes variable. So again, two completely different things, but I think this is a very nice example to once again illustrate how the scope chain works. And with this, I hope that you now completely understand how scoping works in JavaScript. Also, just keep in mind that real code should probably not be this confusing, but this was just to show you how scoping works. The next topic we need to talk about is a very misunderstood concept in JavaScript, and that is hoisting. So we learned that an execution context always contains three parts: a variable environment, the scope chain in the current context, and the this keyword. We already learned about the scope chain, and so now it's time to take a closer look at the variable environment, and in particular at how variables are actually created in JavaScript. So in JavaScript, we have a mechanism called hoisting. And hoisting basically makes some types of variables accessible, or let's say usable, in the code before they are actually declared in the code. Now, many people simply define hoisting by saying that variables are magically lifted or moved to the top of their scope. For example, to the top of a function. And that is actually what hoisting looks like on the surface. But behind the scenes, that's in fact not what happens. Instead, behind the scenes, the code is basically scanned for variable declarations before it is executed. So this happens during the so-called creation phase of the execution context that we talked about before. Then, for each variable that is found in the code, a new property is created in the variable environment object. And that's how hoisting really works. Now, hoisting does not work the same for all variable types. And so let's analyze the way hoisting works for function declarations, variables defined with var, variables defined with let or const, and function expressions, and also arrow functions. So function declarations are actually hoisted, and the initial value in the variable environment is set to the actual function. So in practice, what this means is that we can use function declarations before they are actually declared in the code. Again, because they are stored in the variable environment object even before the code starts executing. And I actually told you before that function declarations work this way, but now you understand why. It is because of hoisting. And just to make this table a bit more complete, so that it serves as a nice overview for you, I also show here that function declarations are block scoped, as we learned before. Just keep in mind that this is only true for strict mode. So if you're using sloppy mode, which you shouldn't, then functions are function scoped. Next, variables declared with var are also hoisted, but hoisting works in a different way here. So unlike functions, when we try to access a var variable before it's declared in the code, we don't get the declared value, but we get undefined. And this is a really weird behavior for beginners. You might expect that you simply get an error when using a variable before declaring it, or to get the actual value, but not to get undefined. Because getting undefined is just really weird. And it's not really useful either, right? And actually, this behavior is a common source of bugs in JavaScript. So this is one of the main reasons why in modern JavaScript we almost never use var. Now, on the other hand, let and const variables are not hoisted. I mean, technically, they are actually hoisted, but their value is basically set to uninitialized. So there is no value to work with at all. And so in practice, it is as if hoisting was not happening at all. Instead, we say that these variables are placed in a so-called temporal dead zone, or TDZ, which makes it so that we can't access the variables between the beginning of the scope and the place where the variables are declared. So as a consequence, if we attempt to use a let or const variable before it's declared, we get an error. Also, keep in mind that let and const are block scoped, so they exist only in the block in which they were created. And all these factors together is basically the reason why let and const were first introduced into the language, and why we use them now instead of var in modern JavaScript. Okay, but now what about function expressions and arrow functions? How does hoisting work for these? Well, it depends if they were created using var or const or let. Because keep in mind that these functions are simply variables, and so they behave the exact same way as variables in regard to hoisting. This means that a function expression or arrow function created with var is hoisted to undefined, but if created with let or const, it's not usable before it's declared in the code because of the temporal dead zone. So again, just like normal variables, right? And this is actually the reason why I told you earlier that we cannot use function expressions before we write them in the code, unlike function declarations. Okay, but now before finishing, let's take a more detailed look at this mysterious temporal dead zone. So in this example code, we're gonna look at the job variable. It is a const, so it's scoped only to this if block, and it's gonna be accessible starting from the line where it's defined. Why? Well, because there is this temporal dead zone for the job variable. It's basically the region of the scope in which the variable is defined but can't be used in any way. So it is as if the variable didn't even exist. Now, if we still tried to access the variable while in the TDZ, like we actually do in the first line of this if block, then we get a reference error telling us that we can't access job before initialization. So exactly as we learned in the last slide, right? However, if we tried to access a variable that was actually never even created, like in the last line here where we want to log x, then we get a different error message saying that x is not defined at all. What this means is that job is, in fact, in the temporal dead zone where it is still initialized, but the engine knows that it will eventually be initialized because it already read the code before and set the job variable in the variable environment to uninitialized. Then, when the execution reaches the line where the variable is declared, it is removed from the temporal dead zone and it's then safe to use. So, to recap, basically each and every let and const variable get their own temporal dead zone that starts at the beginning of the scope until the line where it is defined. And the variable is only safe to use after the TDZ, so the temporal dead zone. All right, now what is actually the need for JavaScript to have a temporal dead zone? Well, the main reason that the TDZ was introduced in ES6 is that the behavior I described before makes it way easier to avoid and catch errors. Because using a variable that is set to undefined before it's actually declared can cause serious bugs which might be hard to find. And I will show you a small example in the next lecture. So accessing variables before declaration is bad practice and should be avoided. And the best way to avoid it is by simply getting an error when we attempt to do so. And that's exactly what the temporal dead zone does. A second and smaller reason why the TDZ exists is to make const variables actually work the way they are supposed to. So as you know, we can't reassign const variables. So it would not be possible to set them to undefined first and then assign their real value later. Const should never be reassigned, and so it's only assigned when execution actually reaches the declaration. And that makes it impossible to use the variable before. Okay? Make sense? Now, if hoisting creates so many problems, why does it exist in the first place? I get this question all the time, and so let's quickly talk about that here. So the creator of JavaScript basically implemented hoisting so that we can use function declarations before we use them, because this is essential for some programming techniques, such as mutual recursion. Some people also think that it makes code a lot more readable. Now, the fact that it also works for var declarations is because that was the only way hoisting could be implemented at the time. So the hoisting of var variables is basically just a byproduct of hoisting functions. And it probably seemed like a good idea to simply set variables to undefined, which in hindsight is not really that great. But we need to remember that JavaScript was never intended to become the huge programming language that it is today. Also, we can't remove this feature from the language now, and so we just use let and const to work around this. All right, great. And with all that being said, let's now work on some practical hoisting examples. Maybe it didn't seem like it, but hoisting is actually a fairly straightforward process. So let's just go through the different scenarios here, starting with variables. So let's just create 3 variables here using the 3 different ways of declaring them. So now a let for the job, teacher, and then const for the birth year. Let's just call it year 1991. And now let's try to use all of these 3 variables before declaring them, just to see what happens. So me, job, and year. So from the rules that we learned in the previous lecture, what do you expect will happen now? Well, the first console.log results in undefined. And that's because variables declared with var are actually hoisted, but they are hoisted to the value of undefined. And so therefore, when we try to access them, undefined is exactly the result that we get. And so that's the reason why we see this here. Then on the contrary, we have this let variable. And so here we see that we cannot access job before initialization. And so that's exactly the kind of error that I showed you in the last slide. And the origin of this error is the fact that the job variable is still in the temporal dead zone here at this point. Right? So remember that the temporal dead zone of a variable declared with let or const starts from the beginning of the current scope. And so that's basically here. So in this case, it's the global scope. So from the beginning of the scope until the point of the code where it is defined. And so here. And this means that at this point, of course, the job variable is still in the temporal dead zone. And the same is true for year. And so now we get the same error here for the year variable as well. All right. So let's comment out both of these. Let me just write here that this is hoisting with variables. And now let's try out functions. So let's create function declarations and function expressions here. So function, and again, I will use a simple add, and let me just call it add decl, which stands for declaration AB, and return A plus B. And now a function expression, so add expression and once more return A plus B. And now, since we're doing these two, let's also create an arrow. So add arrow AB and return A plus B implicitly. So I hope you remember that this is how the arrow function works. And now, once again, let's try to use these functions before they are defined. And so I will log them to the console, so the result of calling them, because they return something. And so we need to log the result to the console. So as you already know. So let's add 2 plus 3. And now what do you think will happen? Do you think that it will be undefined again, just like we have here with the var variable? Let's see. And no. We actually get the result of 5. And so indeed, we were able to call the function declaration before it was actually defined here in the code. All right. And now let's try the same for the other two. Expression and add arrow. But now I hope that you can already anticipate what is going to happen. And so indeed, we get an cannot access add expression before initialization. And so that's exactly the same error that we got before here with this let and const variables. And that's because this function here right now is simply a const variable too. And so it means that it's now also in the temporal dead zone, right? So again, we are simply assigning a function value to this variable. And since this variable was defined with const, it is now in a temporal dead zone, and therefore we get this exact same error message as before. And the same, of course, is going to happen with the arrow, right? But now let me show you what happens when we change these to var. So do you think that now it will work somehow? Okay, we still get an error, but it is another error message here. So right now, add expression is not a function. And once again, the same is going to be happening for the arrow. Okay. And now let's think about the reason for this different error message here. So as you already know, any variables declared with var will be hoisted and set to undefined. And now this add expression here is essentially that. It's a variable declared with var. And so right now it is undefined. And then here we are trying to call undefined, basically. So we are doing essentially this. So undefined, and then we are trying to call it. And so we should now get the exact same error. So you see, it's not a function. And in fact, let me show it to you here even better. So add arrow should now be undefined. And indeed, here it is. And once more, that is because we now declared these two here with var. Okay, so let's simply take both of these out. And for you to keep this as a reference, I will leave this one as a var and this as a const. But just know that both of them will not work. The only function that you can use before declaring it is the function declaration. Okay, so now we covered all the rules here and saw how hoisting works. But now let's show me a very cool example which can demonstrate a pitfall of hoisting. And so it's a mistake that we can easily make if we're not careful and at the same time use var to declare or variables. So let's just write example here. So to start, let's declare a fictional function here. So a function which is a function declaration, and that's important. So a fictional function that will delete the shopping cart. So let's say that we have like an e-commerce website or application. So let's simply log here all products deleted. And so this is a dangerous function, okay, that we should not be calling without care. Next, let's also declare a variable which contains the number of products. And so now I will use a var, and this will then show you once more why we should not use var. Products equals 10. And now here at the top of our code, we are going to write some logic which will delete the shopping cart whenever the number of products is 0. Now we already know that 0 is a falsy value, and so we can write this, right? So in this case, we want to call delete shopping cart. All right. So again, here we have var num-products set to 10. But then here we have this logic in which we want to write that when there is no products, we want to delete the shopping cart. But now watch what actually happens. So we get all products deleted, even though num-products is actually 10. So why did that happen? Well, it is because of hoisting. So at this point of the code here, the num-products variable is in fact not 10. Instead, what is it? Well, it is undefined. And that's because of the way hoisting works with var variables. So we just show that to you very quickly. And so indeed, now here from line 71, which is this one, we get this undefined. And we know that undefined is also a falsy value. And so therefore, this code will then still execute even though we thought that num-products is 10. But in fact, it's undefined. And so that will also trigger the execution of this if block here. Now, of course, this is just a fictional tiny example, but in a large code base with thousands of lines of code and without best practices, something like this can totally happen. And it's going to be a bug that will be hard to find. So what are these best practices? What is the conclusion of all this? Well, as a first step, as I told you many times, just don't use var to declare variables. Use const most of the time to declare variables, and let if you really need to change the variable later. Also, in order to write clean code, you should declare your variables at the top of each scope. That will just make your code at least look a little bit better. Finally, always declare all your functions first and use them only after the declaration. And this applies to all types of functions, even function declarations which are hoisted. So you could use function declarations before you declare them, but still, just don't do that. It's just not clean, okay? So what I just told you are the best practices, not the rules of how it works in JavaScript, all right? And now just to finish, since we're talking about the differences between let, const, and var here, let's just take 2 minutes to see yet another small difference between them. So let's again declare one variable for each. Let y equals 2. So the values don't matter at all here. And now let's just take a look at the window object in the console. Okay, x has been, of course, z here. And so let's now take a look here at the window object here in the console. And window is the global object of JavaScript in the browser. And you can see all kinds of stuff in here. For example, the alert window that we have used before or also some other functions that we probably might have used already before. So I'm not going to go into that here. But what is important, so let's go all the way to the down here, and you can of course explore this by yourself in case you're interested in. But what matters here is that beside all these functions, we also get a property of x equals 1. And that's exactly the variable that we declared right here using the var keyword. However, we cannot find y or z here anywhere in this object. And that's because they were declared with let or const. And so variables declared that way do not create properties on the window object. So let me actually demonstrate this to you even better. So we can say, or we can test x equal window dot x. So here we are testing if x is actually a property of the window object. And so if it is, then of course x must be the same as window.x. And actually it is true. And now the same for y and z. And so in these cases, it is both false. So in conclusion, I just wanted to let you know that variables declared with var will create a property on the global window object. And that can have some implications in some cases. And again, you can take some time to explore the window object because it's quite interesting to see everything that is in there. All right, but with that being said, let's now finally move on to our next topic, which is going to be the this keyword. The this keyword is an extremely important concept to understand in JavaScript, and many beginners find it especially difficult. But don't worry, it's actually not that hard if you know exactly how the this keyword works. So the this keyword, or this variable, is basically a special variable that is created for every execution context, and therefore any function. In fact, we learned before that it's one of the 3 components of any execution context, along with the variable environment and scope chain that we already learned about before. Now, in general terms, the this keyword will always take the value of the owner of the function in which the this keyword is used. We also say that it points to the owner of that function. And that sounds very abstract, but we will see what that means in a second. For now, what's very important to understand is that the value of the this keyword is not static. So it's not always the same. It depends on how the function is actually called, and its value is only assigned when the function is actually called. So it's very different from a normal value in this regard. If we set, for example, x to 5, then x will always just be 5. But the this keyword, again, depends on the way in which a function is called. But what does that actually mean? Well, let's analyze 4 different ways in which functions can be called. And the first way to call a function is as a method, so as a function attached to an object. So when we call a method, the this keyword inside that method will simply point to the object on which the method is called. Or, in other words, it points to the object that is calling the method. Okay? And so let's illustrate this with a simple example. So the method here is the calc_h method, again, because it's a function attached to the Jonas object. In the last line here, we then call the method, and as you see, inside the method, we use the this keyword. Now, according to what we just learned, what should be the value of the this keyword here? And that's right, it should be Jonas, because that is the object that is calling the method down there in the last line, isn't it? And so then, on Jonas, we can of course access all the properties that it has, and so this .year will become 1989, because that's Jonas.year as well. So in this case, writing Jonas.year would have the exact same effect as this .year. But doing it this way is a way better solution, for many reasons that we will get into throughout the course. And we will play around with this example a bit more in the next video. But anyway, another way we call functions is by simply calling them as normal functions, so not as a method, and so not attached to any object. In this case, the this keyword will simply be undefined. However, that is only valid for strict mode. So if you're not in strict mode, this will actually point to the global object, which in case of the browser is the window object. And that can be very problematic, and so this is yet another very good reason to always use strict mode. Next, we have arrow functions. And while arrow functions are not exactly a way of calling functions, it's an important kind of function that we need to consider. Because remember, arrow functions do not get their own this keyword. Instead, if you use the this variable in an arrow function, it will simply be the this keyword of the surrounding function, so of the parent function. And in technical terms, this is called the lexical this keyword, because it simply gets picked up from the outer lexical scope of the arrow function. So never ever forget this very important property of arrow functions. Believe me that actually I run into 1 or 2 bugs because of this behavior. Okay, so it's really important not to forget that arrow functions do not get their own this keyword. Okay, and finally, if a function is called as an event listener, then the this keyword will always point to the DOM element that the handler function is attached to. Very straightforward, right? Now, the this keyword is usually a big source of confusion for beginners. But if you know these rules, then it should become a lot simpler. And to make it even simpler, it's also important to know what the this keyword is not. So this will never point to the function in which we are using it. Also, the this keyword will never point to the variable environment of the function. And these are 2 pretty common misconceptions, and so that's why I'm addressing them here. Okay? So again, the rules that I showed you here is all that you need to know. Alright, and now just for the sake of completion, there are actually other ways in which we can call a function. For example, using the new keyword or the call, apply, and bind methods. But we don't know yet what any of these are, and so I will talk about how the this keyword works with them when the time comes. Anyway, that's it for this lecture, so let's now use this in practice to make it crystal clear. Let's now see the rules of how the this keyword is defined in action. And let's start by taking a look at the this keyword outside of any function whatsoever. So just outside here in the global scope. And so we get that the this keyword in the global scope is simply the window object. So that's the global object that we just saw before, remember? And now let's do the same, but inside of just a regular function call. So we're going to use our old friend calc h here. So let's log to the console just the usual result so that we're actually doing something here. But then what we're really interested in is taking a look at this keyword. So let's now call this function. And so let's see. And now the result of taking a look, so at logging the this keyword, is undefined. Okay. And so what that means is that inside this just regular function call here, the this keyword will be undefined. And that's because we are in strict mode. Remember that in sloppy mode, it would be also the global object. So in this case, the window object, but you already know that you always should use strict mode. And so then in a regular function call like this, the this keyword will simply point to undefined. And with a regular function call, I simply mean a call of this function without the function being attached to any object. So without having an owner, so to say. But now let's see what happens if this function here was an arrow function. So let's just copy this. So calc H, both here and here, arrow. And let's call this one with a different value. And now think about the rules that we learned in the last video. So what do you think the this keyword will be if this function is an arrow function? And actually we still need to do that. So birth year. And so now it is a legit arrow function. And so once more, what do you think the this keyword will now be? Think hard about it and then let's check. And so it is window. So that's a little bit weird, maybe, right? So why is that? Why is the this keyword undefined in this function, but window in this function? Well, it is because the arrow function does not get its own this keyword. So instead, the arrow function simply uses the lexical this keyword, which means that it uses the this keyword of its parent function, or of its parent scope, so to say. And in this case, what is the lexical this keyword? So what is the this keyword in the parent scope of this function? Well, it is window, because window is the this keyword here in the global scope. So right here. Okay, that's why I started by showing you this one here. So in this case, this keyword here will simply point to the this keyword in the global scope. And so therefore, it will point to window. Unlike here in this normal function, which does actually get its own this keyword. It simply is undefined here, but it is its own this keyword. While this one here in the arrow function is actually not the this keyword of this function here. Okay, it is simply the this keyword of the parent scope. And that happens to be the window object in this case. In the next video, we will see some more real-world implications of the fact that the arrow function does not get its own this keyword. Now, next up, let's try to use the this keyword inside of a method. So let's quickly create a Jonas object here, just with a birth year, 1991, and then again our calc H method. And so remember that this is basically now a function expression that we need to write here. And now let's log the this keyword here. And then let's call actually the calc H function. For now, just to see what the this keyword will look like. And my hope is that you can guess already what it should look like. So let's save it to see the result. And indeed, it is the Jonas object. So exactly this object with calc H and year. And so it means that's exactly this object. And that's exactly the rule that I told you in the previous lecture. So when we have a method call, the this keyword inside of the method will be the object that is calling the method. And in this case, that's the Jonas object. So Jonas here is basically the owner of the method. That's another way of saying it. And therefore, inside of calc H, this is Jonas. And then we can use that to our advantage to calculate the age here based on the data that is already in this object. And so that's one of the big use cases for the this keyword. Right? Because then we don't have to pass in this data here again. So instead of having to do this again, we can simply use the birth year that is already in the object itself. And so we can use the this keyword to reference that object. And so this should now give us our usual value here of 46. Great. So that's pretty important stuff. And now let's move on just to one final example here in this lecture. So I keep saying that the this keyword will point to the object that is calling the method, right? And that means that the this keyword will not simply point at the object in which we wrote the method. So here we wrote the calc_h method inside of the Jonas object. And so we might think that that is the reason why the this keyword points to Jonas. But that is not true. The reason that the this keyword will point to Jonas in this case is because Jonas was the object calling that method. And that's a subtle but very important difference. And let me now show you why that is. So let's create a new object, which I'm going to call Matilda. And let's create a first name. Or actually, we don't need a name. Let's just say year 2017. And that's it. That's all we need in this object. Now, remember that a function is just a value, right? And therefore, we can do this. We can say Matilda.calc_h should be equal to Jonas.calc_h. So basically, here we simply copy the calc_h method from Jonas to Matilda. And so now when we take a look at Matilda here, then we see that the calc_h function is also in here. All right. And of course, it's still also in Jonas, but now we copied it from one object to the other. And this is called method borrowing. So we basically borrowed here the method from one object to the other, and so we don't have to write it in a duplicate way. So now let's say Matilda.calc_h. And what do you think the this keyword will look like now? And let's get rid of some of these before so that they don't clutter our output here. And you can then, of course, take them back if you want to see them in your own code. But now let me save this and see what the result of this calc_h will be. So the age of Matilda gave us the correct result of 20, which is exactly 37 minus 27. And so this means that in this method call here, the this keyword does now actually point to Matilda. And we can also see that here. So here, as we logged the this keyword, we see that it's actually the Matilda object because of this birth year. And so this proves exactly what I was just telling you before, which is the fact that the this keyword always points to the object that is calling the method. And so here we are calling the method on Matilda, right? And so therefore, the this keyword will point to Matilda, which was the object which called the method. So even though the method is written here inside of the Jonas object, the this keyword will still point to Matilda if it is Matilda who calls the method. Okay? And so that's really important to understand. And it's the reason why I said in the last video that the this keyword is really dynamic. It's not static, and it depends on how the function is called. And we can take this even further by basically completely taking the function out of the Jonas object. So let's create just a variable called f for function, and then say Jonas.calc_h, and not call it, of course. So we just want to copy now the function into a new variable. And so once more, that is possible because a function is just a value. So we take this value here and copy it here. And of course, without calling it, okay? Just like here, where we copied the method from one place to the other, but we did not call it. So here we can take a look at f in the console. And so you will see that it's actually this function. But now, what implications is this gonna have for the this keyword? Well, let's just try to call the f function, which remember is the code of jonas.cogh. And so now the this keyword should be undefined. And therefore we also get this error that it cannot read year of undefined. So that's coming from here because the this keyword is now undefined. And so undefined.year does of course not exist. So this happens because this f function here is now just a regular function call, right? It is not attached to any object. There is no owner of this f function anymore here at this point. And therefore, it is just a regular function call, just like here, for example. And so therefore, the this keyword is then also undefined, just like, again, here in this function, which was also a regular function call, just like our f function is now. All right, so again, that's a subtle difference in our code, but it makes all the difference in the result that we then get. And for sure, the this keyword is a subject that confuses many beginners in JavaScript. But hopefully this lecture and the previous one made it a little bit more clear. Now we didn't talk about the event handler functions here that I also showed you in the last video, so on the slide there, but I'm leaving that for the advanced DOM section where we will come back to this. But for now, in the next video, we need to take an even more closer look at regular function versus arrow functions. Let me now show you some pitfalls of the this keyword related to regular functions and arrow functions. This way, we can learn when we should use and avoid each of them. And to start, let's get back the Jonas object from before. And I will also add a first name property. All right. And now let's add a second method here, but this time using an arrow function. So we will do a very simple greet method. And so an arrow function here, which simply logs to the console, hey, and then the name. And so we're going to take this name from the object. So this dot first name, or at least that's what we think we're doing. So let me now show you what happens as I call Jonas.greet. And maybe you can also anticipate it based on the knowledge that you already have of the this keyword when used in an arrow function. So let's see what the result is here. And we get hey undefined. So that's not hey Jonas as we might have expected. And the reason is exactly the one that I mentioned in the last lecture, which is the fact that an arrow function does not get its own this keyword. It will simply use the this keyword from its surroundings. So in other words, its parent's this keyword. And the parent scope of this greet method is the global scope. Okay, just note here that this is actually not a code block. So you might think that like this kind of block here also creates its own scope, but it doesn't. So this is not a code block, it is an object literal. So it's just a way that we literally define objects. Okay. So all of this here is in the global scope still. And so therefore that includes this greet method. It is in the global scope. And so therefore the arrow function here, which does not have its own this keyword, will use the this keyword from the global scope. And remember, that is the window object, right? And so this dot first name is also undefined. And I think that this is actually something that we haven't seen before. So when we try to access a property that doesn't exist on a certain object, we do not get an error, but simply undefined. And so that is what is happening here. That's why we get undefined, because this is the window object. So just as we saw before. And then on the window object, there is no first name. And so we get undefined. Okay. And actually, this behavior can become pretty dangerous in case we use var to declare variables. Because remember from a previous lecture that variables declared with var actually create properties on the global object. And so let's imagine we have this. So var first name equals Matilda. And so now as we run the greet function, it will say, hey Matilda. Okay, so why is that? So again, it is because inside of this function here, the this keyword is window. And actually, let me print that here to the console as well, just so we can really see that here happening. Okay, so again, window is the this keyword inside of this arrow function, even though that arrow function was called by the Jonas object. But that rule does not apply here because, again, it's an arrow function. And so if we take a look at this window object now, and here close to F for first name, you see here that it does indeed have a property called first name with the value of Matilda. And again, that's because if we declare variables with var, that creates these kind of properties on the global object. And so therefore, this dot first name, which translates to window that first name, is then Matilda. And so that's why we then get hey Matilda here. So that's yet another reason not to use var. So you see there's a pretty long list against var. So from this example, the big takeaway is that as a best practice, you should never ever use an arrow function as a method. And in my opinion, that's even true if you're not even using the this keyword in a particular method. Because if you have this rule of never using an arrow function as a method, then you never have to think about which type of function you should use. You will always just use a normal function expression, and like this, you will then prevent this kind of mistakes from happen. So this mistake that we saw here with hey Matilda is easy to prevent by simply not using var. But even then, hey undefined is still a bug. It's still not correct. And so that would have easily been avoided by just using a regular function. Right? If we had this, then of course now this object Jonas, which is calling the function, would then be the this keyword. Right? So you see first name Jonas and then hey Jonas. Because now this method actually does get its own this keyword. But let's put it back. And okay. Great. And now one final example of a pitfall of the this keyword is when we have a function inside of a method. And that is a pretty common thing to happen. And so let's now take a look at an example of that. So let's create another Jonas object here. Or actually don't. Actually, let's just use this object here that we already have. And let's enhance this calc_h method. So what I want in here is a function that will basically return if the person is a millennial. So easy enough, let's create an isMillennial function in here. And let's simply log to the console if this dot year is greater or equal 1981, and so that's the same rule that we used before, so that the birth year needs to stay between 1981 and 1996. So below 1996. And then let's also call that function right here. So isMillennial will be called as we call the calc_h function. So let's also do that. So Jonas dot calc_h. So we're calling this method here, the calc_h method, which is a regular method, so not an arrow function. And so therefore, the this keyword right here should be the Jonas object. But then in here, we have a regular function, so this one, and here we are then calling it again. Now inside of this function, we are using the this keyword. And so let's now see what happens as we reload the page. And we get cannot read property year of undefined on line 138. So that's right here. So what this means is that the this keyword must be undefined. That's what it says here. So let's just log that as well. And here we can get rid of this one now. Okay, and indeed, the this keyword here is undefined. So why is that? Well, if we think about this, then this here is really just a regular function call, isn't it? It is a regular function call even though it happens inside of a method. And the rule says that inside a regular function call, which this clearly is, the this keyword must be undefined. And so therefore, it is undefined right here. So this is just as if this function was outside of this method. So if we copied this function out here, we would get the exact same result. Now, some people consider that this is a bug in JavaScript, but in my opinion, it's not really. It's just how the this keyword works. It's a clear rule that a regular function call has the this keyword set to undefined. And so that's just what is happening here. Now, there are two solutions to this problem. The first solution is to use an extra variable that we usually call self. So outside of the function, let's say self, and then we set that to this. Because here we are still outside of this isMillennial function. And so here we still have access to the this keyword set to Jonas, right? And so then in here, we can use simply self. And let's do that just here. And here I will duplicate this line so that we can keep the original one. And so now let's use self here. And so then through the scope chain, this self will be equal to this. So self is referenced here, but it's not, of course, in the scope. And so JavaScript goes up the scope chain into the parent scope, which is calc_h. And so here is where self is defined, and it is defined as this. So as the this keyword. And so this is a way in which we can preserve the this keyword. This can also be called that, so that you might also see. And so as we reload now, this actually works. So now we get the value of true. So this was kind of the pre-ES6 solution, but you might still find this solution in some older code bases. However, now in ES6, we have a more modern and better solution. And that solution is to use an arrow function. All right. So let's actually copy all of this because I want to preserve both versions here. And now I will just comment out this first. Let's say solution 1. But now here we have solution 2, which does not need this extra variable. Okay, so let's get rid of this, bring this back, and here, this again. And now, again, the solution to the problem that we saw before is that we can now use an arrow function. And that is going to work because the arrow function does not have its own this keyword. Right? So let's remember again that when we just call this, we get that the this keyword is undefined. And that's because a regular function gets its own this keyword. But the arrow function will not. It will simply use the this keyword of its parent scope. And in this case, that will be the calc_h method. And in here, the this keyword is Jonas, so the Jonas object. And therefore then, here in an arrow function, that would also be the this keyword. And then it is going to work as expected. And indeed, now it is true. And again, this worked because this arrow function uses the this keyword from its parent scope. And in this case, in the parent scope, the this keyword is Jonas. So basically, an arrow function inherits the this keyword from the parent scope. And that is exactly what we need here. All right. And so here you see that it's pretty important to know exactly how each of the different type of functions work in regard to the this keyword, because then you can really use them according to your specific needs. Great. So I hope that especially this solution here made sense to you, and that when you need it at some point in your journey or in your job, you can remember that this is a very useful use case of the arrow function. Now, just to finish this lecture, I also want to quickly touch on the arguments keyword. Maybe you remember me talking about that also in a previous lecture. So in the video about execution contexts and the call stack, we learned that functions also get access to an arguments keyword. So not just the this keyword, but also an arguments keyword. Now, just like the this keyword, the arguments keyword is only available in regular functions. So let's create another function here. So first an expression. So again, basically that's our functions for adding. And actually, let me just grab them from here. I think I defined them somewhere up here. Yes. So there's no need to rewrite the same code over and over again. You just add a comment here, arguments, key, word. And then let me also print to the console that keyword. So let me quickly call this function here now. So 2 and 5. So just so we see the arguments keyword. And so down here it is. And you see that we get basically an array with 2 and 5. And so that's exactly the two parameters that we passed in. And this can be useful when we need a function to accept more parameters than we actually specified. So this is something that we never did before. So up until this point, we have only ever specified exactly the arguments that we have here in the list of parameters. So we have 2 parameters and so 2 arguments. But it is completely legal to add more arguments. They will not have a name, so we didn't name them, but they exist. And we can see them here in the arguments array. All right. So they do appear here, and we can use them, therefore, in the functions. For example, we could use a loop and then loop over this array and add all the numbers together. But now my point here is that the arrow function does not get this keyword. So let's also log it to the console here. So let's put this here in curly braces. Then remember, when we have more than one line of code, we need to explicitly return. And so let's try to take a look at the arguments keyword here as well. So add arrow 2, 5, 8, let's say. But then we get an error. So arguments is not defined. All right. So this was simply just to show you that the arguments keyword exists, but that it only exists in regular functions. So in function expressions like this, but also in function declarations, but not in an arrow function. But anyway, the arguments keyword is not that important in modern JavaScript anymore, because now we have a more modern way of dealing with multiple parameters. But still, it's important that you are aware that this arguments keyword exists. All right. And now with all these lectures on regular functions and arrow functions, you should know all the differences between them, and even more importantly, when to use each of them. As we move towards the end of this section, we need to learn about the big difference between the way primitive types and objects are stored in memory. And this is actually a very practical aspect and one that causes a lot of confusion in beginners. So let's actually start by writing some code this time to understand what the confusion actually is, so that I can then show you how it all works behind the scenes. So right now, I'm not gonna explain how the code we will write now works, but I will just show you what the source of confusion is. But for now, let's start with a simple example with primitives. And so remember, primitives are like numbers, strings, booleans, etc. So simply setting the age to 30. And then I'm creating a old age variable. And this one I will set to the age, because now it is my birthday basically. And so my age changes to 31. But I still wanted to preserve my old age here in this variable. Okay, so let's log the results to the console now. And they should be pretty much what we expect at this point. So you see that my current age is 31 because, well, I changed the original one from 30 to 31. But the old age is still 30 here. And that's because I set it here at this point of the code to age, which was still 30 at this point. And so then changing the age here from 30 to 31 did of course not affect the old age variable. Again, because at this point here, age was still 30. All right. So here, hopefully there is not much confusion. Everything works just as expected. But now let's create another scenario which has an object. So I'm simply going to create an object for me with the name of Jonas and age 30. And now let's copy this object, because let's say that I have a friend who's also called Jonas. And so instead of creating a brand new object from scratch, I will just copy the me object. So const friend equals me. Okay? And so now both the name and the age are the same, but let's say that we have different ages. And so let's change the age of my friend. And that's pretty straightforward, right? So let's say that he is 27 years old. But of course, we did not change me.age, right? So let's now take a look at both of them in the console. So first my friend. So that's the friend object. And then also me. Or we could say Jonas, it doesn't really matter. But what matters is that we will see the me object. And what do we think will happen now? So let me show it to you. And now we get that both me and my friend have the age of 27. And that looks a little bit strange, because all we did was to change the age of the friend, right? Nowhere here I have me.age equals 27. But still, for myself, so here at the me object, the age is also 27. And so that is what I mean by source of confusion. And so in this video, let's now find out why it works this way. Now, before we can understand the code that we just wrote, we need to review some basics here. First, we need to remember about JavaScript's primitive data types, which are number, string, boolean, undefined, null, symbol, and big int. Then everything else are basically objects. So objects created with the object literal, arrays, and even functions are all objects. Now, when we're talking about memory and memory management, it's usual to call primitives primitive types and objects reference types because of the different way in which they are stored in memory. Next, we need to remember about the JavaScript engine. So the engine has two components, the call stack where functions are executed and the heap where objects are stored in memory. And that's right, all our objects, or in other words, reference types, will get stored right in the memory heap. And I mentioned that when we first talked about the engine, but now you will finally learn how that actually works. On the other hand, primitives, or primitive types, are stored in the call stack. And with that, I mean that primitive types are stored in the execution contexts in which they are declared. But for the sake of simplicity, let's ignore that detail now and simply say that primitive types are stored in the call stack, because that's where execution contexts run. All right, but now how does all that actually work? And why did our code example earlier behave in that weird way? Well, let's find out. So here we have the two code examples from earlier, as well as the engine with call stack and heap. And let's start by looking at the primitive values example. So when we declare a variable like h equals 30, what actually happens inside the JavaScript engine and the computer's memory? Well, first, JavaScript will create a so-called unique identifier with the variable name. Then a piece of memory will be allocated with a certain address, so 0001 in this example, and finally the value will be stored in memory at the specified address. So in this case, the value 30 will be specified at memory address 0001. And remember, this all happens in the call stack where primitive values are stored. Now, what's extremely important to understand here is that the identifier actually points to the address and not to the value itself. So we would say that the h variable is equal to 30, but in fact, h is equal to the memory address 0001, which holds the value of 30. All right? And this subtle distinction is very important to keep in mind. Now, in the next line, we declare old age to be equal to h. So, knowing that a variable actually holds a memory address, what should old age look like? Well, it will simply point to the same memory address as the h variable. And so, it will look like old age is simply 30 as well. Great, but now in the next line, we set h to 31. So what will happen then? The value at address 0001 will certainly not become 31, because that would change old age as well, since they both point to the same address. So that would make no sense at all. Also, the value at a certain memory address is immutable, or in other words, it cannot be changed. So instead, what's going to happen here is that a new piece of memory is allocated, so is created, and the h identifier now simply points to the new address, which is holding the new value of 31. All right, and that's why when we lock both our variables to the console in the end, they both return exactly the values that we expect. Now with reference values, things work a bit differently, which is the reason why this example gave us that unexpected weird behavior earlier in practice. So what's the origin of this weird, unexpected result? Well, when a new object is created, such as this me object, it is stored in the heap. And such as before, there is a memory address and then the value itself. Now, in the case of reference values like this me object, the me identifier does actually not point directly to this newly created memory address in the heap. So in this example, D30F. Instead, it will point to a new piece of memory that's created in the stack. And this new piece of memory will then point to the object that's in the heap by using the memory address as its value. In other words, the piece of memory in the call stack has a reference to the piece of memory in the heap which holds our me object. Okay? And that's the reason why we call objects reference types in this context. So again, when we declare a variable as an object, an identifier is created which points to a piece of memory in the stack, which in turn points to a piece of memory in the heap. And that is where the object is actually stored. And it works this way because objects might be too large to be stored in the stack. Instead, they are stored in the heap, which is like an almost unlimited memory pool. And the stack just keeps a reference to where the object is actually stored in the heap so that it can find it whenever necessary. Now, moving on in the code, we create a new variable called friend that we set equal to the me object. So what will happen here? Well, just like with primitive values, the friend identifier will point to the exact same memory address as the me identifier. And again, that address contains the reference which then points to the object itself. And like this, the friend object is now essentially the exact same as the me object. Do you see that here in the diagram? So here comes the interesting part, because now we're actually going to change a property in the friend object by setting friend.age to 27. So what happens then is that the object is found in the heap and the 30 is changed to 27. Great. And by the way, even though we defined the friend variable as a constant, we can actually still manipulate the object without problems. And when we think about that, it makes sense, because we're actually not changing the value in memory for the friend identifier. It is still D305, so the reference to the object. All we did was to change the value in the heap, and that's not a problem. So it's a misconception that all variables declared with const are immutable. In fact, that is only true for primitive values, but not for reference values. So keep that in mind whenever you're working with const. Anyway, as we log the friend variable to the console, we get the age of 27, just as we said it before. But then, when we log the me object, we get that weird behavior that we could previously not explain and not understand. But with everything that we learned in this lecture, it actually now makes sense that in the me object, age is now also 27, even though we never changed me.age directly. And the reason for this, as we can see in this slide, is the fact that me and friend actually point to the exact same object in the memory heap. So whenever we change something in this object, it will always be reflected in friend and in me. So in both these objects. So these are basically just two different identifiers pointing to the exact same value. And once again, that value is the memory address D305, which points to the reference in the memory heap. And one important implication of this is that whenever you think that you're copying an object, you're really just creating a new variable that points to the exact same object. And this has huge implications for the way JavaScript works in practice, and we will see that in the next video and throughout the course. Now, there are actually ways around this, as we will also learn later, but in general, this is how reference values work in JavaScript. So make sure to really understand this, as well as the implications that this behavior has, even if that means that you have to rewatch this lecture, or at least the explanation of this slide. All right? Then, once you really understand what happened here in this example, let's understand primitive values and reference values even better in practice in the next lecture. But before we do that, let me just quickly take a second and mention 3 more really big topics about how JavaScript works behind the scenes that will not be in this section, but closer to where we actually need to learn about them. For example, one fundamental concept of JavaScript is prototypal inheritance, but we will only talk about that in the object-oriented programming section of this course, because it doesn't make sense to learn about this now, only to then forget it all until we finally reach that section. The same is true for a detailed lecture on the event loop. So I already introduced the event loop in this section, but in the section about asynchronous JavaScript, we will dive really deep into how exactly the event loop works and why it's such a fundamental piece of the JavaScript engine. Finally, we will have lectures on how the DOM actually works behind the scenes too. And that's going to be in the advanced DOM and events section, so that you can then apply what you learned there right away. Okay? And with that being said, let's now move on. Let's now create a similar example to what we had in the last video, just so that we can actually see this happening in practice. And just like in the last video, let's start by mutating a primitive value. So let's now use the last name, and I'm going to set it here to Williams. And so that's the initial value of this last name. Then let's also copy it. And so that's because, let's say that this person gets married and decides to change their last name. However, we still want to remember the old name. And so we say old last name is equal to the current last name at this position of the code. But then we mutate actually the last name to Davis. So basically when this person gets married, they then change their last name to Davis. And of course, if we now check out both of them, so first the last name and then the old last name, then we see that they are in fact different. So Davis is the new last name, so the one that we mutated here, and Williams is this old last name that was copied right here in this first line of code, or actually the second line of code. So here everything works as we would expect in an intuitive way. Now remember that it works this way because each primitive value will simply be saved into its own piece of memory in the stack. Okay? But now let's do the same thing with an object, which, as we already know, is a reference value, because it is going to be stored in the heap, and the stack then just keeps a reference to the memory position at which the object is stored in the heap. So let's create an object called Jessica. And so here we will have a first name of Jessica and a last name of Williams. Let's also give her an age of 27, just to make it more complete. And now let's again say that Jessica will get married and will therefore change her last name. And so this time, let's create a new object for the married Jessica. So married Jessica, and it should be equal to Jessica. So we're copying the entire object here. At least that's what it looks like. But behind the scenes, we are actually just copying the reference, which will then point to the same object. Remember that? And so now as we change the last name on married Jessica, so last name, let's change that to Davis. But as we already know, this will not give us the result that we expect. So before marriage, let's log this original Jessica object, so to say. And then after marriage, and then here the married Jessica object. Giving it a save. And now, as we see, we get before the marriage and after the marriage both the last name of Davis. All right, so the last name Davis is now also in the original Jessica object and not just in the one that we copied. And now at this point, we already know why this happened. So just to remember that, it happened because when we attempted to copy the original Jessica object, it did in fact not create a new object in the heap. So this one, again, is not a new object in the heap. It's simply just another variable in the stack which holds the reference to the original object. So both of these two variables simply point to exactly the same memory address in the heap. And that's because in the stack, they both hold the same memory address reference. And so of course, it makes sense that if we change a property on married Jessica, it will also change on Jessica itself. So again, because they are essentially just two different names for the same thing. Now, this is also the reason why we can change properties in the married Jessica object, which was declared using a const here. And const is supposed to be for constants, so for things that we cannot change. However, what actually needs to be constant is the value in the stack. And in the stack, the value only holds the reference, which we are not actually changing. The only thing that we are changing is the underlying object that is stored in the heap. And that is okay to change. That has nothing to do with const or let. All right? That's only about the value in the stack. But if we change something in the heap, that has nothing to do with const or let. Now what we can't do is to assign a completely different object now to married Jessica. So for example, we could not say married Jessica is equal to this new empty object. So that will not work, because this new object will be stored at a different position in memory, and therefore the reference to that position in memory will have to change here in this variable. And therefore that does not work, because that is in the stack, and so since it is a constant, we cannot change that value in the stack. So we cannot change the value to a new memory address, and therefore this does not work. If it was a let here, then we could do this, what we have here. But since it's a constant, again, it is not allowed. So as a conclusion, completely changing the object, so assigning a new object to it, is completely different than simply changing a property as we did here. Okay? So it's a fundamental difference. So please make sure to really understand this. Anyway, what if we actually really wanted to copy the object so that we could then change one of them without changing the other? So let me show you a way in which we can do that. Let's first add some comments here once more. So primitive types, reference types, and then let's now say copying objects. All right. And actually, let's create a new Jessica object. Let me, in fact, copy it from here. So let's say Jessica 2. And so now, if we really wanted to copy this object, we could use a function called object.assign. And what this function does is to essentially merge two objects and then return a new one. So we could do this, object.assign, and then again we can use this function to merge two objects. And so what we can do is to simply merge an empty new object with Jessica 2. And this will then create a completely new object where all the properties are really copied. All right, so the result of calling this function here with these arguments will be a new object. And so let's store that in Jessica copy. And now let's say that Jessica copy gets married. So the same situation as before, changing her last name to Davis. And now let's log both to the console just like here. So Jessica 2, and then here it's Jessica copy. So let's see what happens now. And so it's these last two here from line 222 and 223, right? And so now indeed we can preserve the original last name Williams after we change the last name on this other object here. So this Jessica copy. And what this means is that this object now is indeed a real copy of the original. So all the properties were essentially copied from one object to the other. And so behind the scenes, what that means is that a new object was in fact created in the heap, and Jessica copy is now pointing to that object. So it has a reference to that new object. However, there is still a problem, because using this technique of object.assign only works on the first level. Or in other words, if we have an object inside the object, then this inner object will actually still be the same. So it will still point to the same place in memory. And that's why we say that this object.assign only creates a shallow copy and not a deep clone, which is what we would like to have. So again, a shallow copy will only copy the properties in the first level, while a deep clone would copy everything. And to illustrate this, let me actually show you what I mean. And so let's add an array here in this original object. So an array of family. And this is going to work as an example because an array is really just an object behind the scenes. So here I can prove my point to you with this. So we have now an array called family, okay? And so you see that now this array here is indeed in both objects. So, okay, so far so good. But now let's actually change that array in Jessica copy. So in this one, because as Jessica married, she also increased her family. And so let's now add some more family members there. So Jessica copy dot family, and then let's use the push method to add a new element to the end of the array. And let's add Mary, and let's also add another one. So family dot push, and let's add John. So remember, here we are manipulating the copied object, which is actually a copy, but now here we are manipulating an object that's within the object. So that's this object. And so now as we save this, it still looks the same, but that's because we need to log, of course, after this operation happens. And so now we see that both the objects now have a family with 4 members. And let's open this a little bit, give it some more space. And so indeed, now before the marriage and after a marriage, the family has all these 4 members. All right. So the last name was, of course, as we already saw, preserved. So the name before the marriage is Williams, and that was preserved because that's in the first level, and object.assign here took care of copying that property. And so that was not changed as we changed the last name in the copy. However, the family object is a deeply nested object. And so therefore, object.assign did not really, behind the scenes, copy it to the new object. All right. So in essence, both the objects Jessica2 and Jessica copy have a property called family, which points at the same object in the memory heap. And that object is, of course, this array. And so when we change the array in one of them, it's also going to be changed in the other one. Now, a deep clone is what we would need here, but it is not easy to achieve. And it would actually be beyond the scope of this video to learn how to create a deep clone. Usually we do something like this, which is like really complex, using an external library, for example, like Lodash. And this library has a ton of helpful tools, and one of them is for deep cloning. And actually, we will do that in a later section, just so you see how we can include an external library to do this kind of stuff. All right, and with this, we actually finish this section about how JavaScript works behind the scenes. And it was a long one with so many things and so many new concepts to learn. And many of them were hard and probably confusing, but that's not a problem. So it's always a part of learning. And even if you did not understand 100% of everything, you're still good to move on in the course to the next section now. But just reaching the end of this section already gave you a big advantage over many other developers which have no idea about many of the things that I showed you here in this section. So congratulations for sticking with it to the end and for learning all of this valuable knowledge. And now I see you in the next section. Welcome back after a long theory section, which I hope was really helpful. Now in this one, we will basically continue learning about basic JavaScript features and syntax, but this time with a focus on more modern JavaScript. So we're gonna dive deeper into built-in data structures like objects, maps, and arrays. We will talk about modern ES6+ operators such as destructuring and optional chaining, and we will also take a look at how to work with strings. And all this together will then give you a very solid and important foundation for the upcoming sections and projects. Let's start this section by learning about array destructuring. So as I said in the intro video, in this section we're basically going to continue learning basic syntax and basic JavaScript features, but now with a focus on more modern JavaScript. And the theme of this section will be to simulate a food delivery application, and in specific one Italian restaurant, which is this starter data here that we already have in the starter files. And so this one is called Classico Italiano. So I already opened up the starter files here for this project, okay? Now, learning complex topics like the ones we're gonna dive into in this section is really best done in isolation. This way you can understand exactly what I'm trying to teach you without having to think about 5 other things at the same time. And so I'm isolating just this one restaurant and building no user interface so that we can focus just on the JavaScript language here. And some people will say that this is boring, but believe me, I do have enough teaching experience to know that some topics are best learned in isolation. And for me, the most important thing is that you will actually learn in this course. Now, of course, there are also topics that can be applied to a visual project. And that's why in the next section, we have a really cool project with an amazing user interface where we're going to learn about array methods. But for now, let's focus on built-in data structures and modern advanced operators. And again, starting with array destructuring. So destructuring is an ES6 feature, and it's basically a way of unpacking values from an array or an object into separate variables. So in other words, destructuring is to break a complex data structure down into a smaller data structure like a variable. So for arrays, we use destructuring to retrieve elements from the array and store them into variables in a very easy way. So let's just actually start with a very simple array. And now if we wanted to retrieve each one into its own variable without destructuring, we would do it like this. Let's say we wanted to name them A, B, C. And so we would write the name of the array, which I totally forgot up here. So R0, and then just duplicating this line, which I'm using Command or Option L for. And I'm not sure if that is actually a shortcut in VS Code. Let me see here. And apparently it's not. Let's see here. Duplicate selection. So it's this duplicate selection here. And you can set up a shortcut for that. And so I will just do that. So B, and so that would be element number 1, and number 2 would be C. So that's how we would retrieve these 3 elements. But now with destructuring, we can actually declare all the 3 variables at the same time. So let me show you how. So const, and then we use the square brackets. And so that's because we are destructuring an array. And so now we can declare 3 variables at the same time. And now I'm not using A, B, and C because we already used them. So let's go with X, Y, and Z. And then I will simply set that equal to the array. And that's it. So let's actually see them now in the console. Give it a save, and then we need to start our live server with a new terminal. And actually I can hit the tab key now, and it will then automatically write the rest of the command. Then close that down. And as you can see, here we get the 2 results, 2, 3, and 4. So the elements of the array. So basically we write this syntax here, and then this will become the first element of the array, this the second, and this the third. And so this here is destructuring this array here from the right side. Okay, and of course this looks like an array, but it's really not. It's just the destructuring assignment. So whenever JavaScript sees this here on the left side of the equal sign, it knows that it should do destructuring. Now when you do this, just don't forget to actually also declare the variables using const. Okay? And I also wanted to notice that even though we did destructuring, which sounds kind of destructive, right? The original array is of course not affected. Okay, so we are not destroying here the array, we are only destructuring. So we are unpacking it. Okay, and now let's work a little bit with the data from our restaurant. So here we see that we have a couple of arrays here actually. So the categories, the starter menu, and the main menu. So let's take some elements out of the categories. So let's say, and then the destructuring assignment, first and second. All right. And so now you see here that we do not have to take all of the elements out of the array. So this will just take the first and the second. So it will simply follow the order of the elements here and will basically only take these 2. And so now the array from which we want to extract, and that's restaurant.categories. Just to take a look now. And indeed, we get Italian and pizzeria, which are exactly the first 2 elements of the array. But now let's say that we only wanted to take the first category, so this one, and the third. So let's say that this one is the main category and this is the secondary for some reason. Well, to do that, we simply leave a hole in the destructuring operator. So what I mean is just this. And so now the second element will be skipped, so the one that would go here, and then this second here simply becomes this third element. And now, so you see that second now is vegetarian, which is element number 3. All right. And so like this, we don't have to create variables for all the stuff that we might not even need. So if we only need to take this and this, we just skip the element in the middle. Okay. And this is really powerful, and we use destructuring to do a lot of cool things. For example, let's say that the owner of the restaurant now decided to switch the main and the secondary category. So right now the primary is Italian and the secondary is vegetarian. But now they wanted to switch it. So let's first change the name here to main and secondary, just to make it a bit more obvious. Second array. And so if we would like to switch these two variables, then without destructuring, we would have to do it like this. We would need to create a temporary variable, and then to that we would assign one of them. So let's say main, and then we could switch main. We would say main is equal to the secondary, and then secondary is equal to temp, because that's where we temporarily stored the value of main, right? We could not just do main equals secondary and then secondary equals main, because by then we would already have overwritten the main variable, right? And that's why we need this temporary variable in the middle. So that's how we would do it. But with destructuring, we can make it a lot easier. And this is how we do it. First, we create an array with both of them. And the first one is going to be the secondary. And then the second one will be the main. And actually, before we do that, let me just show you that this worked. So main and secondary. And so now we should see them switched. Oh, okay. Here we need to change, of course, to let, because we are reassigning here to a const in line 24. So let's try that now. And indeed, what was Italian is now vegetarian, and what was vegetarian is now Italian. So this here worked indeed, but let's now take this out so that we can do it using destructuring. So as I was saying, in order to switch the two variables using destructuring, we would first start by creating a new array with the two variables inverted. So first secondary and then main, and then we can simply destruct them. So main and secondary equals the destructuring of this array. And now we're not using let or const here, because we are simply reassigning the values of the two variables. So just like we did here. But now we do not need a temporary variable in the middle. So let's check now. And indeed, the result is the same. But this is a lot easier. And this is a trick here that I actually use all the time. So let me just show here, or actually write here, switching variables. Okay, so that's a pretty cool trick. And another trick with destructuring is that we can have a function return an array, and then we can immediately destruct the result into different variables. And so this basically allows us to return multiple values from a function. And so let's try that and write a function to order food. So here in our restaurant, let's now add a method, and I'm going to call it order. So this will be a function, and it will accept two parameters. One index for the starter menu, so this menu, and then one index for the main menu. And then the person will order basically by giving the index for each of the menus. So something very simple, just to illustrate the point here. So let's say starter index and main index. Okay, and so we will simply now return the content of the arrays based on the given indexes. So return, and so as I said, we're going to return an array, and then we go to this dot starter menu. Okay, and remember how the this keyword here is set, as we learned in the last section. And so now we go to the position of the starter index that we passed into the function. Okay, that makes sense. Then the same with the main menu at the position of the main index that is passed in. All right. So here we are, of course, not doing any destructuring yet, but now is a time where we will do it. So let's call order, or in fact, restaurant.order, and let's use 2 and 0. So we want element number 2 from the starter menu, so the garlic bread, and the number 0 from the main menu, which is pizza. So we're going to receive an array with that, right? Let me just show that to you. And indeed, it is garlic bread and pizza. And so now we can simply destructure that. So this is the destructuring assignment. And so let's say starter and main should equal these two results. So let's log them, starter and main. Oh, and now this was already defined before. So let's just call this one here the main course. And now indeed we get garlic bread and pizza. All right, so this is how we basically receive two return values from a function. All right, so of course we could have done that without destructuring and still return an array from the function, but this is a very handy way of then immediately creating two variables out of one function call. Okay, and now that you understand how destructuring works, let's take it one step further. Because what happens if we have a nested array? So let's say nested. And with nested, we mean one array inside another. So let's say that we now here have another array, 5 and 6. So an array inside an array. And I'm not sure if we did that before, but of course that's perfectly acceptable. So as a small exercise, how can we get this value here and this entire array? Well, we simply define two new variables using the destructuring assignment. Let's call them I and j. And remember that we do not want in the middle. So we just skip it. So simply leave a space and then another comma, and then this one is going to be j. Equals to the array from which they should be taken. And indeed, we get the number 2 and then the array 5 and 6. Great, but what if we actually wanted all the individual values? Well, then we would essentially have to do destructuring inside of destructuring. So that sounds complicated, but it's not. So let's take out these here, and let's create now 3 variables. So one for this, one for the 5, and one for the 6. So we're going to skip the 4 again. So that's going to be I. Then again the whole here. And now here we can destruct this inner array immediately. So we use the destructuring here again. And so now j for the first element and k for the second. So for 5 and 6. And then again, the array from which to take. And then let's take a look. And so this should now give us 2, 5, and 6 as separate variables. And yes. So that's how nested destructuring works. Basically, we need to do destructuring inside of destructuring. Okay. And now to finish, there's just another feature of destructuring that I want to show you. So we can also set default values for the variables when we are extracting them. And that's going to be very useful in the case that we don't know the length of the array. And this can sometimes happen in real-world applications, as you will see later. So if we have an array that is shorter than we might think, then we might try to unpack the array in positions that don't even exist. So let me say here just default values, and here nested destructuring. So learning a lot of stuff here about destructuring. And so let's now say that we have this array, 8 and 9, and then we are trying to destructure it. So just pretend that we actually don't know the array, all right? And so we might try to take 3 elements out of the array using, again, destructuring. So let's call them P, Q, and R. And then let's try to log them all, P, Q, and R. And so now here we get undefined as the third one. So this would basically be the same as trying to read the element at position number 2 of this array, but it only has elements at position 0 and 1, and so therefore we then get undefined. But as I said, we can set default values. So let's simply set them all to 1. And then our R will become 1. Great. And if we remove this element, then Q will also become 1. Okay? And as I said, this can sometimes be useful, for example, when we get data from an API. And so we're gonna probably use this one and actually everything that we did in this lecture a bit later in the course. So we talked about destructuring arrays, but we can also destructure objects. So let's do that now. And this time, let's actually write the code before the previous lecture. So right here after this restaurant object, so that we don't have to scroll too much. Also, I added this object here to the restaurant object. And so that was already in your starter files, but I didn't have it here yet. Anyway, let's now talk about object destructuring. And so to do that, we use the curly braces to destructure. So to destructure objects, we use the curly braces, because this is also how we create objects, right? Then all we have to do is to provide the variable names that exactly match the property names that we want to retrieve from the object. So the obvious choice here of object to destructure is restaurant. So let's take the name, categories, and opening hours. So again, let's start with const in order to actually define some variable names. And now, as I said, we need to write the exact property names here to now extract variables from this object. Now, since in an object the order of elements does not matter, we don't need to manually skip elements like we did in an array. So we can simply write name, so that's the restaurant name here, and then also remember that in objects, the order of the elements does not matter. And so we can also then take now the opening hours, which is kind of the last property, and only then the categories. And then we simply say equal restaurant. So that's exactly the same as with arrays. But now here we use the curly braces and we have to specify the name of the properties. But just like with arrays, this now creates 3 brand new variables. So based on this restaurant object. So let's see. Name, opening hours, and categories. And indeed, here they are. Okay, so that's the fundamentals of destructuring objects. And once again, this is an extremely useful addition to the language, especially when we deal with the result of an API call, which basically means to get data from another web application like weather data or data about movies or something like that. And this data usually comes in the form of objects, basically. And then destructuring is really a lifesaver. It allows us to write a lot less code. So this is really used in modern applications. But now, what if we wanted the variable names to be different from the property names? Well, we can do it like this. Now, of course, we still need to reference the property names like we did before. Otherwise, JavaScript has no way of knowing what we actually want. So let's write name again, but then we can use the colon and specify a new name. Let's say we actually want it to be called restaurant name. And then here, let's say we want the opening hours, but we want the variable to be called just hours. And then once again, we want to take the categories, but we want the variable name to be called tags. And then again, equal to restaurant. And so the variables that we now created are called restaurant name, hours, and tags. So basically this, and this. And VS Code is nice enough to put them in this purple color here too. And so you see that these three are actually the exact same name, but we were able to give them new variable names, which again is going to be immensely helpful when dealing with third-party data. And another useful feature for when we are dealing with third-party data like that, so like an object that we get from somewhere else, for example, an API call, as I was just explaining, it can be really useful to have default values for the case that we're trying to read a property that does not exist on the object. So usually then we get an undefined. For example, if we were trying to say restaurant.menu, this would be undefined because there is no property called menu. We have starter menu and main menu, but not just menu. Okay, and so we can set default values just like we can actually in arrays. So let's say that we are trying to destructuring the menu, and so we use equal to set a default value. All right, and then we can do the same with the starter menu, for example, and then we can even combine this syntax here with what we did previously. So let me show you. So let's say that we're trying to retrieve the starter menu. So this one, but we then want to give it another name. So starter menu, and we want to call it just starters. And we also want to give it a default value in case it doesn't exist. So in this case, just an empty array. Now in this case, it actually does exist. So starter menu does exist. And so therefore this default value will not apply, but it should apply to menu. Because as I was just saying, there is no property on the restaurant object called menu. So menu and starters. And so here indeed we get the default value, which is the empty array. And here we get the starter menu. And without this, we would then get undefined, as I was saying. You see? And so this is a nice way of setting a default value. And once again, keep in mind that this is especially helpful when we do not have our data hard-coded like we have it here. So this is just hard-coded data in our application, but in the real world, we usually get the data from somewhere else. And then we might not always know how exactly the data looks like. And so then it's useful to set defaults like this. Next up, we need to talk about mutating variables while destructuring objects. So we did that before with arrays when we were switching variables. Remember that? So let's see. Down here, you see that we mutated these variables that we created before. But with objects, it works a little bit differently. And so let's write that here. Mutating variables. And here let's write default values. So let's say that we already have some variables here. So A and B. And then we have this object, which has a property A of 23, property B of 7, and C of 14, let's say. All right. And now we want to destructure this object. And actually, let's first store it into a variable. That makes it a bit easier to work with it. And so now actually let us destructure this array. Now we cannot say const like a, b, because a and b are already declared up here, right? We can also not do let, because again, that would create new variables and we already have them there. Okay, so here we are missing the object that we are destructuring. But as I was saying, we cannot do this. And so in fact, we want to mutate these variables. So a should become 23 and b should become 7. But now as we save this, watch what happens. And so we get a syntax error. And the reason for that is that when we start a line with a curly brace like this, then JavaScript expects a code block, all right? And since we cannot assign anything to a code block like we did here with the equal sign, then we get this error unexpected token with the equal there. So to solve this here, the trick is to wrap all of this into parentheses. And so that's the thing that I wanted to show you here. Okay, so now if we log a and b, it will work. So you see, now we get 23 and 7. So basically we did overwrite these two initial variables, but in order to do it, we had to wrap this destructuring assignment into parentheses. All right, and now we already know how object destructuring works, and so now we need to talk about nested objects, just like we did with nested arrays. So let's say we wanted to create two variables, open and close. And these should contain the open and close hours for Friday. Okay, so you see that opening hours is an object, and then in that object, we have another object. So this Friday is an object inside an object, which itself is inside the restaurant object. Okay, now the opening hours is already an object here that we have already stored in a variable. So that's the object that we're going to destructure. So nested objects. So again, we're going to start with opening hours. And now we want to retrieve Saturday. So let's start with doing that. So just Saturday for now. Or actually Friday. So I think I said Friday. So let's see. And so indeed, Friday is this object that we get here. But remember that we actually want two variables, one called open and the other one called close. And this is how that works. So we know that this is an object, and now we can further destructure that object using this syntax. So the colon, and then again, the exact property name of that inner object. Okay. So that looks confusing, but that's just the syntax that we have to use. So maybe you don't even need to memorize this, but when you need this someday, and you will, then you can just come to this video and see how it works. And so indeed, now we get our numbers 11 and 23. And we could, of course, take this even further and even assign different variables to these, just like we did up here. So with the colon again. So we could call this one just O, and this one just C. So this is taking it to an extreme. But as I said in the beginning, destructuring is really powerful. So there's a lot of stuff we can do with it, and that's why I'm showing you all of it right now. Okay, and now to finish, let me actually show you a really cool practical application of this destructuring. And for that, we're going to go back to our object here. So to our example of this section, and now we will create another method. So many times in JavaScript, we have functions with a lot of parameters. And then it can be hard to know the order of parameters for someone that is using this function. And so instead of defining the parameters manually, we can just pass an object into the function as an argument, and the function will then immediately destructure that object. So let me show you what I mean. And let's say we want an order delivery. So that's a new function. Okay. And so here, let's just for now call this argument object. And then I will log that object to the console here. And now let me call this actually. And I will do it right here so that we can see everything at the same time. So that is restaurant.order delivery. And now here comes that object of options. So as I said, we can now specify some options here. Let's say the time of delivery, let's set it to 23:30, which is like 10:30 p.m. Let's also say address Via del Sole 21. And then we also specify the main index and the start index. So a little bit like we did up here in this function, starter index. Okay. Oh, and here we need to also give it some value. Let's just say 2 as well. And so, yeah, here right at the beginning is that object that we just defined, because here we are simply logging it for now. Okay. So what we just did was to call this function here and passing in an object of options. And that's a pretty standard thing actually in JavaScript, especially in third-party libraries. Because now here in the function arguments, we can actually do destructuring right away. So we can now say starter index, main index, time, and address, which is exactly the 4 property names that we have down here. And of course, usually we would first develop the function and then call it, but I wanted to explain you this way of calling a method with an object so that writing the object here then makes sense. All right, and so now instead of the object, since we did destructuring right here, we now actually have 4 variable names. So we can log them to the console, or actually let's do some nice string here. So let's say order received. And then let's get the food. So based on the starter index, let's just copy that from here. So this .starter menu at the current starter index, and then also the main menu. So let's again copy that, actually all of this from here. And we need the curly braces and this $sign will be delivered to, then the address, and then the time. Okay. And so indeed, we get this complete string based on the data that we passed in this single object. Okay. So that's important to realize. We only passed in one object into this function. Okay. We did not pass 4 arguments. It's really just one argument, one object. Then here in the function, as we receive that object, we do immediately destructuring. And so that's why these names here need to be exactly the names that we have down here in the object. But what's great about this is that here the properties in the index don't have to match the order in which we do destructuring up here. And so that makes it really easy for the user of this function to specify basically the arguments. All right. So this is great, but we can even use some more knowledge that we gained here, which is these default values. So we can now use this to basically set defaults here on some of these. So let's say that the starter index will be 1 if it cannot be destructured, and that the main index will be 0 and the time will be 20 hours. And so now as we call this method, restaurant.orderDelivery, I can specify the address again. Let's actually copy it from here. And let me also just specify the starter index. Okay, but then the rest will be taken from the default values that we set here for destructuring. All right, and so here as a second string, we get will be delivered to Via del Sole at 20 hours. Okay, so in this object that we passed, we do not have any property for the time, right? And so then as JavaScript did destructuring, it here took the default value of 20. Okay, and the same happened for the main index that we also did define. So it shows 0, and 0 is pizza, and that's why we get pizza here in the output string. All right. So if you ever need to write a function like this, so a really complex one with a lot of parameters that might be then hard to specify, keep this technique in mind. And this becomes even more useful as the amount of parameters increases. Let's now talk about the amazing spread operator. So we can use the spread operator to basically expand an array into all its elements. So basically unpacking all the array elements at 1. So let's say that we have an array. So 7, 8, and 9. And now we want to create a new array based on this array, but with some new elements at the beginning. So how would we do that? Well, with what we already know, we would need to loop over this array, or even worse, do it like manually. For example, like this. Let's call it the bad new array. So if we wanted to add 1 and 2 to the beginning of this array, we would have to write 1, 2, and then each of these elements, right? So that would be R0, R1, and R2. Okay, let's take a look. And now indeed we get a new array with the 3 original elements and then a 1, 2 at the beginning of that array. Okay, and this is actually quite a common operation that we need to do. And so we can now, since ES6, do it in a much better way using the spread operator. So with the spread operator, it's going to work like this. So let's create a new array. So this is the good, let's say, new array. And then again, we use 1, 2, and then we use the spread operator, which is ... to basically expand this array into all of its individual elements. So let's see the result, and then I will explain it a little bit better. So new array, and you see that we get the exact same result here. So what the spread operator does is to basically take all the values out of this R array and then write them individually as if we wrote 7, 8, 9 here manually. All right. So if we wrote it without these 3 dots, then we would have this array, so this R array inside of this one. So just like this. So 1, 2, and then an array of 7, 8, 9. And that's because here we are including this entire array. But with the spread operator, again, it's like taking all the elements out of the array and writing them here manually. And so when we do this, we then get 7, 8, 9 individually here represented in this new array. So what this means is that we can use the spread operator whenever we would otherwise write multiple values separated by commas. And that situation happens whenever we write an array literal like we did up here. So that's the first situation in which it's very useful to expand an array. And the second situation is when we pass arguments into functions. So, for example, let's say that we wanted to actually log the individual elements of this new array here. So if we simply logged the array, then it's of course going to look like this. It's just one value, which is the array. It's just one big value. But if we use the spread operator to expand the new array, then see what happens then. So now it logged the individual elements of the array. So this would be the same as writing 1, 2, 7, 8, 9 individually. So once again, whenever we need the elements of an array individually, then we can use the spread operator. And that is useful when we write an array and when we need to pass multiple elements into a function like we did here. All right, so let's see a bit more useful example. So in this example, we will create an array with one more food item in the main menu array. So that main menu is here at restaurant.mainMenu. And so basically we want to create a new menu here. So const new menu. And then let's say that we want the original array plus one new element. So we can do that by simply expanding the array. So that's restaurant.mainMenu. And then we can add other stuff. So let's say gnocchi, I think, at least that's how I think it's spelled or pronounced in Italian. And so let's have a look at our new menu. And indeed, it has the 3 original elements plus the gnocchi. And keep in mind that here we are indeed creating a completely new array. All right. We are, of course, not manipulating the restaurant.mainMenu array. So we are building a new array from scratch, and you can see that here by these square brackets. So this brackets syntax here is simply the way in which we have always been writing new arrays. And so here, again, we are writing a new array, but simply based on expanding this array and then adding another element to it. Okay. Now, you might have noticed that the spread operator is actually a bit similar to destructuring, because it also helps us get elements out of arrays, right? Now, the big difference is that the spread operator takes all the elements from the array, and it also doesn't create new variables. And as a consequence, we can only use it in places where we would otherwise write values separated by commas. And in case you're taking notes, probably what I just said would be very helpful to have as a note. Next, let's learn about 2 important use cases of the spread operator, which is to create shallow copies of arrays and to merge 2 arrays together. So let's say copy array, and so let's simply create a copy of the main menu. So main menu copy, and so let's write a new array, and into that new array we will put all the elements that are currently in the main menu. So at restaurant.mainMenu, and that's it. So here we just created a shallow copy of this array. So that's a little bit similar to object.assign that we used in the previous section. Okay, but here this syntax is actually a lot easier to use. Now to join 2 arrays together, so join 2 arrays or more, of course, we can use the same technique. And so maybe at this point you can already guess how that would work. And so you can do this actually as a challenge. So pause the video right now and create this variable menu, which will be an array which contains the whole menu. So both the main menu and the starter menu. So take a minute and try it on your own here. All right, so hopefully you managed to do that. And so the secret here, again, is to use the spread operator. So restaurant, and let's start with the starter menu. So that's going to be our first couple of elements in this new array. And then, of course, we can use the spread operator again. And then this time expand the main menu. Dot main menu. And so now we end up with an array containing all the food items that are both in the starter and the main menu. And again, because here with this spread operator, we took all the elements out of the starter menu and basically wrote them here into this new array, and then the same with the main menu. All right, so I told you that the spread operator works on arrays, but that's not entirely true, because actually the spread operator works on all so-called iterables. Now, what is an iterable? Well, there are different iterables in JavaScript, and we will talk about all of them by the end of the course. But for now, just know that iterables are things like all arrays, strings, maps, or sets, but not objects. So basically, most of the built-in data structures in JavaScript are now iterables, but except objects. So let me actually write that here for you. Iterables are arrays, strings, maps, and sets, but not objects. Now, anyway, since strings are also iterables, that means that we can use the spread operator on a string as well. So let me quickly show that to you. So let's just create a quick string here, Jonas. And then I want to create an array which contains all the individual letters and plus some other elements. So let's call this one letters. And then we create a new array and expand the string here as well. Then here I want an empty string, and then here I want an S. And now let's log it to the console, and then it will make a little bit more sense. All right. And so indeed, here we get this array where each letter of the original string is now an individual element. So just like we expanded, so we unpacked an array, we now did the same thing with a string. Now just keep in mind that we can still only use the spread operator when building an array or when we pass values into a function. So for example, we can also do this. So expand the string here, and so then it is the same thing as writing this. So J, O, and so on and so forth, right? So indeed, here now we get all the individual elements. All right. So for example, what we can do is to use this to build a string using a template literal. So here, this is not going to work. And that's because this is not a place that expects multiple values separated by a comma. So you see unexpected token. All right. So again, multiple values separated by a comma are usually only expected when we pass arguments into a function or when we build a new array. So take note of that, because that is important to understand about the spread operator. Okay, but now enough with building arrays. Let's now actually write our own function that accepts multiple arguments and then use the spread operator to actually pass those arguments. And so that's going to be a very real life example right there. So let's add here another method now. And so let's say that we want a method to order just pasta, okay? And the pasta always needs to have exactly 3 ingredients. So let's say order pasta, and it's going to be a function. And so now here we need 3 ingredients. So let's just call them inc1, inc2, and inc3. And then just log them to the console or some string. Here is your delicious pasta with, so inc1, inc2, and inc3. So up here we have an error. So this should be number 3. And then let's now call this function. So order pasta. Now what I want to do here is to actually get these ingredients from a prompt window. So remember the prompt function that we can use. And so let's create an array called ingredients. Ingredients. And each element here will be defined by a prompt window. So this here now has nothing to do with the spread operator. It's just a way so that we can actually input the data ourselves. So let's say, and here we need to escape this. So let's make pasta. Ingredient 1. And I think I didn't show you this escaping here before. So here, when we simply write this single quote here to write let's, JavaScript thinks that we are finishing this string here. Okay, and so we could use the double quotes out here, or we can escape using the backslash. Okay, now when we save this, I think that Prettier will actually get rid of this here, but it's still important to know that escaping exists. So basically this masks this single quote here so that it does not finish the string at this point. So let's save it. And so you see that now the Prettier extension actually replaced the single quote with the double quote. And so here we see our prompt already, but let's create 2 more. So let's say ingredient 2 now, and then another one. So again, here we are simply building an array of the 3 ingredients. Okay, and then we can log it to the console. So just to see A, B, and C. And so indeed, we now get this array ingredients with A, B, and C, which are the 3 strings that we just wrote there. And now, how should we actually call the order pasta function? So restaurant.order pasta. And in the old way, we would now write ingredients 0, ingredients 1, and ingredients 2, right? But since we learned about the spread operator in this lecture, we can now do a lot better. And so instead, we do this. Restaurant.order pasta. And now all we need to do is to expand the elements of the ingredient array. And that will then basically write the 3 elements of the array here separated by commas. So this and this should yield the exact same result. And so let's now test it out with some real data. So let's see, mushrooms, asparagus, and cheese. And so indeed we get now twice. Here is your delicious pasta with mushrooms, asparagus, and cheese. And what do you think is the better solution? This one or this one? And especially considering that an array could of course be a lot longer than just 3 elements. So indeed, always go with this more modern ES6 syntax here. It's an amazing addition to the language. And now just to finish this lecture here, since ES 2018, the spread operator actually also works on objects, even though objects are not iterables. So let's write that here. And here let's just write a real world example. And so let's now experiment with this. The first example here was to create a new array based on one initial array, right? And so let's now also create a new restaurant object with all the data from the original one plus some additional data. And so this is actually an amazing way of doing this because it's so much easier than with old JavaScript. So let's call this one new restaurant. And then we can simply spread the old restaurant, and this will then basically copy all the properties of the restaurant into this new object. And then we can add anything that we want. Founder, for example, let's say Giuseppe or Giuseppe, I don't really know how to say it. And of course here the order does not matter as always. So this spread here doesn't even have to be the first one. So let's say we also want the founding year, let's say 1998. Okay, and so with this we created a brand new object. Now we need to get rid of these 3 prompts there, because otherwise it's gonna drive us crazy. So let's just take this out and simply log here the new restaurant to the console. And so indeed we get our original object basically, plus the founder and plus founded in. Great. And finally, since we were able to do shallow copies of arrays using the spread operator, we can do the same with objects. So instead of using object.assign as we did it in the previous lecture. So let's do that. Restaurant copy. And so all we need to do is an empty object, and then in there expand all the elements of the original object. So the restaurant in this case. And so now if we attempt to change something on the copy, copy.name, let's call it now Ristorante Roma. And if you're Italian, you're not gonna like how that sounds. But anyway, now as we take a look at both of them, so the name of the copy and the original, now you will see that they are different. So the copy has the name of Ristorante Roma, and the old one has Classico Italiano, which means that indeed we did make a copy of the original restaurant, because otherwise, as we learned by the end of the previous section, changing one object would then also change the other one, right? Cool. So another long lecture here, but we're making really great progress. And of course, we will use all this in real projects later down the road. But again, I chose to teach you these concepts in a separate way and not inside a big project, because this allows me to show you a lot more different examples, and it also makes the material more referenceable for you in the future. And so that's going to be helpful when you're trying to find what you're looking for after taking this course. Moving on, let's now talk about the REST pattern and also REST parameters. And the REST pattern looks exactly like the spread operator. So it has the same syntax with the 3 dots, but it actually does the opposite of the spread operator. Now that doesn't seem to make much sense, right? But let me explain. So remember that we used the spread operator to build new arrays or to pass multiple values into a function. So those are the 2 use cases of the spread operator. And in both cases, we use the spread operator to expand an array into individual elements. Now the REST pattern uses the exact same syntax, however, to collect multiple elements and condense them into an array. So that's really the opposite of spread. The spread operator is to unpack an array, while REST is to pack elements into an array. And since that sounds really confusing, let's write some code. And let's start by exploring the use case of building arrays. So just to recap, in the last lecture, we used the spread array like this. So we wanted to create a new array based on an existing array. And so we used the spread operator to expand that. So here we are still using the spread syntax. And we know that this is the spread syntax because we are using it on the right-hand side of the assignment operator, so of the equal sign. So let me actually write that here. Spread, because on right side of the assignment operator. However, we can also use it on the left-hand side of the assignment operator together with destructuring. So now we're mixing kind of everything together here, but bear with me here. So let's say that we are destructuring this array. So let me first write the array here, 2, 3, 4, and 5. And so let's say I want to take the first element, store it in variable A, the second element to store in variable B, and now I can here use the rest pattern. So the same syntax, and now let's call this others. And so here it is the rest syntax because it's on the left-hand side of the assignment operator. First write that and then see the result, because on left side of the equal sign. And so now let's log A, B, and the others, whatever that's gonna be. And so 1, 2, and then basically the rest of the elements that we did not select into the A and the B variables. So what is happening here? Well, just like before, the first and the second elements become this first and second variables. But then here comes the rest pattern. And so it's called rest because it will take the rest of the elements, so the remaining elements of the array, and then put them into a new array. And in this case, we call this array others. So as I said in the beginning, the rest pattern basically collects the elements that are unused in the destructuring assignment. So let's see another example here. And this will show you that we can actually use the 3 dots on both sides of the assignment operator. So let's say that we have this array, which will be the entire menu. And so we already know how to build that using the spread operator. So we go to restaurant.mainMenu. So that's dot. So we take all the elements out of that array and put it into a new array. And then into this new array, we also put the starter menu. Okay, so this is going to be an array, a big array with all the entire menu. But now we can actually also use the rest pattern here. And so again, we do that here on the left-hand side while we are doing destructuring. So let's take a look here at the main menu. So let's say that we want to take the pizza and the risotto. Okay, so that's the first and the third. So let's create a variable called pizza. Then we can skip one variable, remember, so leaving a hole there in the destructuring assignment. Then let's call one variable risotto, and then simply put all the other food, well, into an array called other food. And now let's simply log everything here to the console. All right, so we get indeed the string pizza, the string risotto, and then all the rest of the elements that we didn't select previously into their own variables. And note here that the rest syntax collects all the array elements after the last variable. So in this case, here risotto. So it does not include any skipped elements. So it's really just the rest of the elements. And yeah, again, as I said, it does not include any skipped elements. And so for that reason, the rest pattern always must be the last in the destructuring assignment, because otherwise, how will JavaScript know until when it should collect the rest of the array, right? So for example, we could not do this. So the error message is actually very explicit. So the rest element must be the last element. All right. And also for the same reason, there can only ever be one rest in any destructuring assignment. Okay, And now let's do the same in objects, because it also works indeed in objects. So the difference then, of course, is that the remaining elements will be collected into a new object and not into a new array. So let's now work here with our opening hours. And let's say that we want to select only Saturday here. And then the rest should go into a new object, which are the weekdays. So Saturday is weekend, and Friday and Thursday are the weekdays. And so basically we want to create an object only with these two. So only for the weekdays. And now that is easy to do. All we need to do is to basically take out Saturday into its own variable, and then we simply collect the rest into a new object. And this we can call weekdays. Okay. And then here, of course, the object that we are destructuring. Dot opening hours. And now let's take a look at our weekdays here. And indeed, it is exactly what we were expecting. It is an object only containing Friday and Thursday. And again, that's because we already took Saturday into its own variable before. And so this then collected the rest of the properties into its own new object. Great. So now we know how the rest pattern works to collect elements in a destructuring assignment. And actually, let's write that here. So this whole first part is for destructuring. And then the second part will be about functions, basically. So remember that also for the spread operator, the second use case was to pass multiple arguments into a function all at the same time. So that's exactly what we did here in our real example with this ingredients array, right? So we had an array, and then we expanded all of these elements of the array to basically pass these elements then as individual arguments of the function. And so now, as you can guess, the rest operator can basically do the opposite. And so let's now write an example function for that. So I'm going to call it add. And so in a real adding function, we want to take an arbitrary amount of arguments and simply add all of them together, right? So function, and for now, let's just leave it like this. And so let me illustrate how we want to call this function actually. So we want to be able to do, for example, this 2 and 3. It should give us 5. But then we also might want to be able to do this 5 and 3 and 7 and 2, for example. So again, any arbitrary amount of arguments should work for this function. So something like this, for example. But of course, we're not going to specify like 7 arguments here, right? So how can we do that? Well, we will use the rest pattern. And in this case, it is actually called rest parameters. So let's use the rest syntax, and then let's call this argument numbers. And here, let's then log these numbers to the console. So this function is going to be called 3 times. And so we are expecting 3 results here. And what we see here is 3 arrays with all the arguments that we passed into the functions. But they are indeed arrays. And so now, once again, as I said in the beginning, the rest syntax is taking multiple numbers or multiple values and then packs them all into one array. So once more, it is doing the opposite of the spread operator. So with the spread operator, we expand. With the rest syntax, we compress. So here it's called rest arguments. Okay? And now we can write some simple logic here to actually add all the numbers together. I believe we already did that. So here is our sum variable that's going to be accumulating. Then let's write a simple for loop. And you could also do this here as a challenge if you want it. But anyway, I will just do it right away. So we know that numbers is an array, and so we can take the length of that array and run this loop as long as the counter is below the length of the array. And in each iteration, we simply add the current number to the current sum value, basically. So I'm writing this really fast because we already did this before. All right. And so this should be nothing new at this point. And now to finish, we can log this sum to the console to get some results. And indeed, this here is now 5. And so this is at this point a working function which can accept any number of parameters. And hopefully you're not confused yet by this. And now I want to take it even to the next level. So let's create yet another array. Let's just call it X because it's not important. And I will put in numbers 23 and let's say 5 and 7. So now if we wanted to take these values here and call the add function with these 3 values, how would we do that? Well, simple enough. We simply use the spread operator. And that's it. And so this is exactly what we learned in the previous lecture. So we're taking all the numbers of the array and spreading them here. And so this would be the same as writing manually 23, 5, and 7. And so this is a good example of showing you how spread is the opposite of rest. Because after these numbers being spread here, they will then enter this add function here, and then they will immediately be collected into this numbers array by the rest parameters. Okay? So here we unpack the values, and here we pack them back again into an array. And you could actually be wondering why we are not simply writing an add function which takes an array as an argument, and then we don't need all of this. Well, it's way better to do it like this, because then the function can accept both an array, basically by doing this, and simply all the single values, like this. And also it feels a little bit more natural to simply pass as many arguments as we want to add together into the function. So without having to deal with arrays if we don't want to. And so this rest parameters is something that you will see all the time in modern JavaScript code bases. Okay, and now just to finish this, let's actually use rest parameters in our restaurant example here, also to see some edge cases. So let's add yet another method here. And this time the method is going to be about ordering pizza. So order pizza. And now pizzas need to have at least one ingredient, but the other ingredients are optional. And for this, rest parameters are perfect. So let's say main ingredient, and then the other ingredients. And so now this is going to work a little bit like destructuring again, where then this here basically will collect all of the rest of the arguments into an array. So let's see that. So main ingredient, and let's log the other ingredients. Okay, and so now let's order pizza. So restaurant.order pizza. And now here we specify our ingredients. So let's say mushrooms, onion, olives, and spinach. So nice vegetarian pizza right here. And so you see, we can specify as many arguments as we wanted. Let's save this. And you see down here immediately that we get mushrooms, which is this first ingredient here. And then we get an array of all the remaining ingredients that we passed in. And so this, of course, is the result of the rest arguments. So again, the first argument was stored into this main argument here. And then all the remaining arguments that were passed in were simply stored into this array by the rest parameter syntax. Okay. And of course, we could also simply define just one. So let's order now a pizza with only mushrooms. Then the remaining arguments here will simply be put in an empty array because, of course, there are none. And so there's nothing to collect into the array, but we still get an empty array that we can work with if we want. So in that function, we could now create some logic, like to create a string based on all of these ingredients, but I'm not going to go into that right now. But if you want to have some fun, then feel, of course, free to do that by yourself. Anyway, the takeaway from this example is that, once again, the rest parameters serves to collect all of the remaining, basically unused parameters that were not used in this parameter. All right, so let's recap after yet another quite long lecture here. So the spread and the rest syntax both look exactly the same, but they work in opposite ways depending on where they are used. So the spread operator is used where we would otherwise write values separated by a comma. On the other hand, the rest pattern is basically used where we would otherwise write variable names separated by commas. So again, the rest pattern can be used where we would write variable names separated by commas and not values separated by commas. So it's a subtle distinction, but this is how you know when and where to use spread and rest. Let's go back to two logical operators that we already used before, but we didn't use their full potential yet. And I'm talking about the AND operator and the OR operator, and how we can use them for something called short-circuiting. So up until this point, we have used logical operators only to combine Boolean values. But the truth is that we can do a lot more with the AND and OR operators. So let's start with the OR operator here. And so let me log 3 or Jonas. So that's something that we didn't do before, which is to use basically non-Boolean values here as the operands. Okay, so let's see what the result of this is going to be. And for some reason I have to reload here. And you see that the result is 3. And so that means that the result of the OR operator doesn't always have to be a Boolean. And so that's something that I didn't show you before. So there are 3 properties that I didn't tell you before about logical operators. So first, they can use any data type. They can return any data type, and they do something called short-circuiting. Or as we also call it, short-circuit evaluation. So in fact, here we used 2 values that are not Booleans, okay? And it then returned a value that was not a Boolean. And now about short-circuiting. In the case of the OR operator, short-circuiting means that if the first value is a truthy value, it will immediately return that first value. So that's exactly what we see here with the 3, which is a truthy value. So again, if the first operand is truthy here in the OR operator, then the other operand will not even be evaluated. So JavaScript will not even take a look at it. And so that's what we mean with short-circuiting. And now let's do some more. Let's use the empty string or Jonas now. Then let's say true or 0. And then let's say undefined or null. And now, before taking a look at the result, try to take a guess of what the result of these three operations here will be. So did you do that? So let's see. So the first result of this one here is Jonas. And so that's because this here is a falsy value. And so then the second operand will actually also be evaluated, and that's Jonas, and it will then be returned. And so here we see again that the result of the OR operator doesn't have to be a Boolean. It will simply return the truthy value here. Next up, we have true or 0. And so this first value here is truthy, and in fact, it's even true, and so therefore that will simply be the result of the operator. And so that's what we see here. And then here we have undefined or null, and as you already know, undefined is a falsy value, and so we then go to the second operand, so there is no short circuiting, and so that's then the one that's going to be returned. So here we see null, and that happens even though null is also a falsy value. And let's actually now generalize this to more operators, so I can give you basically the general rule of how this operator works, no matter with how many values. So let's say undefined or 0 or empty string or hello or 23 or null. So what do you think that the result of this one will be? And it is hello. And that's essentially because hello here is the first truthy value in this chain of OR operations. So we start with this one. So undefined is falsy. And so then we go to the next one, which is also falsy. And so then to the next one, which is also falsy. And then we get hello. And hello is truthy. And so therefore it will short circuit the entire evaluation, and it will be the returned value. Okay? And if we think about this, then it actually makes sense. Because remember, in the OR operation, the result is true if at least one operand is true, right? So if the first operand is already true, for example, as it happens here, then JavaScript doesn't even have to look at the other values, because the result of the expression will already be true anyway. And so it will short circuit and then simply return that first result. And now let's see a more practical application of this. So let's say that there might be a property on the restaurant object with the number of guests. So something like this, restaurant.num guests. But again, we don't know if it exists. However, we want to basically define a variable based on this number of guests, and we want to set a default value if this doesn't exist. So basically, what we want to do is this. So guests, I'm going to call it 1 here. And so what we want to do is this. We want to check if it exists, and then the result should be actually restaurant.numGuests. But if it doesn't exist, then we want to set a default value of 10. So let's log guests1 to the console. And so you see that now it is 10. And so that's because restaurant.numGuests doesn't exist. So this is undefined. And so therefore 10 will be the result of this ternary operator. Okay, but now if we do set the property like this, for example, to 23, then guests1 is going to be 23. So, but instead of doing this, we can take advantage of short circuiting and the OR operator. So let's again write restaurant.numGuests and then simply OR 10. So let's analyze why this works. And first actually store this into a variable. So guests2 equals this, and then console log guests2. So let's take a look at why this works, and starting again with disabling this. And so right now, restaurant.numberOfGuests is undefined. So it's a falsy value, and as we already know, then the second value here will be the result of the OR operator. And so that's basically our default value of 10. So let's take a look. And indeed, we get 10 here. But now if we put it back on, then restaurant.number of guests is now 23, which is a truthy value, and therefore the OR operator short circuits and it will become the returned value, or let's say the result of the operation. And so now indeed we get 23. And so this is a way easier method of setting default values than having to deal with this ternary operator, or even worse, an if-else statement. Okay, so that is short-circuiting with the AND operator, but we can also do the same with the OR operator, but the AND operator also has short-circuiting. So let's take a look, and we'll start by log something to the console here, like a string to separate, so that we don't get confused by the results in the console then. Oh, but before we talk about the AND operator here, there's actually one more thing that I need to tell you here, which is that both of these solutions here, this and this, will not work when the number of guests is 0. So let's see what happens. And so now they're both 10. And that's not the result that we want, but given what we already know, it makes sense. Because this is now 0, so it's a falsy value, and therefore the second one here will be the result of the operation, and therefore assigned to guests too. However, 0 is the real number of guests, and so that's the value that we actually would guests to have. But instead, it set the default value of 10. So that's obviously not what we want, and we will explore a great solution to this problem actually in the next lecture. But now, let's talk about the AND operator. And basically, when it comes to short circuit evaluation, the AND operator works in the exact opposite way of the OR operator. So let's see, 0 and Jonas, and now the result of this is 0. And so what this means is that the AND operator short circuits when the first value is falsy, and then immediately returns that falsy value without even evaluating the second operand. So again, that's exactly the opposite of what happens with the OR operator, which short circuits when the first operator is true. So let's now set it to a true value here, or actually a truthy value, and then in this case, Jonas is actually returned. So when it is truthy, it means that the evaluation continues, and then simply the last value is returned. And once again, this makes sense if we think about it. So the AND operator is only true if all the operands are true. And so if the first one here is false, then it means that the entire result of the AND operation will already be false anyway. And so there's no need to even look at any of the other operands. So I think that's a good way to memorize how both of them work. Anyway, let's again generalize this to multiple operands here. And 23, and null, and Jonas. And so what do you think this time the result will be? Well, let's see. And it is indeed null. And to understand why, let's apply the same logic as before. So this is a truthy value, and therefore the evaluation continues. 23 is also truthy, but then null is a falsy value, and therefore the evaluation no longer needs to continue, because at this point the whole result of the AND operation is going to be false anyway. And then as a result, this is then simply the value that's going to be returned, and it short circuits the rest of the evaluation. So it will not even take a look at Jonas here. All right, and so now let's see another practical example. So let's say if restaurant.order pizza, So basically we're checking if this method exists, and then if it does exist, we want to call it. So restaurant.order pizza, let's say with mushrooms and spinach. So many times we can use the AND operator to actually avoid an if statement like this one, where all we want to do is to check if a certain property or value actually exists. Okay, so in this case here, what we're doing is to basically pretending that we don't know if order pizza exists. And so we first check if it exists, and only then we execute it. And so this now gives us mushrooms and spinach, but with the knowledge that we gained about the AND operator, we can do this in a simpler way. So we can say restaurant.order pizza and then basically if restaurant.order pizza does not exist, so it's undefined, it will then short circuit the evaluation and nothing else will happen. And so that's essentially exactly the same as this if block here is doing. All right, but if it does exist, so if it's a truthy value, then the second part here will be evaluated. And so here in this second operand, we can then call the function. Okay, and it's perfectly fine to use this operand, the second operand here, to call a function. We can put anything here. It doesn't just have to be a single value. Now, I'm not saying that you should go ahead and replace all your if statements with the AND or the OR operators. So please definitely don't do that, because it's going to make your code very hard to read in the future. But anyway, let's now summarize. So the OR operator will return the first truthy value of all the operands, or simply the last value if all of them are falsy. So that's what happened here, right? On the other hand, the AND operator will return the first falsy value or the last value if all of them are truthy. And as for practical applications, we can use the OR operator to set default values, and we can use the AND operator to execute code in the second operand if the first one is true. So play around some more with this maybe, and then let's just move on to the next video where we will solve this problem that we had here with this OR operator and this 0. Let's now learn about the new operator with the funny name of Nullish Coalescing operator. So in the last video, we used the OR operator to set a default value in case that the first value was a falsy value. So let me bring back that code here actually. So this one, but we're only interested in the OR operator here. So let's call this one simply guest. And so let's again remember what happens here, which is when we set numGuests to 0, then JavaScript will still take this default value here and assign it to guests, because 0 is a falsy value now, and so therefore we go to the second operand. However, fortunately for us, there is a very good solution to this. And that's the new operator with the very weird name of Nullish Coalescing operator. It's an operator that was introduced in ES 2020, and it works like this. So guests, let's call this one correct now. And so it works almost the same way as the OR operator. Really almost the same, but it will fix our error here. So let's see that it does. And then I will explain you why that is. All right, and now indeed we get 0. So we get the real value that is actually here. And now if we take it off, only then we get 10, which is the default value that we want. So why does this work? Well, it is because the Nullish Coalescing operator works with the idea or with the concept of nullish values instead of falsy values. And nullish values are null and undefined. That's it. It does not include a 0 or the empty string. So basically, for the nullish coalescing operator, it is as if the 0 and the empty string were not falsy values and were instead truthy values as well. But again, this operator does work with the principle of nullish values. And so only nullish values will short circuit the evaluation here. Okay, so only if this was null or undefined, only then the second operand here would be executed and returned. And so right now that's the case, as number of guests does not exist. So we commented it out here. And so now it is undefined. And so only then the evaluation continues. But again, as we put it back, it now is 0. And 0 is not a nullish value. And therefore the evaluation here is short-circuited. And immediately this first non-nullish value is returned. All right, and that's actually all for now about this nullish coalescing operator. It's a really great and really useful operator, even though right now it might not seem that useful. But as we go through the project, you will see that it really is. Now, even more modern than the nullish coalescing operator that we just talked about are 3 new so-called logical assignment operators that were introduced in ES 2021. So let's see how they work. And in order to do that in an effective way, let's quickly start by creating 2 new restaurant objects. So I'm going to call them Restaurant 1 and Restaurant 2, and they are extremely simple. They just have a name, and then this one has a property, number of guests, and let's set it to 20 here. And then there will also be a Restaurant 2. And in fact, let's just duplicate this one here. Restaurant 2. Call this one La Piazza. And this one actually doesn't have the number of guests property, but it has an owner. So Giovanni Rossi or whatever. Okay, and the first thing that we want to do now is to set a default number of guests for all the restaurant objects that do not have that property. So in this case, it is just this restaurant here, but let's pretend that we got them, so that we got these restaurants from some kind of API, and now we want to apply something to all of them. So in this case, basically adding the number of guests property to the objects that do not have them. And let's start by using the tool that we already know about to do this. And so that is the OR operator. So we already know how we can do this using the OR operator, right? So let's say rest2 dot number of guests should be equal to rest1 dot num guests or 10. So let's quickly remember that this works because of short circuiting. So in the OR operator, if the first value is truthy, so this one here, then that first value will immediately be returned and the second value will not even be evaluated. So that's this one here. And so by doing this, and here actually should be num guests. So again, by doing this, here we are returning the number of guests if it does exist, so if it's not falsy, and otherwise the 10 is going to be returned. Okay, and in fact, let's duplicate this line here. But first I should fix it, because of course the number of guests in Restaurant 2 should be set based on the number of guests that are in Restaurant 2 or not. But anyway, I'm duplicating this now, and then doing it for both restaurants here so that we can see the result. here for both objects. So let's see. And here we go. So the second one here didn't have a number of guests, and so now numGuests is 10. And again, that is because of short circuiting. So this here returned undefined, and so then the second one got returned. While here, in this one, this value was 20, and so it is this 20 that immediately got returned. So nothing new up until this point, but now let me introduce the very first logical assignment operator, which is the OR assignment operator. So with that operator, we will be able to write the same thing basically in a more concise way. So rest1.numGuests. And now instead of repeating the same thing again, like I did here, I can simply write OR equal, and then 10. And that's it. So this here is exactly the same as this one, but in a more concise way. Okay. Let's do the same for restaurant 2. And if we comment out these two now, then as you see, the result is exactly the same. Great. So let's write here the OR assignment operator. And basically this operator assigns a value to a variable if that variable is currently falsy. So again, exactly what's happening here, because this variable is currently falsy, and so it will be assigned the value of 10. Great. So that works beautifully, except in one situation that actually we already encountered before in the previous lecture. So let's actually duplicate this here, comment out this one, and now setting the number of guests to 0, which is a perfectly reasonable number, right? But look what happens if I then run this code again. As we can see here, it is back to being 10, even though we set it to 0 here. So can you guess why that is happening based on what we learned in the last lecture? Well, 0 is actually a falsy value. And so this OR assignment operator is actually working just fine. So this here right now is falsy, and so therefore it will then be assigned this value of 10, which is exactly what this operator does. So again, the logical OR assignment operator will assign a value to a variable if that exact variable is falsy right now. However, fortunately, we have a good way of solving this. So let's copy all of this, put it here, comment out these two because they don't really work. And so here we actually do also have the logical nullish assignment operator. Sounds a bit complicated, but really all it is to change the OR for the nullish coalescing operator. So let's actually write that also here. Nullish assignment operator. So if I save it now, then it is back to 0 here. And that is exactly the correct result here. Let's just remember here that nullish basically means null or undefined. And right here in restaurant 2, the number of guests is undefined. And so therefore, then the 10 will be assigned to that variable. And so in a nutshell, the nullish assignment operator will assign a value to a variable if that exact variable is currently nullish. So again, that is the case in restaurant number 2. Okay, and as you can probably guess, we do also have the logical AND assignment operator. And to learn about that one, let's say that we want to anonymize the names of the restaurant owners. So when there currently is an owner, like here in this object, we want to basically replace this string here with the string anonymous. So how could we do that? Again, using the tools that we already know. Well, let's say rest2.owner, and now let's use, for now, just an AND operator. So we can say rest2.owner and then let's write it like this. Anonymous. Okay, let's see for now if this worked. And indeed, it did. So it replaced the string that we had here before with this anonymous. And so let's remember why this works. Well, once again, it is because of short circuiting. And in the particular case of the AND operator, it short circuits when the first value is falsy, and then immediately returns that falsy value. So in this case, that's not what's happening. So this is truthy right now. And so therefore, the second value will then actually be evaluated and returned. So if we duplicated this, like this, then you see that it's now actually being set to undefined because, well, the restaurant1.owner does not exist. So that property is not here. And so this value is undefined. And since the AND operator short circuits when the first value is falsy, well, then that is the value that is immediately returned. So again, we already learned about that a little bit earlier in the section. And so that's why I'm not going really deep into the details here once again. What I will go into detail is that we can now replace, once again, this duplicate variable here. So basically replacing it with the AND assignment operator. So for doing that, I can write rest1 and equal, and then here, let's just copy this string. All right, and copying it for restaurant2. And I can then comment these two out. And just for the sake of completeness, let's also write it here. Oh, and we get an error here. And that's, of course, because I forgot the number of guests. And actually, it is .owner, of course. So .owner, let's see. And there we go. So the owner has been replaced with anonymous in this case. And here in the case of the first restaurant, the result is even better now than what we had before. Because with this code here, we actually had the owner then set to undefined, which was not really what we wanted. Now it is simply not here. And so basically what the logical AND assignment operator does is to assign a value to a variable if it is currently truthy. All right. So clearly this here was falsy because it didn't exist. And so then nothing happened. So the object stayed exactly the same. Then here, this here was indeed truthy. So it was Giovanni before. And so it was replaced now with this other string. And so again, if you ever need to assign a value to a variable that is already defined, so that has a value that is currently truthy, then you can use this AND assignment operator. Let's now talk about a new way of looping over arrays, which was introduced in ES6, and that's the for-off loop. And let's say we wanted to loop over our entire menu here. So let's start by creating again the array with the entire menu. And for that, we expand restaurant.starter menu and restaurant.main menu. So nothing new at this point. Now you already know how to loop over this array with a regular for loop, right? So you would have to go through all the steps of setting up a counter, a condition, and also update the counter. And that's a lot of work. And so that's why we got the for-off loop now, in which you don't need any of that. It's so much simpler. And this is how it works. We still write for, and then we create a variable here. Let's just call it item for now. And then of menu. And then we can log to the console simply this item. So let's see if that works. And then I'm going to explain why it works and what this loop does. So indeed, we got all our elements here now individually logged to the console. So this for-off loop which is called for_of because it is for and then item of the menu, right? So this loop will automatically loop over the entire array, and in each iteration, it will give us access to the current array element, which we can specify here. So in this case, it's called the item, but of course we could call it anything that we want. And so if we simply log the current item then to the console, well, then this is here what we get. Simply each element logged one by one. And that's because, again, the item variable is always the current element in each iteration. And also, just like in the if-else statement, we don't need to create a code block when we only have one statement here to execute. Okay, so that's pretty simple, but it's a really nice level of abstraction over the regular for loop. So we can do the same thing with this one, but without having to worry about all the underlying details such as counters and conditions. What's also great about the for_of loop is that we can still use the continue and break keywords. And this is important because in the next section you will learn other ways of looping arrays, and in those one you will not be able to continue or to break. So you will need to keep that in mind. But now, what if we also wanted the current index and not just the current element? Well, in the for_of loop, it's actually a bit of a pain when we need that index, because originally the for_of loop was really just meant to give you the current element. However, you can get both, and you will have to do it like this. So for, and then again, let's just call it item. But now instead of just menu, we now need to call the entries a method on this array. So entries. And then let's take a look at the item. And so, as you see, each of the item is now actually an array with the index and the array element itself. So let's quickly take a look at what this mysterious menu.entries actually is. So menu.entries. And so here we get this weird array iterator. And so that's not really helpful, but we will learn about iterators by the end of the course. But if we want to take a look at this, we need to essentially expand this here using the spread operator and then create a new array based out of that. So again, this is really just to take a look at what menu.entries actually is. And so we see that it is basically an array which in each position contains a new array, which contains the element, so the element and the index number of that element in the original array. And so that's why we get 0, 1, 2, 3, 4, 5, 6, plus all of the original elements of the menu. And that's also the reason why then we get this output from this loop now. Because here we now basically have that array, and so now each item of that array is, well, this new array. And so now if we wanted to like print a nice menu, then we could take advantage of this data now. So let's now log something nicer here. So a template string. So let's take the first element, which is 0, and then let's actually add 1 to it so that we can start the menu at 1. So here we're basically going to display like a nice menu in a real restaurant. And so there the numbers don't start at 0, right? And now here, then the actual item itself. So that's at position number 1. And so that looks quite nice, doesn't it? So this works great here, but we are actually at this point smarter than doing it like this. And that's because if item is now an array, we can destructure it. We don't have to manually take element 0 and element 1. That is the old school way. So let's now do it in a better way. And so we can actually destructure the item array here, right here, all we have to do is to use the destructuring assignment and then create the two variables that we want. So let's call it I and el for element. And so here we can use I and here element. So let's check that. And indeed, it works the same. And so once again, destructuring made our lives a little bit easier here. So it's a really great addition to the JavaScript language here, once again. And the same is of course true for the for-off loop itself, which also makes it a lot easier to loop over arrays. So maybe you've been noticing that we have been talking a lot about ES6 features and even newer additions to the language. And so let's continue with that now with yet another enhancement, which is enhanced object literals. And so let's take a closer look at our restaurant object here. So this restaurant object is an object literal. So you can see that because we basically wrote this object literally in our code using this curly braces syntax. So, well, you get the point. So all of this object here has been written using the object literal syntax. Now ES6 introduced 3 ways which make it easier to write object literals like this. And so let's go through them one by one now. First off, let's say that we have an object that is outside of this object. So let's take this one and create a separate object with it. So const opening hours equal. And so now this is its separate variable. Now here we need a semicolon to fix this error there. But now we still want to have the opening hours object inside of the restaurant. So before ES6, we would have to write opening hours. So that's the property name that we want. And then set it equal to opening hours. And so then basically the restaurant object is restored. Let's see that here quickly. So you see that here we still have the opening hours just like before. Now, the problem here is, and it's not really a problem, but it can become annoying, is that this property name is exactly the same as the variable name from which we're getting this new object, right? And so with enhanced object literals, you don't need to write this. So we can just do this. Let me write this here, ES6 enhanced object literals. And so what this will do now is to take this opening hours object and put it into the restaurant object and create a property name with exactly that variable name. So as we will reload now, then you will see that it's still here just like before. And of course we could change this now, but then we would also have to change it here. Otherwise, JavaScript will not know what this variable is. And so now, as you can guess, we have a property called hours. All right, so that's a very handy enhancement. And so let's now check out the second one. So the second enhancement to object literals is about writing methods. So in ES6, we no longer have to create a property and then set it to a function expression like we have always been doing, right? So essentially, we create a property just like we do all the other properties, and then we set that to a function expression. But again, now we no longer need to do that. We can write it in an easier way, which is to get rid of this function, even of the semicolon, and then just like this. And so this now works exactly the same as before, but with a slightly easier syntax. And I actually personally really prefer this new syntax. So I'm going to change this entire object to the new way of writing methods. But this actually comes down to personal preference once again. So if you prefer the old way, you can just keep it like that. So maybe you think it's more explicit if you can actually read the function keyword there. But for me, it's enough that we have the parentheses here. So that alone already shows that it has to be a function. And VS Code itself is also helpful as it changes the color of the methods to green. So VS Code is really smart in that regard. And finally, the third enhancement is that we can now actually compute property names instead of having to write them out manually and literally. And compute just means like calculate. And so let's try that here. So let's say that we had an array with all the weekdays. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And now we wanted to take these property names here out of that array. Okay, so instead of having to write them here manually. So we can do that by using, again, the square bracket syntax. And then in here, we can put any expression, basically. So this was Thursday, so let's say weekdays on position number 0, 1, 2, 3. And of course, we could use destructuring here, but yeah, this is just a demonstration anyways. So weekdays 4, and then here weekdays 5. But let me just show you that we could really do anything here. So we could also compute the name in some other way. Let's just say 2 plus 2 or 2 plus 4. So this doesn't make sense, but yeah, I just want to show you that we can do this. Let's take a look at the object now here, opening hours. And so you see that we still get Thursday and Friday, and then here we get day 6. So we computed this property name using a template literal and then also this expression in here. And this is sometimes extremely helpful to be able to do this. So before we could only compute the values. So here, for example, this could be 12 plus 12, right? But we could not compute these property names, but now we can do that as well. Let's learn about an even newer feature of objects and also of arrays, which is called optional chaining. And this one is really amazing. So let's say that we wanted to get the opening hours of our restaurant for Monday. So let's quickly check that. So restaurant.opening hours. And then, since we are checking for Monday, let's try .mon, so which could stand for Monday. Now actually this property doesn't exist. So you see that this is undefined, right? But let's pretend that we do not know whether this restaurant opens on Monday or not. And that could be the case, for example, if this data came from a real web service, so a web API. And in that service, there could be multiple restaurants and not all of them would open on Monday. And so we had no way of knowing if this particular restaurant would open on Monday or not. But now let's go even further, because we actually want to know exactly the hour on which the restaurant opens on Monday. So let's see what we get. And now we do actually get an error, because the result of this was undefined, and then undefined.open is really an error. So that's the error that we get here. So in order to avoid this error, we would first have to check if this here actually exists. So we could do something like this. If this property exists, basically, then do this. Or we could also use a logical operator, as we already learned, but this here is a bit more readable. All right. So if we did the same for, let's say, Friday, then we already know that Friday exists, and so this would then work, and it would be 11. But let's focus here on Monday, which is the day that doesn't exist. And so now at least we get rid of our error here. So it's not a big deal to having to add this logic here, but it does make our code a little bit more unreadable and more messy. However, this is checking just for one property, so just for Monday. But now imagine that opening hours here would also be optional. Or in other words, that maybe the restaurant object can also not have opening hours. So in this case, we would have to check for both, right? So we would have to do if restaurant dot opening hours exists, and if restaurant dot opening hours dot Monday exists, well, only then log the opening hours to the console. And this can get out of hand pretty quickly when we have deeply nested objects with lots of optional properties. And sometimes that happens in the real world. And so therefore, ES 2020 introduced a great solution for this, which is a feature called optional chaining. And with optional chaining, if a certain property does not exist, then undefined is returned immediately. And so that will then avoid that kind of error that we saw earlier. And this is how it works. So let's recreate it now with optional chaining. So now we can say restaurant dot opening hours dot Monday, and now here is the optional chaining operator. So instead of just a dot, we use question mark dot and then open. Okay, so here is how optional chaining works. So only if the property that is before this question mark here, so only if Monday exists, then this open property will be read from there. All right, but if not, then immediately undefined will be returned. And exists here actually means the nullish concept that we already talked before. So a property exists if it's not null and not undefined. Okay, so if it's 0 or the empty string, then it still exists, of course. So if we try this now, then we get undefined. So that's exactly what I was saying. And let's just, again, recreate it here without the optional chaining, just to see the error again. And so here we would indeed get the error. Again, because all of this here is undefined, and then we read open here from undefined, which doesn't work. But here, this next operation of trying to read open only happens if all of this here actually exists. So if it's not null and not undefined. But if it is undefined or null, then the result will be undefined immediately. So let's take this out again. And so that is why we get undefined right now. And of course, we can have multiple optional chainings. So let's basically recreate what we have here. So in this example, so here we are testing for both opening hours and for Monday. So these are essentially the two optional properties that we do not know beforehand if they exist. So Monday is optional, and that's why we have the question mark here basically asking if it exists. And now we can do the same for opening hours. And now if restaurant.opening hours does not even exist, well, then the Monday property will not even be read. And so therefore we don't get that error. All right. And so this makes it really easy to prevent all kinds of bugs that sometimes we might not even expect. All right. So it also takes away all this work of doing this simply by adding this simple question mark in there. But now let's see a little bit more real world example. And for that, let me grab this weekdays array and put it here. Let's just call it days here, so it's not the same variable. And now what I want to do is to loop over this array and then log to the console whether the restaurant is open or closed on each of the days. So that's a good application of optional chaining right there. So let's start just by logging here the day, just so that you can remember how this loop works. And so indeed, now we can do some code with each of these days here. So let's now essentially do the same as we did up here. So restaurant dot opening hours, but now we cannot do this, right? Because this is not an actual property name of the object. And so remember, if we want to use a variable name as the property name, basically, we need to use the brackets notation. So we learned about this way back in the fundamentals section. And so make sure to remember that. Okay. So basically this would be the same in the first day dot Monday and then dot Tuesday and so on and so forth. But the day here is coming dynamically from this array. Okay. But optional chaining, of course, also works with that. And so now we can ask if open exists, basically. And now let's save this to a variable. And then let's log to the console. And this is not yet complete, but for now, let's see what's going to happen. So on day, and then whatever is the current day, we open at, and then here we use the open variable that we just created. Let's get rid of this console.log here. Okay. So we get on Monday, we open at undefined, undefined, undefined. And then indeed on Thursday, Friday, and Saturday, we are open. And so then we get the opening hour that is actually also in the object. Let's just make sure. So this one is open 12, 11, and 0. So essentially it's open 24 hours. It opens at 12 and closes at 24. So at midnight again. All right. So that's working. But now we don't want this undefined here. Okay. And so just like before, let's set a default value. So let's use or. And so as a default, we want to say closed. So we are open at closed. So that doesn't make a lot of sense. So we could create a better sentence there, but let's leave it like this. But maybe you're noticing that now we have a problem, which is that on Saturday it says that we are closed, although actually we open, or the restaurant opens. So here on Saturday, which is this one, indeed, this property exists. So there is a property called Saturday, and so we have a problem here. And the problem is that the restaurant opens at 0. And so here we have the same problem as before, where 0 is a falsy value. And so therefore, it will then trigger this second part of the operator. But we also saw the solution to this, which is to use the nullish coalescing operator. And so that's what we do now. And now we get back to open at 0. Great. So this is an amazing use case of the optional chaining operator and the nullish coalescing operator working together. And in fact, they were introduced into the language at the same time in ES 2020 because they were really designed to work well with each other. So again, both of them rely on this new concept of nullish. And so nullish values are null and undefined. And that's it. And so that's true both for this nullish coalescing operator and also for optional chaining. Okay, great. Now that you understand how it works, let's move to the next topic, which is on methods. So optional chaining does indeed also work for calling methods. So essentially, we can check if a method actually exists before we call it. So restaurant.order, and now we can check if it exists. So we use the question mark dot, and if it does exist, then we can call it. So let's just pass 0 and 1 here. And then we should always use together the nullish coalescing operator. And so method does not exist. So let's run this. But in this case, the method does actually exist. And so here we get the expected result. When we try to call a method that doesn't exist, so let's say order risotto, and so we never wrote a method for that. And so let's see. And yeah, now we get method does not exist. And so just like before, this optional chaining operator will check if order risotto actually exists. And if it doesn't, well, then it will immediately return undefined. And so all of this then returns undefined. And so here in the nullish coalescing operator, we immediately go to that second operand. So that's this one here. And yeah, then that's the result of this whole operation. So of course, if we hadn't this, then we were trying to attempt something that is not a function. So really useful on methods as well. And finally, optional chaining even works on arrays. So basically, we can use it to check if an array is empty. So let's simply create a users array in which we can put a couple of user objects. So name, Jonas, and email hello@jonas.io. And yeah, this is just for demonstration, so let's just put one object here. And now to get the name of the first element of this array, we can do this. We can write users element number 0, and only if it exists, so optional chaining, only then take its name. Okay? And otherwise, we want to log user array empty. So let's see. And indeed, we get Jonas. And so again, this optional chaining here tests if the value on the left does exist. So users 0. Okay, so if it was empty, so users, so like this, then we get user array empty. And without optional chaining, we would have to write something like this. So if users.length greater or equal 0, then console.log this here. And else console.log user array empty. All right. And so that looks like a lot more work than what we just have up there. So here we don't need to do any check. So that's a lot better. And so now in both cases, we get Jonas. So get used to this optional chaining operator, which almost always we use then together with the nullish coalescing operator, so that we can actually do something in case we don't get a result from the object or from the array that's here on the left-hand side. All right, and with that being said, I see you in the next video. So we learned about the for-off loop to loop over arrays, which remember is an iterable, but we can also loop over objects, which are not iterables, but in an indirect way. Now we have different options here depending on what exactly we want to loop over. So do we want to loop over the object's property names, over the values, or both together? And let's start by simply looping over property names. And so remember, they are also called keys. Now ultimately, we will still have to use the for-off loop to loop over the array, but again, we're going to do that in an indirect way. So we're not actually looping over the object itself. Instead, we're going to loop over an array. So let me show you how. So I'm going to call this day, and you will see in a moment why. And now off, and then I say object dot keys, and we pass in the opening hours object. And now let's simply, to see what happens here, log the day variable to the console, and then I will explain what happened here. So indeed we get Thursday, Friday, and Saturday, which are exactly the three key names of the object. So we can see that here. So indeed, Thursday, Friday, and Saturday. So let's take a closer look at this mysterious object.keys. And let's do that here before, actually. So let's just say properties equal object.keys. And then again, opening hours. And now I want to take a look at the result here. And so indeed, it is an array with the three property names. Okay. And we can actually also use this to now compute how many properties are in the object. So let's say we wanted to print a string saying how many days the restaurant is open. That would be simple, right? We can just log to the console. We are open on, and then properties dot length. And now we get the number of properties here, of course. And so that's 3 days. Okay. And so this is also the array that we're going to be looping over. So properties. And that's why I called this variable here day, because this array basically contains 3 days. Now let's actually do something cool here and instead store this into a variable. And let's say open, and then str for string, and here a colon, because now using the loop, I will basically keep adding to this string. So open string plus equal, and then the current day. So day, and then a comma. And so here we are then essentially building just this string. So that's similar to something we did already before. And so the end is we are open on 3 days: Thursday, Friday, Saturday. Great. So that's property names. Let's write that here. Okay, but what if we actually wanted the property values themselves? Well, then we would simply use object.values. So let's also store this here. And of course, then we need to pass in the object itself. So that's again opening hours. Missing the equal sign. And now let's just take a look at the values. And indeed, these are exactly the 3 values that we specified right here. So this value here, right? So open 12, close 22, this one and this one, right? So before we had the keys, now we have the values, and there is no need to now loop over them again, because it's going to work exactly the same as here. Okay? But now, to really simulate to loop over the entire object, we actually need the entries. And so entries is basically names plus values together. And we already saw the entries before. So when we looped over the array, and I think that's going to be somewhere down here. Oh, and actually I already passed it. So indeed, here it is. So here on the array, we called this entries method. And so the entries returned the index number and the element itself. And so we can do something similar on objects, and that will then also return the key and the value. Okay, now it works differently on objects because it's not going to be a method that we call on the object itself. So here we had the menu array, and then we did that menu array dot entries. But now here we do it differently. So we use again object dot entries. And then we pass in, once again, the opening hours. So this distinction between the array and the object is important as we loop over the entire object. Okay, I actually run into that problem myself at some point. So that's why I'm telling it to you. But anyway, let's store this again into a variable. And so then you have all the three versions here nicely organized in your code. And let's take a look here at the entries now. And so, as you might have expected, we now get an array. So all of these keys, values, and entries basically transform the object into an array. And then here we have first the key and then the value. All right. And so now we can use this to basically loop over the object. So for, and now let's start by writing the of. I will just call it x for now, and then we will take a look. So x of the entries that we just generated, and then let's just log them to the console. And so let me get rid of this one here. All right, so that's weird. Oh, it's because, of course, I want to log x. Oh yeah, that's correct. So now we have each key and each value. All right, now we want to print to the console a string like this. So on the weekday, and so that is the key. And so I'm using these variables here before I actually defined them. So to make it easier to say what we want to define. So for example, on Friday, we open at, and then we're going to have an open variable and close at close. So how will we do this? Well, just like we did with the arrays, we can use destructuring right here. So let's do that. The first one is the key, and remember the second one is the value. So we could do this, but we already know that this here is an object, right? And so therefore we can also immediately destructure that object here. So fair enough, open and close. So the two variable names inside of that object are open and close. And so here we specify exactly these property names, and so they get destructured. And therefore this works. So let's see that again. And so, yeah, so this is here the value, basically, all of this, right? And so here we have open and close. And so that's exactly what we defined here as well. And therefore we then end up with the string here, which got all of the data out of the object into this nicely and neat string. All right. So this part here is necessary because the value itself is also an object. But if you had a more simple object with a simple value, then you would of course only do this here as destructuring, just a key and a value. And of course you could then give them other names as you would like. So here we can just call them day. We can use any name that we want. Awesome. So we're doing great progress here. And now it's time to practice that once more. So I see you in the next coding challenge. In the past, JavaScript has always had very little built-in data structures. So basically we only had objects and arrays. But in ES6, two more data structures were finally introduced, and that are sets and maps. So these are pretty common data structures that already exist in other programming languages, and now they also exist in JavaScript. So in this lecture, let's learn all about sets. And a set is basically just a collection of unique values. So that means that a set can never have any duplicates, and that property makes them useful in certain situations. So let's create a new set here. Let's call it orders set. Okay. So again, to create a new set, we write new set, and then here we need to pass in an iterable. And the most common iterable here is an array. So let's create an array with a couple of strings now. Let's say pasta, pizza, then pizza again, then risotto. Let's put another pasta and another pizza. Okay, so 6 strings, but of course they could be different data types in here. So set can of course hold mixed data types. That's not a problem at all. Now here we clearly see some duplicate strings. So what do you think that this set will look like now that we created it and when we log it to the console? Well, we get a set. Here we can see it has a size of 3, and the only values that are in there are pasta, pizza, and risotto. So that's right, all the duplicates are actually gone. Now also we can see that a set kind of looks similar to an array, right? So there are no key value pairs, it's just a bunch of values grouped together, in this case into a set. And just like arrays, sets are also iterables, okay? Now, of course, a set is still very different from an array. So first, because its elements are unique, and second, because the order of elements in the set is irrelevant. And we will see why in a second. But anyway, keep in mind that strings are also iterables. So we can do this. So we can pass in a string. And so now we get a set with these 5 elements. So, and that's the 5 components basically of this iterable, which is this string. And of course, the set could also be empty, just like this. All right. And now let's learn how to actually work with sets. So first off, we can get the size of a set. So order set.size. And so that is 3. And so in this particular example, this might be useful for the chef of our kitchen to know how many different meals are going to be cooked here. Right? So if this array here is an array of all the orders, then the set of these orders are simply the unique different meals that are going to be cooked. And then the size is how many different meals will be cooked. And just note how it is actually called size and not length like it is in arrays. So don't make that confusion. Next, we can check if a certain element is in a set. So order set.has, and so this is actually a method. And so let's check if pizza is in there, and let's check if bread is in there. So true and false, and that's exactly as we expected. And so comparing again to arrays, this has method is similar to the includes method in arrays, right? Next up, we can also add new elements to a set. So order set dot. So let's say that now someone ordered garlic bread. And let's say that this actually happened twice. So what do you think that the set will look like now? So order set. And so the garlic bread got added, but only, of course, one of them, because again, the set has to be unique. And so the second one was basically ignored. Finally, we can also delete elements. So let's do that before the log. So order set.delete. So all of these method names are very straightforward. And that's because this is such a modern feature. So the modern stuff really has these more straightforward names and a different way of working with the data structures. So we have risotto here, and so now here we are deleting it. And so indeed, it is now gone from the set. So really, really easy. And in arrays, there's actually no method that is this simple. We will see how to delete elements from arrays later, but I can tell you that it's a little bit more complex. Okay, and that's actually it. But now you might ask, how do we actually retrieve values out of a set? Can we maybe use an index like in arrays? So doing something like, maybe like this here. And the answer, as we will see, is no. So this doesn't work. It gives us undefined, no matter what number we put here. All right. And that is because in sets, there are actually no indexes. And in fact, there is no way of getting values out of a set. And if we think about this, then it makes sense. So there's really no need for getting data out of a set. That's because if all values are unique, and if their order does not matter, then there is no point of retrieving values out of a set. All we need to know is whether a certain value is in a set or not, and that's why we have the has method. If your goal is to actually store values in order and then retrieve it, then the best use case is to just use an array. You wouldn't use a set for that. And so again, there's no need for getting values out of a set, because if you need it, then you would just use an array. Finally, there is actually one more method here, but it's not that important. All we can use it for is to basically delete all of the elements of the set. And so we see that now it is empty, right? But let's put that back so that we can work some more with this set. So as I said in the beginning, sets are also iterables, and therefore we can loop over them. So let's say order from orders set, and not from it is of, obviously. And then we can just log the order, and indeed, here they are. So looping is possible just like in any other iterable. All right, so now that we know how to work with sets, let's see a big use case for them right now. So in a normal code base, the main use case of sets is actually to remove duplicate values of arrays. So let's just write that here, example. So let's say that we have an array in our restaurant which contains the stuff of our restaurant. Let's say we have one person that is the waiter, one person that is the chef, another person that is a waiter, then we have also a manager, then we have another person that is a chef also, and another waiter. So that's an array of all our stuff in the restaurant. But now let's say that for some reason we are interested in knowing only which different positions there are in our restaurant. Or in other words, we would basically like to have a unique array of this, right? So this array without all the duplicates, that will solve the problem. So let's create a set for that. Easy enough, right? So stuff unique equals new set, and then the iterable that we need to pass in is the stuff, because an array is already an iterable. Now this is not yet the end of the solution, but let's take a look at it for now. And of course, it needs to be stuff unique. And so, yes, so we have a set now with waiter, chef, and manager. So the three unique positions. But now we actually want this to be an array. But the conversion from a set to an array is pretty easy because they are both iterables. So remember from earlier that the spread operator works on all iterables, right? So that includes sets. And so we can now create an array around this basically, and then we can unpack this entire set here using the spread operator. and then these elements will be put into the newly constructed array. Okay? And so, indeed, we now end up with a new array. Okay? So the spread operator here works just like on an array. It works really exactly the same. So it takes all the elements out of the iterable and essentially writes them here like comma separated, right? Now, if we only wanted to know how many different positions there are, then the size property is very useful. So all we would have to do, even though this looks a little bit weird, would be to say new set, then with the array, and then .size. And that's it. And then we wouldn't even need to have to create the array at all. So if we didn't need the unique array. So if all we had was this, and we wanted to know how many unique positions there are, then this here would be the way to go. And the same could even be done with counting how many different letters there are in a string, right? Because an iterable, or actually a string, is also an iterable. So let's see how many different letters there are in my name. And it looks like there are 11. All right. So, as a conclusion to this video, sets are not intended to replace arrays at all. So whenever you need to store values in order, and that might contain duplicates, always just use arrays. That's also true when you need to really manipulate data, because arrays have access to a lot of great array methods that we're going to study a little bit later. Now, sets have this very useful property of being unique. And it's also very easy to interact with sets by using all of their straightforward methods. However, they are not nearly as important as arrays. So keep sets in mind when you need to work with unique values, but besides that, you can just continue using arrays. So we learned about sets. Now it's time to learn about the other new JavaScript data structure, and that is maps. And let me start by telling you that maps are a lot more useful than sets. So what exactly is a map? Well, it's certainly not the same thing that we use in the real life to find our ways around. No, instead, in JavaScript, a map is a data structure that we can use to map values to keys. So just like in objects, data is stored in key value pairs in maps. Now the big difference between objects and maps is that in maps, the keys can have any type, and this can be huge. So in objects, the keys are basically always strings, but in maps, we can have any type of key. It could even be objects or arrays or other maps. So that can lead to some really great and advanced stuff. So let's create a restaurant map here. So I'm just calling it rest here. And so we again use the constructor just like we used for the set, but this one called map. And the easiest way to create a map is to actually create an empty map just like this, without passing anything in. And then to fill up the map, we can use the set method. And then here we pass in two arguments. The first is the key name. So let's call it name, and then the name of the restaurant itself. So Classico Italiano. And so you see that this set method is pretty similar to the add method that we had in sets. So both allow us to add a new element to the data structure. And remember that we can use any data type that we want. So let's say that the restaurant has two locations. So we can create a key with a number. It doesn't have to be a string. So let's say one is in Firenze, Italy, and the other one, so a number 2, is in Lisbon, Portugal. And calling the set method like this does not only update the map that it's called on, but it also returns the map. So let me show that to you here. Okay, so this is what the set looks like after adding this key number 2. So here we have the entries. The first is name, which is then mapped to Classico Italiano, and then the other 2 that we just added. Now, the fact that the set method actually returns the updated map allows us to chain the set method like this. So let's set categories here as an array, and I will just grab that from up here. Okay, so once more, the value can be anything. And now I can just chain the next set on here. So I can now say open and set it to 11. And then again, I can chain the next one and say close at 23. So let's save it. And this will then format this nicely. So again, calling the set method returns the updated map. And so all of this is now the updated map. And so we can call set again on that map. And we can continue this even further. So let's now actually even use Booleans as the key here. And we can say that we want to map true to we are open. And then we can also set false to we are closed. And we will see in a minute how this can become useful. Okay. Now, in order to read data from a map, we use the get method. And so that get method is available on all the maps. And so all we need to do is to pass in the name of the key. So let's see. Let's log this to the console actually. And let's just duplicate it here and also log true. And you see that the true key here is then mapped to we are open and named to Classico Italiano, of course. And here, when we get the elements, of course, the data type of the key matters. So if we tried true the string, then that would be undefined. And if we tried to retrieve 1 as a string, that would also be undefined, because here we have 1, the number, as the key. And so with this, we will then get Firenze, Italy. All right. Now, just for fun, let's use the fact that we can have Boolean keys. So this true and false here, right? And we also have the open and the close time. So you see they are all kind of related. And so let's create something fun with this. So let's say we have some current time, and we could actually get the current time from JavaScript, but we don't know how yet. So let's just say it's 21 hours. So that's 9 p.m. And then we could do something really clever like this. So rest.get. And so when we pass in true, then we will get we are open. And when we pass in false, we will get we are closed. And so in order to get the correct string here according to the time, all we need to do is to compare the current time with these two open and close. Okay, so let's do that. We can say, or we can ask, is the time, so the current time, greater than rest.get open? And at the same time, is it below rest.get close? So basically here we are asking if the current time is between 23 and 11. And so this here is a true-false value, and this is a true-false value, so a Boolean. And so the result of this AND operation will be either true or false. And then true or false will map to one of these values. So that's really clever, right? So let's log the result to the console. And let's check it out. And so at 21 hours, we are open. And that makes sense. It is between these two times. But if it was like 8 hours, then we are closed. Amazing. Now this is, as I said, pretty clever, but it's not really so readable. So don't overuse this kind of pattern, okay? This just really goes to show the power of having booleans as map keys. But anyway, let's now keep exploring the methods that are available on maps. So we already have methods to set and to get. Now we can also check if a map contains a certain key. So let's log to the console the result of calling the has method. So categories, and so this should be true. And it is indeed true. Then we can also delete elements from the map, and again, that happens based on the key. So rest.delete, and let's say that the second location should be closed now. So this one here, the one in Lisbon, and so we take that key and delete it from the map, and as a result, that will then be gone here. So you see, no longer there. Now comparing this to objects, we can actually also delete properties from objects using something called the delete operator, but that's a really slow process and usually it's not encouraged to do that. Here about the has method, actually objects do also have a method which is called hasOwnProperty, but we're going to talk about that in the object-oriented programming section. All right. Next, maps also have the size property. So rest.size, of course, and that should be 7, as we can see here. And yeah, so it has 7 items. And then to finish, we can also clear. So basically remove all the elements from the map. Let's just put that here. And so now it's gone and it has a size of 0. Let's put that back. So as you can see here, there is some overlap in the way that we work with maps and sets. And that's because they were both introduced in ES6. And now just to finish, let me show you that we can, in fact, use arrays or objects as map keys. So let's here set something else. And so now as a key, I will use this array. And I will set it to test. Okay. And let's just put that actually here, so it's before the log, so we can take a look at it. And so here indeed we see this is now the key, this array. All right. But now to get the data based on that array, let me see how we could do that. So rest.get, and think about what we are doing here. Do you think that this will work? And actually we need to log it to console. But given what we learned in the previous section about how JavaScript works behind the scenes, especially primitives versus objects, do you think that this will now retrieve test? Well, let's see, and no, it did not. And the reason for that is that these two arrays are actually not the same object. So this array and this one, even though we wrote them in the same way, and so they have the same elements, they are not the same object in the heap. Okay? And the key here is exactly this object in memory, and not this one. And so this cannot work. In order to make it work, we would have to do this. Creating an array, 1, 2, and then we use that array. And then we also use the same array to read the value out of the map. And so now it is gonna work. Okay, because now, of course, these two refer to the same place in memory. Great. And so with this, we proved that we can indeed use objects as map keys. And this can be very useful with DOM elements, which in fact are also nothing more than just a special type of object. Let's do that here as well. Let's do rest.set. And now as a key, we will use document.querySelector. And then we're going to select this H1 element that we have here. So this is just an H1. So nothing fancy. And so the result of this will be an object. And so let's say that this is the heading. And now as we check it out here, you will see that it is here indeed. So as I hover it, you can even see it here visible on the web page. You see that? The highlight up there? That exactly is the key of this map entry. Sounds crazy, but it is possible, and it can enable some advanced functionality. All right, so we learned here how to create maps and how to work with them. So this should be enough for one lecture. And so let's wrap up this one now and continue learning about maps in the next one. So let's continue learning about maps. So in the last video, we created an empty map and then added elements to it by using the set method. Remember? However, there is actually another way of populating a new map without having to use the set method. And I prefer that because the set method is a bit cumbersome when there are a lot of values to set. So instead, we can create a new map like this. So I'm going to call this one question, because now we're implementing something like a quiz. So in a very simple way. So new map. And then here we can pass in an array. And this array itself will contain multiple arrays. And in each of these arrays, the first position is going to be the key, and the second position is going to be the value. So let's do that. So let's say question, and then what is the best programming language in the world? So this is basically the first entry of this question map. So before we would have used the set method and then this as the first argument and this as the second. But now we can simply specify this array of arrays in this way. Now, next up, I want to specify the options for the answer, basically. And so I can simply do that by their number. So the first answer is going to be C. So C, the programming language. The second will be Java. And the third will be, of course, what else? JavaScript. Then we need a key for the correct answer. And what do you think the correct answer is? Of course, number 3. And then we can also have like a success message and an error message. And so let's again use the Boolean keys. So true, which is basically when the user is correct. Then we can say correct. And maybe some kind of emoji here, like this one. But if it's wrong, so if the answer is false, then try again. All right. And so let's take a look. And that looks correct. Fantastic. So when creating a new map from scratch directly in the code, I actually prefer this way of writing it over the way that we did in the previous lecture. But when we keep adding new elements programmatically using code, then of course the set method is still the way to go. Now, as an aside, does this kind of structure here, so this array of arrays, look kind of similar to you? Well, I hope it does, because this is exactly the same array structure that is returned from calling object.entries. So for example, on the opening hours object. And so you see that there too, we get an array of arrays, where the first element is the key and the second one is the value. And so what this means is that there is an easy way to convert from objects to maps. So let me write that here actually. Convert object to map. And so we can say hours map is a new map. And then simply with object.entries of opening hours. All right. So again, because this structure that results from object.entries is exactly the same as this. So an array of arrays. So indeed, now we have a map here. And so keep this small trick here in mind whenever you need a map when you already have an object. Next up, let's talk about iteration. And iteration is possible on maps because, as we already know, maps are also iterables. And so the for loop is also available for them. And so let's use a for loop actually to now print just these options here to the console. So these three, all right? So as always, I like to start with first saying what we will loop over. And so that's going to be the question map. And so each item of the question will, just like before, contain both the key and the value. And so here I can now directly destructure that into two separate variables. So this is a really, really good use case of destructuring. All right. So just to reiterate, this is exactly the same as we did when we looped over the object. The only difference is that for the object, we needed object.entries right here. And that's just because the object is not an iterable. But then we converted it to an iterable using object.entries. And so then this part here is exactly the same. Okay. Now keep in mind, we only want to print these three. So essentially, we only want to print an element if the key is a number. So let's use what we already know. Type of key equal number. And only then log to the console. So inside here, answer, and then the key. So the number for the person then to choose with the correct value, which is going to be the answer option itself. So here we go. Answer 1, 2, 3. And now let's just also log the question itself. So quiz app. And here we want question.get, remember, and then the question key. And so now it is complete with question and answers. Now to get the answer from the user, let's again use a prompt. So answer equal prompt. And let's ask for your answer. And answer. And remember, we need to convert this now to a number, because eventually we will compare this number with the key that we have here. All right. Let's just print it then also. Okay, so here we have the question, and of course the correct answer is number 3. And so here we go. And now we can use the power of the Boolean keys here in order to print either the success message here or the error message, basically. All right. So do you think you can do that on your own? Just take a minute or two and try that on your own right now. So did you manage to do that? Well, let's start by comparing the answer with the correct answer, basically. So that is question dot get correct. And so this is 3, right? And then we can compare that to the answer. So in this case, this was also 3. And so this here would return true, correct? And now, since this is true, we can directly plug that into the map. And so this true will then return correct. So that's similar to what we did in the previous video as well. And so again, we are using the power of having Boolean values as keys. And then let's just log that final message to the console. So 3 again. Oh, and something went wrong. But I see that it's just here. It's the name. So this is correct, not correct. So again, 3. And now indeed we get correct. Okay. So this is 3 here. The answer is 3. This is 3. And so this here will be true. And so when we get true from the map, we get this string. Now, something else. And indeed, we get try again. Okay. And with that, we finished this nice little quiz. Now, just to finish here, as a side note, sometimes we also need to convert a map back to an array. So basically to this structure. And we can do that like this. So convert map to array, basically. You can do that by simply building a new array and then unpacking, again using the spread operator, the question map. It's asking us here again. And so then the result is essentially this same data structure, so the array of arrays with which we started. So it's this one here. So in this case, of course, this wouldn't make too much sense, but it's still good to know that sometimes you can convert a map to an array. Let's just preset this here to some value so that it doesn't always bug us here. And by the way, there are also the methods that we had on arrays, which are the entries and also keys and values in case that you need them. Okay, now they give us this weird iterator here. So then, just as I showed you before, you have to spread them and put them in a new array. So like this. But this is not really that important. I just wanted to show you that this exists. And for this, there's actually no need because it's going to be exactly the same as this one. Okay, so these are all the keys and all the values indeed. All right, and that's all I have to show you about maps for now. But now you might be wondering, when should I use maps and when should I use objects? Because they are pretty similar, right? Well, that's what the next lecture is all about. There I will help you to choose between all the data structures, including even arrays and sets. Dealing and working with data is the main thing that we do as developers. And that's the reason why, since the beginning of the course, we have been working with JavaScript's built-in data structures like arrays and objects. Then in the last few lectures, we learned about 2 new data structures, which are sets and objects. So now we have 4 data structures from which we can choose. And so I decided to create this quick lecture, which will show you the pros and cons of each data structure and also when to choose each of them. And I want to start this video by quickly categorizing where data can actually come from. So there are essentially three sources of data. First, the data can be written within the program's source code itself, like status messages that will be displayed on a web page based on user actions. Second, data can come from the user interface, so from the web page. It can either be data that the user inputs into some form, or data that's already written somehow in the DOM. For example, this can be the user's tasks in a to-do app, or expenses in a budget app, or anything like that. Finally, data can come from external sources, which is usually a web API. Now, what is a web API? Well, API stands for Application Programming Interface, and we can basically use a web API to get data from other web applications. For example, we can use a web API to get the current weather in any city, or data about movies, or currency conversion rates, and really every kind of data that you can imagine. And we will learn how all that works later in the course. So no matter where the data comes from and what kind of data it is, we usually always have collections of data that we then need to store somewhere. And so where do we store collections of data? That's right, we use data structures. But as you know, there are 4 built-in data structures in JavaScript. And so now we need a way of deciding between them. But it's not that hard. So the first decision is this. Do we just need a simple list of values? If so, then we're going to use an array or a set. But on the other hand, if we need key value pairs, then we need an object or a map. So the big difference here is that with a key value pair, we have a way of describing the values, so by using the key. On the other hand, in a list, like an array or a set, we simply have the values without any description. Okay? Now, as a quick example, let's go back to getting data from a web API, because in modern JavaScript applications, that's usually the most common source of data. So data from web APIs usually comes in a special data format called JSON, which looks like this example here. So JSON is essentially just text, so a long string, but it can easily be converted to JavaScript objects because it uses the same formatting as JavaScript objects and arrays. So here we have 3 objects that describe recipes. We have the values in green, like the title and the publisher, and it makes complete sense that these values are then described using a key. Otherwise, we would have no idea what the different values actually are, right? So key value pairs are essential here, and that's why this data is stored in an object, not an array. Now, each of these recipe objects in itself can be seen as a value, and since we have many of them, it means that we have again a collection of data, and therefore we need a data structure to store them. Now, do we want to describe each of the objects? Well, it's not really necessary, is it? We already know they are all recipes, and whatever information we need about the recipes is already stored right in each of the objects. So all we want is basically a simple list where all the recipes are held together. And so here, an array is the perfect data structure for that. And in fact, creating an array of objects is extremely common in JavaScript. Now you will be working with this kind of data all the time as a professional JavaScript developer. And that's why I'm placing so much focus on this here. Okay, now before we move on to compare arrays, sets, objects, and maps, I quickly want to mention that there are also weak sets and weak maps data structures in JavaScript. Also, there are even more data structures that are used in programming, but which are not built into JavaScript. And just to mention a few, these can be stacks, queues, linked lists, trees, or hash tables. And these don't really matter for now, but I still just wanted to let you know that there are more than just the 4 built-in data structures. But now let's talk a bit more about the built-in data structures. So you already know at this point how to use all of them, but it's important to know when to use them. So starting with arrays versus sets, we already know that we should use them for simple lists of values when we do not need to describe the values. Now, you should use arrays whenever you need to store values in order and when these values might contain duplicates. Also, you should always use arrays when you need to manipulate data, because there are a ton of useful array methods. Now, sets, on the other hand, should only be used when you are working with unique values. Besides that, you can also use sets in situations when high performance is really important, because operations like searching for an item or deleting an item from a set can be up to 10 times faster in sets than in arrays. Now, one great use case for sets is to remove duplicate values from an array, like we already did before. So sets are really not meant to replace arrays, but rather to complement them whenever we are dealing with unique values. Okay, so now let's talk about objects versus maps. And we already know that we should use these key value data structures whenever we need to describe the values using keys, right? But when to use objects and when to use maps? Well, objects have been the traditional key value data structure simply because we didn't have maps before ES6. But using objects simply as key value stores has a couple of technical disadvantages. And that's why some people say that we've been abusing objects for this. Now, maps, on the other hand, are way better suited for simple key value stores, because they offer better performance, in fact. Also, map keys can have any data type, and they're also easy to iterate, and it's easy to compute the size of a map. However, the biggest advantage of objects is probably how easy it is to write them and to access data by simply using the dot or the brackets operator. Also, most developers are already super used to objects, and so they simply keep using them for simple key value stores. Anyway, as a conclusion, you should use maps when you simply need to map keys to values, and also when you need keys that are not strings, because as we saw in the last video, that can be very powerful sometimes. Now, if you need functions as values, then you should absolutely use an object for that. So in objects, these functions are then called methods, and you can use the this keyword to access properties of the same object, which is impossible in maps. Also, when working with JSON data, as we saw in the previous slide, you will probably be using objects for that as well, unless you then want to convert the objects to maps. But that's usually not something that we do. So, in fact, we still use objects all the time, but maps are also a very important data structure right now, and way more important than sets. Great, and with that, we wrap up this overview. I hope you found this useful, and so let's now move on. Over the next few lectures, we will learn how to work with strings. And so we're going to be taking a look at a couple of useful string methods. Now, I could have divided this part about strings into many more lectures and go really deep into some topics, but I think it's best to just quickly introduce you to all the topics here and then keep using them in future projects, because we work with strings all the time in JavaScript. And so you will see these methods being used all the time throughout the rest of the course. Anyway, this is going to be really fun, so let's get started. And in this part of the section, we're going to leave the restaurant theme behind and work on stuff related to airplanes and airlines. So that's something that I really like. So let's now start by creating an airline variable here. And I'm using tab air Portugal. All right. And if you want, you can use some other one from your country maybe, but then you might have to adapt the examples. So as a plain, I'm using a string A320. Okay, and now let's do some stuff with this. So just like in arrays, we can get the character of a string at a certain position. So for example, plain at position 0 should be A, right? So let's load this here, and indeed we get A. And the same, of course, for all the other letters. 1, 2, for example. And so indeed, you now get 3 and 2 here, but both of them are still strings. So if we wanted them to be numbers, we would have to convert them. And we can do the same directly on a string. So we can just write a string, and let's write B737 now, which is a Boeing. And so this works the same. Okay, so now we got the B. We can also read the length property of strings, just like we can in arrays. So let's say airline.length. And again, we can also do that directly on the string. Okay, there you go. Next up, let's talk about methods. So again, comparing strings to arrays here, strings also have methods. And some of them are quite similar to the array methods. So one of them is the index of. So I believe we talked about this one when we talked about arrays. And so this one works the same way. So we can get the position in which a certain letter is in the string. So let's use R here. And so here we now get the position number 6. And so let's see, 0, 1, 2, 3, 4, 5, and 6. Okay, and that's where this 6 here comes from. So you see that strings are also 0-based, right? And we could observe that already up here. Now this here will only give us the first occurrence, but sometimes we might need the last one. And so then we can use last index of. Last index of. And so that is 10. So this one was 6, then 7, because the space, of course, also counts as a character. Then 8, 9, and this is position 10. All right. And we can also search for entire words. So, for example, for the occurrence of Portugal. And so that is at position 8. And this one is actually case sensitive. So if I search with lowercase, then we get -1, because this can now not be found in this airline string. All right. Now, what can we actually do with these indexes? Why are they useful? Well, one good use case is to extract part of a string using the slice method. And the slice method needs indexes as arguments. And so therefore, sometimes it can be very useful to first figure out the index of part of a string to then extract that. So let's see how the slice method works. So airline and then dot slice, and let's write 4 and see the result here. All right, so the result is Air Portugal. And the reason for that is that this here is the begin parameter. So basically it's the position at which the extraction will start. And remember that this is 0-based, so 0, 1, 2, 3, and 4. So 4 happens to be this A, and so this is where the slice method starts to extract. And now this result that we get here, so just this here, is called a substring, because it's just a part of the original string. Now this does not change the underlying string, okay? Just keep that in mind. That's because it's actually impossible to mutate strings. They are primitives, right? So if we wanted to use this string now, we would have to store it first into some variable or some data structure. Okay, so this method here and all the other ones that we're going to talk about always return a new string. Okay, and so that's why we can then log that result to the console like this. Now, besides the begin parameter that we already specified, we can also specify an end parameter. So let's try 7 and see the result. And so now we only got air. Okay, so this one is 4, then 5, 6, and 7 is the space here. And so what this means is that the end value is actually not included in the string. All right, so basically it stops extracting before reaching index number 7. And that's really important to keep in mind. And just as a side note, the length of the extracted string is always going to be end minus beginning. So 7 minus 4 is 3. And so that's the length here of air. All right. Okay. Now, up until this point, we have always just hard-coded these values. But of course, many times we don't even know the string that we receive yet. Okay. And so let's now try to extract just the first word of this string here, but without knowing any of the indexes. And so that's where this index of and last index of here become really important. So basically that we do not have to hard code these values here. All right. So let's try to extract that first word, as I was saying. So airline.slice. And now we need to figure out the index. And now if we want the first word, we need to start at 0. But what about the end parameter? Well, we want to extract until this space here, basically. So let's find the index of that. So airline.index of, and remember that this will be the first occurrence. And so indeed we get top. All right. And now let's do the opposite, extracting the last word. So slice. And so for the last word, we want to start at the last space here. Okay, that's why we have last index of. So airline dot last index of, and again searching for the space. And now we don't need the end parameter because then if we don't specify it, it will simply extract everything until the end. Okay, but actually now the space is also included here. And so we just need to add +1. And now we're good. So that's the fundamentals of the slice method, but we can do even more with it. So let's go again here. And we can even define a negative begin argument, like this, for example, and then it will start counting from the end, or actually start extracting from the end. So these are the last 2 letters from Portugal. And finally, let's duplicate this one again. And again, I'm using this shortcut here for duplicate. Okay. So we can also specify a negative end parameter. So the begin is back to positive, and now the end is -1. So let's see. And so basically we started at position 1. So that's why the T is cut off. And then the negative end parameter basically cuts off the last character. All right. And so we will need all of these different combinations here in different situations. So it's good that you know how to use them because you will need them at some point. Okay, and now let's practice a little bit what we just learned and write a function that receives an airplane seat and logs to the console whether it is a middle seat or not. So I hope that sounds like fun. So let's write check middle seat. And it is a function which takes in a seat. And just to illustrate it, let me start by calling this function. So check middle seat. And so typically an airplane seat looks like this. So we have the row as a number here, and then the seat itself, so that's like the column, so to say, is then a letter, for example, a B. So it starts from the left and goes all the way to the right side. And in small planes like the A320 or the Boeing 737, we only have 6 seats in one row. And that means that B and E are the middle seats. Let me just write that here. B and E are middle seats. So just in case you're not familiar with how these small planes work, right? And that's also not the point here, of course. So basically all we want to do is to check if the string that we receive contains a B or an E. And if so, then it's a middle seat. And let's call this with a couple of different strings. So 23C and 3E. All right. So what we need to do here is basically take the last character of the string and test whether it is a B or an E, right? So let's get that letter from the seat. Now we'll just call it S for seat again, but I cannot repeat the same name here. So how do I do that now? Well, to extract part of a string, we already know we use the slice method. And how do we take the last character of a certain string? Well, we use -1 as the begin character. And then, as we saw up here, it will start counting basically 1 from the right side. And now it's very easy. If S equals B, or if S equals E, then let's log to the console. You got the middle seat, which is the one that no one wants. Well, let's add an emoji here. Let's say this one. Or else you got lucky. Just any emoji here, just to make it different. And I think we are good now. Let's test it. And so indeed, this here contains the B at the end. And so therefore it's a middle seat. The same for this one. And this person with this seat got lucky. All right. And that's how we extract parts of strings. And that's something really important to do. So maybe if you'd like, you can play around with this some more, maybe come up with your own example. Now, before we move on here, let's just stop for a second and understand why all of this actually works. So we know that strings are just primitives. So why do they have methods? Shouldn't methods only be available on objects such as arrays? Well, that is actually true. However, JavaScript is really smart. And so here is how this works. Whenever we call a method on a string, JavaScript will automatically, behind the scenes, convert that string primitive to a string object with the same content. And then it's on that object where the methods are called. All right? And this process is called boxing because it basically takes our string and puts it into a box, which is the object. So basically, what happens is this. So what JavaScript does is to call this string function here. Okay, and so now you see that this string here looks a little bit more like an object. And we could take a look at this here. And so you see here all of these methods like slice that we just used. But this is beyond the scope of this lecture. We will learn what this is a little bit later. But what matters is that this indeed is now an object. So you see, it is an object. And so this conversion here is what JavaScript does behind the scenes whenever we call a method on a string. And then when the operation is done, the object is converted back to a regular string primitive. Okay? And in fact, all string methods return primitives, even if called on a string object. So let me demonstrate this here as well. Just really quick. And actually we want here type of. And so the result of all of this is then back to being a string. Okay, but don't get confused by this. This is just the theory explanation behind why all of this works, in case you're curious. And I hope you are. Great, but now let's move on to the next video where we will continue working with strings. Let's continue with some simple string methods. And the first two are going to be for changing the case of a string. So that's airline dot to lowercase, and this doesn't require any arguments at all. And then we also have to uppercase, and these we use all the time, as you will see soon in a more real world example. And here you see that indeed they transformed the string all to lowercase and to uppercase. And again, you can of course call these directly also on a string. So like this, all right? But now let's use this on a more practical example to fix the capitalization in a passenger name. In name. Okay. So let's say that the passenger, when he checked in, misspelled his name. And so it looks like this now. And so this needs to be fixed. It should look like this. Okay? So in order to fix it, the first step is usually to put everything into lowercase here. So const passenger lower is passenger dot to lowercase like this. Okay, so basically we already have now this part here, and now all we need to do is to essentially take the first letter and then the rest of the string and put these two parts back together. So passenger correct will be passenger lowercase, and here we only need the first letter. So how do we do that? We take the first letter by using the index 0. And so this one we now convert to uppercase. All right. And now we simply need to add the rest of the string. So again, we take passenger lower, and then we use the slice that we learned in the last lecture and start at position number 1. Because remember, that will then go to index 1 and take everything until the end of the string. And so here we then put back together just the first part of the string converted to uppercase here, and then the rest of the string that we already had converted to lowercase before. Okay, and indeed, now it is corrected. Great. And of course, we could have done a function with this. And so maybe if you have the time, you can do that. So just create a function which takes any passenger name and then returns the correct one. So with the fixed capitalization. But anyway, I will now do another real life example, which is to check a user input email. Okay. So check email. Now this will not be really a checking, it will more be a comparing. So comparing emails. So let's say that we have the email of one passenger. So hello@jonas.io. But now as the user logs in, so let's say login email, accidentally they do it all wrong. and they start with a couple of spaces here, and then the capitalization is all completely off, like this, and then maybe even another space, or even an enter character, which remember is \n. So I think we talked about that in the beginning, okay? But still, this email here is actually still kind of correct and kind of valid. And so we can now still compare if these two are kind of the same, okay? So we can now try to convert this one to this one and then check if they are the same. Because essentially, again, they are. They would be different if we had like different letters here. Then of course they would not be the same. But here it's just a matter of capitalization. And for emails, I believe that they are still valid even with the capitalization off. And so when we check user input like this, the first step is usually to convert it to lowercase. So lower email is login email dot to lower case. And then we must also get rid of all the white space here. So these empty spaces and also this enter basically here also counts as a white space. So there is even a method for that. So let's say trimmed email, and so that is lower email dot trim. All right. Let's just now log this to the console just to see. And so that looks exactly like that first version. Now, just look closely at what we did here. So we called to lowercase on this login email, stored it to this variable, and then on that variable, we called the trim method. But why do we even need this intermediate email? We could do this all in one step. So basically, we can replace all of this, and let's call this normalized email, actually. And so, again, I will start from login email, and then do it all in one step. Dot to lowercase. And now this is a bit similar to what we did before with the map set method. So this here will return a new string, right? And on strings, we can call string methods. And therefore, right here, we can now immediately call the trim method. Okay, so normalized email, and that should look exactly the same. And it does. So let's get rid of this. And these two I will simply leave as a comment here. And now just to finish, let's actually also compare them for the sake of completion. And once again, you could do this here in a separate function. So you could do a function for this behavior where you pass in two emails, one which is the correct one and one which is the one to check. And then you could return either true or false from that. So again, that sounds like a good challenge that you can take if you want. And by the way here, since ES 2019, there's also trim start and trim end, which as their names say, you can use to trim whitespace only from the start of the string or only from the end. Next up, let's learn one of the most important things about strings, which is to replace parts of strings. So replacing, okay? And we're gonna stay here again with the airlines. So let's say we have the price of a flight, and that price is for Great Britain. So let's say 288,97 pounds. And you can use any other currency sign that you want here. What's important is that here in Europe, we use the comma as a decimal separator, unlike in the US, where you use the period, so the dot. And so that's actually what we're going to do now. We want to compute the price in US. All right. And so for that, we will need to replace the pound with the $sign, and the comma with the period. So that's easy enough. Price Great Britain dot replace, and now here 2 arguments. The first one is the one we want to replace, and let's start here with the pound sign, and the second argument is the string that will replace the first one. So let's take a look. Price US, and so that already worked. And now we need to replace also the comma with the period. So we could create another variable now, but instead we will do chaining again, just like we did before. And for the same reason, because this returns a string. And so on that string, we will immediately call the next replace method. And now we are replacing the comma with the dot. And so, indeed, now we have the price in US. Okay. But indeed, we can also replace entire words, not just single characters. So let's create an announcement that you would typically hear on the airport, like all passengers come to boarding door 23. Boarding door 23. However, usually it is called gate and not door. And so let's replace that and log the result to the console immediately. Because just like the other method that we studied, replace also creates a brand new string. It doesn't mutate the original one. And so here it's the same, and so we need to log the actual result to the console. So replace door with gate. And here it's boarding. And now let's check it out here. So here, boarding gate, but then here you actually still have boarding door. And so this replace only replaced the first occurrence of this search string here. Okay? And actually that's completely normal. That's just how it works. But we can still go around this. Now very soon JavaScript will have a method called replaceAll, which will work like this. But right now, here it should not work yet. And indeed, I get here replaceAll is not a function. But if you're watching this video in the future, then this here might already work for you. So please go ahead and try it out. All right, but for me it doesn't work yet, but there is still another solution, which is to use something called a regular expression. Now, regular expressions are one of the most complex and confusing topics of programming, but we will still take a short look at them at some point in the course. But for now, we are just going to use a very simple regular expression to tell the replace method that it should actually target all the occurrences of door here and not just the first one. So let's again copy this here. And then to create a regular expression, we need to write the string between slashes. So not between quotes. So it turned yellow here again, which means that it's some kind of string, but it is now a so-called regular expression. Then in this case, all we want to do with this regular expression is to add this G flag here. And this stands for global. And that's actually it. So right now, all the occurrences will be targeted. And so we replaced gate here and here. All right. And just as a side note here, once more, the replace method is of course also case sensitive. So just like all of the other string methods are. Okay, and now as a final topic of this lecture, there are 3 simple methods that return booleans. So booleans, okay? And these methods are includes, starts with, and ends with. So let's create a new plane here. And that's going to be the A320 Neo. And I'm just missing here the assignment. And now we can simply use includes just like we can in arrays, one more time. So they have a very similar structure here in terms of methods that we can use on them. So includes, and let's test if it includes the string A320. And indeed, it does. So this airplane here is the Airbus 320 Neo, but it still includes just the A320. Now, let's say if it includes Boeing, and of course it doesn't. And now there's another one, which is the starts with. And this one is also actually very much used. I remember using it very recently. And so in this case here, it is false. All right. But then if we change this here to Airbus, then it is indeed true. Okay. So these three letters here are indeed the first three also here. So it doesn't have to match the entire word. So just AI would also be true, but AI B, let's say, would then be false. Because of course the string does not start with these three letters. With air B, then it would again be true. Okay? And of course this A320 is also still true as long as it is somewhere in the string. So now it's somehow here in the middle. Okay? So let's try something very simple here. So let's say that we want to check if the current plane is part of the new Airbus family. And so all we need to do to check that is to see if the plane name starts with Airbus, and we can already confirm that it is, right? And we also need to check if it ends with Neo, because that means that it's part of the new Airbus family. And so we can also use ends with. So as always, these methods here that return booleans are especially helpful for conditionals like this. Part of the new Airbus family. And indeed, this one here is. But of course, if it was just the regular A320, then that would not get logged to the console. So whenever you need to take some decision based on the contents of the string, these three methods are very, very helpful. And let's now actually practice that a little bit with some kinds of, we can say a practice exercise. And so here we want to check if the baggage of a certain passenger is basically allowed to be checked in. So to be allowed on the plane. So check baggage function. And then here we get the items. And let me again first call the function to show you what I mean. So basically the passenger here says what they have. So I have a laptop, some food, and a pocket knife. Then let's call this again and say we have, or I have some socks and a camera. And then let's call it a third time with the string now, got some snacks and a gun for protection. Okay. So maybe some passenger would bring a gun to a plane. But so now let's make sure they will not get aboard the plane. And actually let's change some things here. So let's make this uppercase. Let's say this person likes to write uppercase for some reason. Okay. And so this is important to show you once again that when we receive input from a user, we usually always start by putting everything into lowercase, okay? Because that makes it a lot easier to then compare it to something. Well, let's simply say baggage here. And so baggage is basically items to lowercase. So this one we use all the time. And now we can just check if the baggage includes a knife or a gun. And in that case, the person is not allowed on board. So if baggage.includes, and so here is that method again, which returns a Boolean. So if it includes knife, or if it, so baggage includes a gun, then we say you are not allowed on board. Else, let's log welcome aboard. All right. And so now let's see here why it is so important to convert everything first to lowercase. So in this example here, this first person has knife, but with an uppercase. And so if we didn't convert this to lowercase, then this includes here would be false, because the lowercase knife is different than the uppercase knife. Okay, so let's see the result. And so indeed, this person has a knife, so they are not allowed. This person here is fine. And then this one has a gun. And so, of course, they're also not allowed. But now, if we took away this here, well, then our code is not really going to work. So let's just delete this part for now. So if we didn't have the two lowercase, then the first person would also be welcome aboard. And again, that's because knife here, uppercase, is different from this knife. And so then we would have to check for all the variations, like knife like this, or this knife, or even this. So every possible variation. And so that would be highly impractical. And so we just turn everything to lowercase. So again, so that we can then easily compare it with one standard, which is this and this. All right, perfect. So that was another fun lecture, if you ask me, and I hope you are feeling the same. Now it's time for a break, and I see you back here in the next video. This is the third and final part of working with strings. And let's start by learning about one of the most powerful string methods, which is split. So split allows us to split a string into multiple parts based on a divider string. So let's check that out. So any string works here. Let's say a plus very plus nice plus string. So let's say that for some reason we have a string like this. And now on this string, we can call the split method. Here we need to specify a divider string. So let's just use plus. And so what will happen now is that it will split up this string by this plus sign. And it will then store the results into elements of a new array. So let's see that. And indeed, we get an array which contains a and very and nice and string. So essentially everything split up by this divider string. So let's try the same with my name. Dot split. And so the goal here is of having one array with two elements, one for each name. And so I can split by the space. And this is a very common one. And so indeed, I get this result. And this is really useful. Indeed, we can now actually use the power of destructuring to create variables directly like this. So I can say first name and last name will be the results of this split. Okay? So this here will create an array with two elements. And then from that array, the first one is going to be taken into first name and the second one into last name. Okay. Now we could have done the same thing with the slice method, but that would have been a lot more complicated and for longer sentences, almost impossible. And like this, it's really straightforward. Okay, now let's say that we want to make the last name uppercase here, and then we also want to add a Mr. in the beginning. So we could just use a simple template literal and do what I just said, but I want to show you something else here. And that's the join method, which is essentially the opposite of split. So let's create an array which contains all I just said. So we want to start with Mr., then the first name, and so that's going to be the second element of this array, and then the last name in uppercase. Okay, and now I want to join this. And again, we can specify a divider string, and hopefully you can see by now where this is going. So let's store the result of this into new name. And then let's check it out in the console. So what do you think will be the result of this? So of the join method. So indeed, we now get one entire string here. So one string composed of the three parts of this array and joined together by this joining string here, basically. And of course, we could have used anything else. So like this, or even like this. So anything works here. But what makes sense, of course, in this case is just the space. So this combination of split and join is really powerful, and we will actually use this all the time. So split and join. Okay. And in fact, we can use this for something that we already did in one of the previous lectures, which is to capitalize a name. But now with this, it makes it really easy to capitalize an entire name with multiple names in there. So let's say that this passenger is called Jessica N. Smith Davis. So how will we capitalize this name here? And actually, let's write a function. So that's a bit nicer. So const capitalize name, which is a function which receives a name, and then it will do something with that. So let's capitalize name here with that string instead. And then we can also call it with some other name. So my name, for example, and you can use your own name here, of course. So what's the strategy for capitalizing this entire name? And by the way, what I mean here is to transform the first letter of each name into a capital letter. So here, Jonas, and then this one here, Schmettmann with this capital S. Okay. Well, we have multiple words here. And so we will have to capitalize all of them one by one. And so to do that, it would be good to have them inside of an array that we can then loop over. And so now we can use the split method for that. So let's say names is equal to name split by the space. And so this will be an array, and now we can then loop over that array using the for off loop. So const, let's just call this one word, of names, or let's call it n, which stands for name, but I cannot reuse name because that would then override this input here, and that's a bad practice. Okay, and so now here we will then capitalize this name, so this individual name. So remember how we did that in the last lecture? We took the first letter, converted that to uppercase, and then joined it with basically the rest of the word. So that's n.slice starting from position number 1. So everything except the first letter, which is letter number 0. Okay, and now what should we do with this? Well, I think we should push this into a new array, so that in the end we end up with an array with all the names capitalized, and then we can join that array together. So let's say const names upper and start it as an empty array. And then in each iteration, we will simply push into this array. So sounds good to you? Okay. And now in the end, let's then log to the console names upper. And so now we need to join that array back together using the space as a separator. Okay. So here we practice a lot of different methods all in one function. So this is a really great use case. So let's now give it a try. And indeed it worked. So great, right? No matter how long a name we feed into the function, it will always give us the correct output. Now here is a small challenge for you, because there is another way of doing this. So basically of doing the capitalization of one name. So given what we already learned, especially in the last lecture, can you think of a different way of doing this? And if you can't, it's not a problem at all, but maybe you can pause the video here for a minute or two and think about this. So let me just show it to you quickly, because I think this is really interesting that we have different ways of achieving the same thing. And so this time, what will we push into the array here is simply n, and then in there we replace the first letter with the first letter in uppercase. So let me write that. So that's n at position 0 and replaced with n at position 0 to uppercase. Let's give it a try and we get the same result. All right. So again, we are here simply taking the word and then we replace the first character. So that's n at position 0 with the first character to uppercase. So that's a completely different approach than this one here, but it gives us the same result. Now, next up, let's talk about padding a string. Now, padding a string means to add a number of characters to the string until the string has a certain desired length. So, padding, and let's just create a message here. Go to gate 23. So now let's take a look at padding here. So I will take message and then I can say pad start. And so this will then add some characters to the beginning of the string. And the first argument here is the length that we want for the string. Let's say we want it to be 25 characters long. So after the padding. And then the character that we want to pad the string with. So let's use plus and let's take a look. Okay. And so you see that it added all of these here. And so now the length of this entire string here should be 25. Okay. So let me show that to you with another string here. So if I said Jonas and then the same, you would see that it would add a lot more of the plus signs because the initial string is shorter. So you see, we have a lot more pluses now, but in the end, the string is also 25, or actually 23, so mistake here. So now the string is also 25 long. And so we see here that this has exactly the same length as this one here in the console. All right. Then there's also pad end. And so we can now take the result of this and immediately also pad the end of the string. So pad end. And now let's make it longer. And then again, the plus sign. So this will basically then add 10 pluses to the end of the string because the result of this string here is already 25 characters long, right? And so onto this one, we then pad it all the way until the length of 35 with some more pluses. And so we're going to add 10 of them. Let's just do 30 so we can easily see that. And so indeed, it now added 5 of them here. And just for the sake of completion, let's do the same here with my name. And this here just to 20 to make it a bit more even. All right. But now let's actually use a more real world example of padding here. So when you see a credit card number on the internet, you never see the entire number, right? So usually we see the last 4 digits and the rest is masked with some symbol. So let's implement a function that actually does that masking. So this is going to be really interesting. This is a great application of string methods. So mask credit card function. And so we're going to receive a number. Okay, so an actual number. And let's start by converting this number to a string. So string. Now we learned how to convert a number to a string in the fundamentals section, right? So that was like this. Remember? However, there is a nice trick that actually makes this easier for us. So we can just take the number and then we add an empty string. And so the result of this will be the number, but as a string. And this works because, as you hopefully remember, when one of the operands of the plus sign is a string, it will convert all the operands to a string. And so then this number will become a string plus the empty string. And so then it's going to stay exactly the same. Okay, so in order to know what we should do here, let's one more time first call the function before we actually write it so that we know what kind of input we get. So mask credit card, and let's say now the number is this one, and I'm just putting something random here. But of course, it will also work with strings. And no matter how long it is. All right. So as I was saying, usually on the internet, we can only see these last 4 digits. And the rest is masked by some symbol. So what we need to do here is basically to take out these 4 numbers and then use pad start to create a string with the same length as this initial number here, but with some kind of symbol there. So let me just write that in code. And then I hope it will become clear. So we're going to take the last 4 characters of this string. And so we use slice with the negative parameter again of -4. And now here is what we're going to return. We will return a last. So that is just these 4 characters. And then we will pad it at the start all the way until the original length of the string. So string.length, and the character we're going to use will be this star. Okay? And so since we return something to make this function a bit more real, now we need to log the result to the console. And to start, let's actually make a slightly simpler version so that we see that it actually worked. So a shorter number here with just 8 digits. And so the end should be 7836 and then beginning with 4 stars. So let's see. And yeah, that worked great. Right? So again, we took the last 4 here and then we padded the rest of the string until it matched the original length of the string, which was 8, and therefore 4 stars were added. And the same here, and the same here. Awesome. That's really fantastic application of this method, I think. And now to finish, the last simple method that I want to show you is the repeat method. So repeat. And as the name says, this one simply allows us to repeat the same string multiple times. So let's say there is some bad weather at one airport. So when that happens, they usually have those long messages on the screen, like with the text repeating, which then keeps running and repeating all the time. So let's call this one message. So let's call it message 2. We already have message up there. So let's say bad weather, all departures delayed. Okay, and now we want to basically create a bigger string repeating this one here multiple times. So that's easy enough. We just take this string, call repeat, so repeat, and then the number of times we want to repeat it. Let's say 5. And there it is. So this is all the same long string. We should just add one space here at the end. And so you see, now you can see it even better, that it's all just one big string with the same message repeating over and over again. Or we can also simulate that due to the bad weather, there are now many planes waiting in line for takeoff. So let's create a fun function for that. So planes in line, and here the number of planes. So console.log, there are n planes in a line. And then here we can kind of show that graphically using an emoji like this. Let's say plane. I'm going to use this one. And so this here, in fact, counts as a string. So let's create a string with that and then repeat it. And we will repeat it as many times as there are planes waiting. So planes in line. Here we have 5 waiting. Then let's call it on another airport where there are just 3 planes waiting. And then 12. So indeed, now we have 5 planes, here 3, and here 12 planes. All right. Okay, cool. Now we didn't talk about all of these string methods that exist, but if you want to check them out, you can do so on MDN. And what I like to do is to simply search for one of the methods. Let's say string replace. And then that will take me to that page of replace, because then on the left side, at least when the window is a bit bigger, so then here we can see all of the different string methods that we can use. So we used split, slice, repeat, pad start, pad end. But as you can see, there are even more here. But actually we talked about all of the most important ones. Maybe one that you can check out is, let's see, concat maybe, or there should one be called reverse. Well, actually it is not here. But anyway, as you see, we talked about most of the most important string methods here. And so I hope you had fun with this, and I see you in the next video where we then have a challenge where you can then use all of this knowledge that you just gained here over the past 3 videos. So over the last couple of videos, we have learned how to work with strings and also did a couple of exercises and one challenge. But many people have actually asked me to create even more string exercises. And so in this lecture, we're going to solve basically one more challenge and do one more nice string exercise. So somewhere at the beginning of your starter files, you will have this flights string like this. And so our goal is basically to transform this huge mess here, which is this string, into this nicely formatted output, which contains all the information that is in this string here, but then put it in a way that is actually legible to people. So let's pretend, for example, that we get this string here from some kind of web API, and our goal in our application is then to display the data like this. So let's start by taking a look at our string here so that we can think about how to approach this problem. So we see that we have basically 4 lines of output here, right? And so if we take a look at the string, we can see that we have here this first part, then we have this plus sign, and so you see that here is another one and another one, and so essentially this plus sign acts as a separator between these 4 pieces of information, so these 4 flights. So this one here I showed you is the first one, then here we have the second one, the third one, and the fourth one. Okay, so let's start by dividing that up so that we can transform this one string into these 4 pieces. And for now, I will simply log the result of doing that to the console, just so we can get a first look at this. So remember that for that, we are going to use the split method. So flights.split, and then we specify by which character we want to split the string. So give it a save, and then you see that we get this array, and this array contains now these 4 pieces of information, so these 4 flights. Now, again, you see here that we have actually 1 line for each of the flights. So that means that we want to log to the console 1 line for each flight. And so we should probably loop over this array and then create a string like this in each of the iterations. And so we also learned how to do that in this section, right? So we can use the for of loop. So let's say that each of them is a flight. And here we can then directly use flights.split, which creates the array that we just saw. And so again, to start, let's just log each of the flights here to the console in each iteration, and we can then get rid of this. Oh, and here we are trying to access that flight variable, but of course it is flights. So this string here. And so now indeed we get our 4 strings here logged separately to the console. And now it's time to actually build each of these nicely formatted string out of this mess that we get here. So again, we can notice that we have an element which basically splits or separates different pieces of the information inside of this string. So here we see we have a delayed departure, and here we have this airport code, here another one, and then here the time of arrival, which is exactly what we have in the string. So here we have the late departure, the airport code for Faro, and then the airport code for Berlin. And so, therefore, let's extract that information from this string again. And so, again, I will start by splitting this variable, but this time using the semicolon separator. So exactly this. So you see it already worked. And now all we need to do is to get this data out of these arrays, then format each of these 4 pieces here a little bit, and then assemble each of them into the final string. So we can do this in many different ways, but what I'm going to do is to use destructuring to take these 4 pieces out of the array. So remember destructuring, we use the array syntax here, but to specify variables. So the first variable here, let's call it the type, because we can have departures and arrivals. So that's the type. The second one is the from. So you see here that the first airport code is the from, and the second is the to. So from FAO to TXL. So the third one is 2, and then the last one is the time. So 1125, which we will then transform here into 11H25 like this. All right. So now, of course, we don't have the output anymore. But anyway, let's now start creating our output string here. So I'm going to call that output. And of course, we're going to use a template literal. And I will start by simply put these 4 variables that we just created in here. And so then we can format each of them individually. So that's type, from, to, and then the time. And we can already put that inside parentheses just as we have it here. And then to finish, we will just log that nicely to the console. And so now indeed we have 4 strings right here. Okay, so let's now individually format each of these 4 pieces. And I'm going to start here with the time, which is the easiest one. So here we just want to replace the colon with an H. All right, that worked beautifully. And now let's go to the type. So you see that in the type, we always have these underscores, which of course we want to get rid of. So here it should just say delayed departure with a space instead of the underscore. And here in the arrival, we basically also want to get rid of the underscore. So essentially, we're just going to replace the underscore with an empty space. So here we can now actually use that ES2021 method that I mentioned before, but which didn't work back then. But now, as I'm recording this video, replace all actually already works in Google Chrome. And so here we can now use replace all. All right. So again, this is an ES2021 method, which is brand new in JavaScript and which allows us to replace all incidents of a certain string at once. And so again, we're going to replace the underscore with a space. Okay, that's nice. Now we see here that we have this empty space at the beginning of each string, but we're going to take care of that later because we will have to add some strings here, or actually some spaces anyway, in order to create this format here. So with this and all of these spaces here. All right, so don't worry about that for now. Instead, what we're going to do now is to add these red dots here. So these are actually emojis, and we will add this emoji whenever the departure or the arrival is delayed. So basically to symbol that there is a delay. So this applies to both departures and arrivals like this. All right, so basically we want to add this emoji whenever the type, so which is, remember, all of this, so this here, so whenever this starts with the string delayed, then we want to add this emoji here. So let's do that. And we actually have a nice and easy string method for that, which we already talked about, which is the starts with. So starts with, and so here we are asking if the string starts with delayed, so actually like this, and remember that this is going to return a Boolean. And so this is perfect to then use a conditional like the ternary operator to return something in case this is true. So in case it is true, here we want to add this emoji. So we can just come here and copy it, paste it here, and if not, then simply add nothing. All right. Well, that didn't really work. All it did was to add like another space here, which is this one here. But I think I know what the problem is, which And let me actually show this to you by logging here again the type. So we are looking if the string, so if the type string starts with delayed. But in fact, it does start with underscore delayed at this point, right? And so therefore, we need to add that here to our test as well. And then it works just like expected. Nice. So let's take away that log here, and let's actually take away that space. And so now we have a more evenly spaced text here. Great. And actually, we're almost done here. All we have to do is to now format these airport codes. Now, we have all of these numbers here and here as well, but they don't really serve any purpose here for formatting this string. So all we want is the 3 letters here, which any airport code is made of. So it's always just 3 letters, but the number afterwards, we don't care about it at all. So basically what we will do to this string and also this here is to take the first 3 letters and then convert them to uppercase. And then that's actually it. So let's do what I just said. So we use the slice method to take the first 3 elements. So from position 0 all the way to 3, where 3 is not included. So we're taking 0, 1, and 2. And then we can simply chain the to uppercase method onto that, and there we go. So that's fao now. And now we can copy the same thing from here to here. But let's actually not do that. But I will create a small refactor outside here. So basically create just a small function called getCode, which gets a string, and then from that string, it does this. So let's cut that, and that's it. So just a nice and simple arrow function just for this small use case. And notice how I defined this variable here outside of the loop, because otherwise this function here is going to be defined over and over again, which is not necessary. So now we can just wrap this into parentheses and pass it into getCode. And so that will then take this string, pass it into this function, which will then do the formatting that we wanted, and will return it. And let's do the same thing to the destination. And that's it. So we are almost done now. So a string is nicely formatted. It looks just, or at least almost like these ones here. Now the only thing that's different is that here they are basically all aligned to the right like this. So that we have these airport codes here and the times all in the same position, which makes these strings a lot easier to read. And do you remember how we can do that? So for that we can use the padStart method that I also introduced some time ago. So we can do that on the entire string, which ends right here, right? So the output string starts here and ends here. And we now want to apply the padStart method on the entire string. So we can chain that right here. We could also put it here like this, but this formatting should actually be a part of the string itself. And so let's actually add it right here. So let's try 50 here. And remember that by default, the default character that will pad the string is an empty space. So if we give this a save now, then you see that indeed everything is now actually aligned here. But 50 is apparently a bit too much. Let's try 20, which is not really enough. Let's try 40 here maybe, or 30. This has to be a little bit like trial and error until it looks nice. But 36 it is. So now everything is nicely aligned, and all these strings are now exactly 36 characters long, which is exactly what this pet start does, right? So it makes sure that the string has exactly this length, and if it doesn't, then it keeps adding the string, or so the character that we define here. So we could also do like this, and then it would add this character here, but we simply want a space, so we can just get rid of that, and then automatically it adds this empty space. Okay, and that's actually it. That solves the problem that we set out to solve in the beginning, and on the way we practiced many of these methods that I showed you before, and we also used the ES2021 method here, replace all, for the first time. So I hope that you found this exercise useful and that you're now even more comfortable working with strings on your own.